this time, please find your seat. Our session will begin soon.
Don't try to bring me down. It's time we get out this town. Rise up, 'cause I can't go on hoping this thing ain't working out. Rise up, 'cause I'm already growing, and this thing can't stop me now. We were so young, we couldn't help but love each other. But now I know nothing hurts deeper than a first love, a first love. And don't try to tell me now how you think I missed out. Don't try to bring me down. It's time we get out this town. Rise up, 'cause I can't go on hoping this thing ain't working out. Rise up, 'cause I'm already growing, and this thing can't stop me now. Rise up, 'cause I can't go on hoping this thing ain't working out. Rise up, 'cause I'm already growing, this thing can't stop me now.
Welcome. Thank you for joining. Our session will begin soon.
face like she's deja vu. She's the image of the fruit you cannot taste, forbidden and out of reach from another place. You don't know her name or how she got to here. All you know is that you know she's from a higher tier. You're reaching for her now. She felt to weigh you down and out. She's never coming down. There's never any doubt. She's up above. She's a beach. She's simply out of reach. She's up above. She's a beach. She's simply out of reach. She's up above. She's a beach. She's simply out of reach. She's up above. She's a beach. She's simply
Hi, everybody.
Good
Oh,
morning.
thank you. Holy cow, it is really early.
I can't believe you guys made it.
You all must be super excited to find out about how to make your app more successful with Firebase.
I am excited.
Yeah, or you're from Europe and are jet lagged and have been up for hours anyway, or East Coast. Show of hands, like jet lagged people, Europeans, East Coasters. All right, yeah,
Yay!
about half the audience.
Hopefully we'll wake you up.
Yes.
And live stream. Hello, Internet.
Hi,
Thank you
Internet.
for joining us. Hi, Mom. All right.
So this here's Jumana,
And this is Todd.
and we're going to talk about how to make your app more successful with Firebase.
All right. How about you get started with
I'll
that?
get started. You take a rest. We actually both kind of had to run here because we had to kind of get through the security line and get here in time. So you're going to relax and drink some water while I do the talking first. So as we all know, building a great app is nice, but it is only half the battle. So yes, we all love getting like nice review scores and thumbs up and nice comments from the people that use our apps. But it turns out our landlord usually does not accept those as payment. Even in San Francisco, you still often need to make money. And so if you're like a lot of developers, maybe like a typical game developer, you've got a business model that consists of like selling some in-app purchases and then maybe kind of crossing your fingers, hoping for the best, and maybe that's it. If you're feeling ambitious, you might be doing a couple of tests to help improve this. But this sometimes involves a fair amount of like one-off engineering work. This ends up being kind of hard to scale. Well, lucky for you and for this talk, this is one area where Firebase can help. So Firebase does help you reduce the time it takes to build your app in the first place with lots of great products like Cloud Functions and Cloud Firestore and Cloud Storage and other stuff that probably begins with cloud, because we like that. But we also provide you with a bunch of out-of-the-box solutions that can help you grow your user base, retain it, and monetize it. So let's talk about how we can move our monetization model from like, let's just try some stuff and hope something works, to something more sophisticated and data-driven. So Jumana, why don't you take it from here?
I will.
All right.
Thank you. So there's nothing quite wrong with hope. But as my fellow product manager over here, Jane, would tell you, hope but verify. So she walks in one day, and she wants to change the layout of the store. She thinks that if we change the layout of the store, we could make more money, say, in our game. Which brings out a lot of questions, like, how are we really going to do this? What if we decide that was a bad idea? Do we have to relaunch the app if this was a bad idea? How do we measure success? And just tactically, how is all of this going to work? And so we're going to walk throughout this talk with how Firebase really can help Jane and her team achieve this and other ideas they may have. So first off, let's go to Hope but Verify. So for Hope but Verify, the first thing you need to do is actually start looking at the data and looking at what's exactly happening inside your app. So that's where the Google Analytics for Firebase SDK can come in to help. Even if you feel totally jet-lagged and unmotivated, adding the SDK without anything else, no customization, just single line of code, integrate the SDK, gives you a ton of value and a lot of insights about what's going on inside your app. For example, we capture automatically all in-app purchases that happen inside the app. There's also a lot of information about user engagement. session time, and so on. Retention cohorts, and how long you're retaining users you're acquiring in certain weeks. Daily active users, and other demographic information. Here is such report. For example, in this report, you can see which of your in-app purchases are selling the best, and how much you're making off of them, and who is really buying them. And all of this, really, the SDK is free, and the reporting is free on it. And there's unlimited events, 500 events.
500 events.
And unlimited volume on these events. So you can take advantage of this right away. And if you're feeling a little bit more motivated, which you should, one line of code gets you a lot more of what's really happening inside of your app. So you can say, if you have a game, put when the round is over, or when a tutorial started, when a tutorial ended, when somebody joined the league, when somebody shared the app or the game with their friends, or really any such important event inside your app that gives you a sense that the user is making it through the user journey you're intending for them inside your app. And adding these events, like I said, is generally one line of code. And once you have that in, you can start asking a lot of more complicated questions, especially if you combine that with BigQuery, which Firebase gives you access to as well. So you can ask questions like, how easy is level 5, or how hard is level 5, and how many people are making it through the tutorial, and so on. Once you have those events in, you can actually go ahead and, from the Firebase console, label a few of them as conversion events. So when you label something as a conversion event, that just means this event is like super important. It's a huge milestone in the user journey with your app. So conversion events come into play throughout the Firebase platform, and we will see how later on. But they're important. They help you refine a whole bunch of targeting. For example, you can refine your ad campaigns so that whatever ad platform you're using, you're saying, get me more users who are more like this, or who are likely to complete one of these conversion events. So we'll talk about this a little bit more later, and stay tuned. Now to the second stage of getting Jane what she wants, which is actually making the change.
Yes, actually making some changes. So now that we can see what's happening in our app, well, OK, now we can start changing some things, see if they're having any kind of effect. And we're going to be using Firebase Remote Config as the primary driver of these changes. Now, if you haven't used Remote Config before, actually, show of hands, who has used Remote Config?
Okay.
All right, a few, mostly clustered in this area. So I'm going to talk to this part of the room, because you all know what's going on. If you've never used Remote Config before, you can kind of think of it like a key value store that lives in the cloud that your app can use to change like the look and feel and behavior of how it works without your needing to publish a new version of your app to the app or the Play Store. So the way it generally works is you're going to set up a bunch of values locally on your device. And then as time goes on, when you want to change one of these values, you can use that using Remote Config, which you will do in the cloud, either using the Firebase console or using the REST API that we just announced like a month or two ago. If you haven't tried the REST API, a lot of people are asking for it. It's now available, so you can make changes there. We got one fist pump. Thank you. Excited fist pumper. So basically, then when your user starts up their app the next time, Remote Config is going to download these values from the cloud and apply them on top of your default values. And so then when you ask Remote Config for the value associated with a certain key, you will either get the default value that you supplied originally or the new value that you supplied from the cloud.
Wait. I see the thought bubble over the audience that says, what about my user data?
Your user's data plan?
Yes.
Thank you for asking that completely spontaneous question. So what's nice about this setup is that you're only downloading the deltas, right? The values that have changed since the defaults that you supply are, originally locally within your app. And that means you can basically keep as many values as you want in Remote Config, like hundreds and hundreds and hundreds of values. And because you're only downloading the values that you want to change from the cloud, the actual amount of data that your user is downloading is still nice and small, and it doesn't end up being a big hit on their data plan or battery, which is nice. And so our recommendation is kind of look at any value you might want to change within your app, whether that's like the look and feel of your buttons, or the difficulty level of your game, or how or if you're displaying ads, or the way items are organized in your store, right? Everything that you've got in like one of these constant files somewhere, we all have one of these somewhere in our app, take a few hours to refactor this and get it to go through remote config. Once you've done that, you basically have the power to change anything in your app directly from the Firebase console, again, without your needing to publish a new version of your app to any of the various stores. So for instance, if we've gone ahead and parameterized our store layout as a variable that we are running through remote config, this is then something we can easily update through the Firebase console. Right? We add this parameter, publish it out to the world, and that lets us easily implement Jane's idea. And we're done. That was easy. Boy, we're done a lot sooner than I expected.
Yeah, I know.
That was great.
That was very cool.
Yeah, you want to get some coffee? I could totally go for some coffee
Totally.
right now.
Let's some coffee.
Oh, wait a minute. All right, Jane's got more ideas.
I'm going to let him handle Jane this time.
Ah, I thought we could get
Sorry.
out of here early. All right. This is what happens. You give a product manager a cookie, and they want a glass of wine to go with it. And also more.
An Excel sheet.
Yes, and also more ways to monetize. So it turns out now that we've added the ability to change our store layout, that has given Jane a bunch of other ideas that she wants to try. Well, now she's thinking, OK, it's great that we're changing our store layout to show the most expensive items first. But will that scare off like our new players, or players that haven't made a purchase? What if we only change our store layout for players who have purchased stuff in the past? So maybe we can kind of maximize our average purchase per user while also encouraging our new users to go in and try out something by just buying a little thing. So this is something we can actually do pretty easily with the systems we already have in place. We don't really need to do anything new here. Because, see, when you implement analytics, you have the ability to create audiences. And these are users who meet certain kind of arbitrary criteria within your app, like some combination of hitting certain events a number of times and being assigned a certain user property. And one audience that analytics will create automatically for you when you start it up is this purchaser's audience, which is basically anybody who has ever spent any money in your app. And one nice thing about remote config that I didn't tell you about earlier is that it contains a bunch of logic on the back end that lets you send different values to different users depending on their situation. So for instance, you can send different values to your Canadian users if you want to provide like a nice localized experience for them, or you want to test some version of your app in Canada before rolling it out to the rest of the world. And another thing you can do with remote config is send different values to different users depending on if they're in different analytics audiences, like this purchaser's audience we just talked about a slide ago. And so we can tell remote config, hey, you know what? Let's create a special condition for people based on whether or not they are in this purchaser's audience. And then we can change our store layout only for people that are within this group. And so we get to implement Jane's new monetization strategy.
She looks really happy about that.
She does look happy. Look at that smile.
Ecstatic.
She is ecstatic right now. That's
That launched 1,000 apps.
yeah, warms my heart. So while this makes her happy, it also kind of gets her thinking, well, it's great we're able to change our behavior for users who have purchased stuff in the past, but wouldn't it be nice if we could also change our store layout for maybe people who we think are about to spend money sometime in the near future? Well, gosh, that sounds great, but nobody can predict the future, can they, Jumana?
Well,
Product manager of Firebase Predictions.
I'll steal my thunder.
Oh, sorry.
The answer is an emphatic maybe, depending on how many users you have and how
Ooh.
many events you're logging inside of.
Maybe. That is exciting.
But it is a maybe if we can get some help from our robot friends. So predicting the future, as you may have guessed, machine learning is a big theme at I/O this year, and so is mindfulness. And here's a product that tries to combine both. So Firebase Predictions is a product that we launched in beta last October. And it's if you will, a batteries included predictive service. That means you don't really have to do anything in order to take advantage of it. You just have to be using the Firebase platform and logging your event. And we will do the machine learning on your behalf. So basically what we're trying to do here is use the app telemetry in order to discover user behavior. So for example, if you're sending us all of your Google Analytics through the Firebase SDK, we can start looking at some of the behavioral data of the users. So say, for example, your past spenders. So we'll take the past spenders, We'll build the TensorFlow model. If you don't know, TensorFlow is Google's library for building and maintaining machine learning models. So again, you don't have to know anything about that. We'll build it for you. We'll choose the parameters. We'll hyper-tune it on your behalf. And then we'll start learning about the patterns of behavior that exist in your app. The first two behaviors we learn are about who's going to pay and who's going to stay, so spenders and churners. So these are your past spenders. We look at their past behavior. And then we can look at your user group and then help you identify the group of users who is likely to spend in the future. So if you're going to spend time trying to monetize more of your app, this is the correct group of user to kind of like address potentially with more promotions or something like that, to incentivize them to do a little bit more spend. So you may be asking yourself,
What can I do with these groups once we create them?
there you go,
Yeah.
even without his first cup of coffee.
Yeah.
Right on the money. So yes, you can use it anywhere that Todd already showed us how to use it in remote configuration. So you can use it in remote configuration for targeting. You can use it in notifications, or you can use it in A/B experimentations. So basically, the idea here is to find the right groups of users so that we're not bombarding everyone with everything all the time. So just you're taking more targeted actions, and you're getting a lot more conversions in your app without kind of bombarding all your users with everything that's happening all the time. So how do you take advantage of this?
Do you need several years of graduate study in machine learning?
That would be actually pretty fun, and it is a lot of fun.
Yeah.
But no, you can do it without that. But I encourage you to do, because it's a really worthy topic of study. But you actually just have to click a single button, turn predictions on, and voila. By voila, I mean it takes about 2 weeks to create the first predictions, but after that, it updates every day, depending on your volume of users and data and how much you've instrumented. But voila, nonetheless, voila stands.
It's a long, drawn-out voila, but it's...
French word, voila.
Oh,
It's very poetic. Anyhow, so once we start analyzing the behavior of your users, it's then updated every day. So these predictions are updated based on actual user behavior. On a daily basis, your users may go from being predicted to spend to predicted to not spend, from being predicted to churn to being predicted to not churn. And you can start asking all these questions about groups of users in your app. If you went ahead and did instrument your app, and added conversion events, now you can start asking these questions about your conversion events and using the predictions to help your users go along the journey that you want them to have inside your app. So you can start asking who will share my app, or who will join a league, or who will reach level 5. Whatever event you logged as a conversion event, now you can start asking a prediction about it, like who is likely within the next week, say, to actually participate in this action, and only sort of like share this with your friends to people who are likely to engage in this. Like push people who are already behaviorally ready to take a certain event inside your app. And so Todd already defined the remote configuration for us. So to help Jane along, we're taking that store layout, we'll edit it, and now instead of having it show up only for the audience spenders or purchasers, previous purchasers, now we're going to give it to people who are predicted to spend, and then we'll publish that condition, and we are good to go. And that makes Jane super happy. Look at that ecstatic face. Ooh. So, but now she wants to try a lot more stuff, and she's worried it's going to break this initial success, so maybe we can help out a little bit more?
Yeah, well, I think the trick is she needs to convince members of the team that her plan actually was a good idea. Like, the trick is, how do we know that all these changes we've made have actually worked? Like, even if we saw an uptick in spending while we were changing the store layout, you know, how do we know that wasn't due to, like, random chance, or another promotion that we happen to be running at the time, or some other change that we made elsewhere within our app? I mean, how do we know if we hadn't made this change, we would have gotten even more revenue, right? It's something that we don't really know. And so instead of relying on like hunches or confirmation bias, we can prove it with data. And that's what Firebase A/B testing is for. So this is our tool to help you make sure that all the decisions you make in your product are backed up by actual data and not just kind of, you know, lucky guesses or things that you want to be true. So the process of creating an A/B test is you're basically going to define an experiment. And there are 3 steps involved whenever you want to create an experiment. The first thing you're going to do is you're going to define the group of users who you want to place into this experiment, right? Maybe it's like 5% of your population, or maybe it's your users who speak Korean, or maybe it's your users who you've marked as like super competitive players in analytics, and you want to try some new multiplayer feature on them. The second step in creating your A/B test is telling A/B testing how you're going to create different experiences for each variant that you've put into this experiment. And generally speaking, you're going to do this by delivering different remote config values to each of these different variants. And I think that's important to note because, as we mentioned several slides earlier, you can basically take any constant in your app and wire it up to go through remote config, which basically means if you can define it in a variable, you can probably A/B test it. And so you get a fair amount of flexibility with what you can do with your A/B tests if you wire up your app to go through remote config for all of its constants that you're setting. So there's a lot of flexibility here. The final step is telling A/B testing what your primary goal here is of your experiment, right? Is it to improve retention? Is it to increase your in-app purchase revenue? Is it to increase the number of people who have made it through your onboarding flow? Essentially, if you can measure it in analytics, you can define it as a goal in your A/B test. And this is useful not just for helping to create your conclusions, but A/B testing will also use this to refine your experiment along the way to make sure that it's finding you exactly the variant that gets the exact maximum value in the thing you're interested in as your main goal of your experiment, using some fancy Bayesian statistics that I don't really understand. And then basically, you're going to kind of relax, right? Hang out with your friends in a hammock inside a giant glass dome, apparently. They're going to run out of oxygen.
Not as fast as if they were not using Firebase. They'd be panicking.
I guess
At least now they're relaxed.
Yeah, they're relaxed, so they'll run out of oxygen slower. And let Firebase do the rest of the work for you. So let's try and prove Jane's original hypothesis with data using an A/B test. And this is what it would look like going through the Firebase console. So the first step, we're defining who we're going to put into our experiment. So we're going to say, all right, our target audience is going to be users who are predicted to spend money within our app. And maybe we'll run our experiment on like 30% of those users. Then we're going to define a whole bunch of different store layouts here by providing different values to the store layout key that we're running through remote config. So here we have 3 variants in addition to our control. I think we allow you up to 7 variants plus a control group. So it's not just A/B tests, it's A, B, C, D, E, F tests. And then we're telling Firebase that we want our goal here to be maximizing our in-app purchase revenue. Note that in addition to our primary goal, you can define a number of secondary goals in all of your experiments. And this is useful just for kind of keeping track of the overall health of your app as you're running one of these A/B tests. Like if we make a change that really boosts our revenue, but it turns out we're so aggressive in pushing these, pushing the store that a lot of our users kind of get frustrated and leave and stop using our app, we would want to know that. And so that's sort of the point of having these secondary goals in all your A/B tests is it gives you a way of kind of sanity checking your experiment and making sure your app is still overall healthy while you're in pursuit of whatever your primary goal is. And then basically check back in a couple weeks and see what happens. So this is sort of what a sample report might look like. We probably don't have time to go into full detail on all the charts and graphs that you get. But I think the big important takeaway is this sort of giant line of text up here in plain English that tells us basically out of all the options that we tried, showing the most expensive items first was, in fact, the proper way to maximize our in-app purchase revenue, at least among our users who were predicted to spend money. And by the way, this is not a completely hypothetical example, is it, Jumana?
No, it's not.
Oh.
You guessed right.
What a twist.
You were playing along. So we had our friends at Rockbite Games actually do that same thing. If you see them walking around, they're really awesome. Say hello and give them high fives. They're a small indie game shop in Armenia, actually. And they tried actually changing their store in A/B testing multiple times. And a lot of these experiments end up being actually inconclusive. They couldn't find out a good layout for the store that maximizes revenue. But then they tried to change the layout of the store based on the predictions. I was skeptical, but it totally worked. So for users who were predicted to spend, they will put rare chests and items in the game that are important on top. And for users who are predicted to not spend, as you can see in the second one, they will put these crystal packages and a special one that's like a high-value one for those who are predicted to not spend, to encourage them to stay more in the game. So the crystals are some sort of an in-game virtual currency. And in both situations, they increased their revenue by about 25% for the predicted segment, which is pretty good ROI for the investment we're talking about here.
I'd like a 25% increase in my revenue.
Don't we all?
Yeah.
So that worked out actually really, really great for them. So all these items are available for everyone. It's just the layout of the store was done differently. So it was a worthwhile experiment for them. And Jane feels totally vindicated. And now that encourages a whole bunch of people in the team to come up with new ideas. So this is Jared. Jared was just promoted to CEO. He's very eager, as you can tell. He's trying to prove himself. That's OK. He's very sincere. And he's like, OK, we want to experiment with whole new ways to extend our runway, make a little more money in the app. And we want to be open to new experiences. And with A/B testing and the Firebase platform, I think we can help that team along with some of more experimentation. So Jared now wants to start showing ads. Now, this can be a scary step for a lot of apps, because you don't want to compromise sometimes the user experience with ads that could be intrusive or at the wrong time or any of that. So that's why A/B testing here can really help us. And then predictions can also help us. So if you have not used AdMob before, you can go ahead and install the SDK from the Firebase console. And linking the SDK has a lot of advantages. One is that in the Firebase console, you can get all sorts of, and in the AdMob console, I guess, all sorts of cool reports about which placements of your ads is getting what kind of exposure, what kind of clicks, and which ones are generating money and not generating money. But most importantly, as we're talking about experimentation, A/B testing, and that stuff, is that we actually predefined goals for estimated AdMob revenue and total revenue. So that means when you're running an A/B test that involves ads, you can make sure as part of your goal that not only you're getting AdMob revenue maximized, but you're also your total revenue maximized, which means you're not cannibalizing your in-app purchases. You can even set all three of them as goals. So you can keep a closer eye on what's happening throughout your app and all your monetization streams. So let's take that show rewarded ads. So for example, again, back to our game example, at the end of a level, if a user, for example, is predicted to not spend, you will show a rewarded video or something like this. So we'll go ahead and set the experiment for users predicted not to spend. We're going to try showing rewarded ads. And the goal here is to maximize our total revenue. Again, we don't want to maximize just the ads revenue, because we want to make sure that in-app purchases are not hurt. So that sounds great. Jared is a lot more optimistic now, and he wants to try perhaps showing interstitials at some other point in the game. All right, well, showing interstitials sounds a little more scary, but we can do it with an A/B test and see how it does. So for users predicted not to spend, let's say we've already defined a remote configuration that controls how often these are being shown. We can not show them at all, show them more often or less often. User predicted not to spend. But in our goal this time, in addition to keeping an eye on the money, we keep our eye on retention. So we add goals for daily user engagement, for retention, to make sure that we're not compromising the overall user experience, which is something you really can even focus on with Firebase.
Absolutely.
Right?
Yes. Yes, these things here. And by the way, A/B testing isn't just about making money. I know that's kind of the whole theme of the presentation. But like, your game design team, for instance, could use A/B testing to make sure your game is, like fun. Which turns out fun games usually make more money too. That's sometimes helpful. So we can try like tweaking the difficulty of a game to see what our users actually like playing more. So we can say, hey, you know what? Let's take 10% of our global audience and try tweaking the difficulty levels. Try changing a few of the variables in sort of our base game setup that makes it either harder or easier for some of our players. And then see which one kind of increases our goal of daily user engagement, right? Do our players appreciate the challenge of a more complicated game? Does that sort of make them feel challenged? Do they get more involved? Or does increasing the difficulty level drive them away? They get frustrated, they give up, and actually they wanted an easier game where they win more often because that makes them feel better, right? As someone who is a former game designer, I would have loved to have been able to run these tests. I often just kind of in the past had to guess and hope I got it right, and spoiler alert, very often I did not. So being able to run stuff like this directly from the Firebase console would have been fantastic. So while all of this is nice and helpful, we don't just want to kind of sit back and hope that our users spend money. Part of having an ongoing successful business is staying in communication with all of your customers or your users. It's a dialogue, not just a monologue. Sometimes that can sort of be for just a nice feel-good moment, make sure your users know that you care about them. And sometimes it's about driving players to perform a certain desired action, right? Maybe it's getting them back into your app if they haven't tried it in a while, or like trying out a new feature that you launched that you think they're going to be excited about, or maybe making an in-app purchase. And now one way we can do this is through notifications, which have very high visibility, as we all know. But they also do run the risk of annoying your user if you send them too frequently or too indiscriminately, and then they go and turn notifications off, which would be sad. So you kind of have to make sure that you are sending the right message to the right people. So when Sarah from Promotions comes by and tells us, hey, we're having a big I/O sale this week, we should tell everybody all about it, that sounds nice, but maybe instead of telling everybody, we should make sure we're targeting the right people, and we should probably make sure that we're delivering the right message. So we've had Firebase Cloud Messaging available for a while to help with this. And for a while, I think we've been saying, hey, one of the great things about cloud messaging is you can send the same message to all of your users on Android or iOS devices, with one call to the same service, which is true, and it's still nice, and it's helpful. But I think what often gets overlooked is cloud messaging also lets you take advantage of all of the targeting and experimentation features that we've been talking about today. So for example, if you want to announce a new sale to your players, you could send it to all of them, or you could send a notification only to those players who Firebase Predictions thinks are about to spend money or are likely to spend money in your app. And if you're not sure which version of your message is going to be most effective, well, guess what? You can A/B test it, right? With Firebase A/B testing, you can try a message on a small segment of your population, say like 5% of your English-speaking users, because our notification is in English. And we'll try 2 different versions of our message, see which one is most effective, and tell A/B testing, hey, our primary goal here is to get them into our in-app store to at least start thinking about making a purchase, maybe something like that. And then we can see which version of our message was most effective in driving players towards that goal. Then once we've determined a winner, we can then go and roll it out to the rest of our users who weren't included in the original experiment. So you can kind of make sure that your marketing campaigns actually move the needle on the metrics that you care about before you roll them out widely to everyone, which is nice.
Yeah, it is super nice. So whether it's worth pointing out here that everything we've talked about here today, whether it's remote configuration so you can give your Canadian users a little extra love.
Yes, or running an A/B test to improve your in-app purchase revenue.
Or starting to generate predictions to figure out who's going to hit a certain conversion event that you care about.
Yes, or running a cloud messaging campaign to deliver just the right message to just the right users and tell them about your big sale.
Any and all of this really can be run by anybody in your team, your game designers, your product managers, your growth engineers, from the Firebase console. So your engineering team has to only...
Go ahead, you take the control.
There you go. I'll
No, you can have it.
Your engineering team has only a one-time setup hit to set up, for example, the Google Analytics, the remote configurations, the notifications, SDKs. But then your growth team can be running experiments for a couple of months and staying productive and trying to maximize your revenue and your retention inside your app, while the rest of the engineering team is working on other things. So you can have everybody on your team being super productive. And your monetization strategy can go from just hope to really nuanced hope and a lot of verification and iteration and a lot of A/B testing that leads you to the best outcome. Not everything's going to work out. Not every experiment is going to be the best thing you've done for your app. But without trying things out, you're not going to get to the best version of your app.
That's right. And you get to go from this to this, paying your landlord with actual money. And are those
Bitcoins. Bitcoin.
Maybe it's Bitcoin. It's the Bay Area. You can pay your landlord in Bitcoin now. It's a
You
thing we
totally
do.
can.
I'm sure somewhere in San Francisco there's a landlord that is accepting Bitcoin. Guarantee. So if you want to find out more about some of the stuff we talked about today, there's a much more detailed and technical talk on cloud messaging, which is happening later on today at 4:30. And if you want to find out more about analytics and some of the new things that are happening this year with analytics, I think it's happening right after the cloud messaging talk, so you get an afternoon full of Firebase-y things. And if you have questions and want to talk to us, you can meet us in the sandbox. That's the big dome thing that is not box-shaped and doesn't have any sand in it, but we're calling them a sandbox. But it's the dome. It's the Flutter Firebase dome.
Yes.
And hey, if you like this presentation, be sure to let the I/O team know by providing feedback on the website here. And if you didn't like this presentation, my name was Colt McCandless, and I was from the Chromecast team.
And I wasn't here.
Right, she wasn't even here.
Don't even rate.
So with that, thank you very much.
Good morning and welcome back to Talks for some play.
into the site. So again, here I'm showing it to you on the first page, the first time somebody opens your app. But the magic of this is that you can take this and place it wherever it makes most sense in your flow. It doesn't have to be at the beginning when they first arrive. It can be wherever they have most intent to create an account. So it is one tap, contextual account creation, where it makes most sense for you. The second thing, well, actually, just briefly, an example from somebody who has integrated this was Redfin, who had an 80% increase in the number of new users once they introduced this one-tap, seamless, contextual account creation. Now, the second thing that annoys me is security. If you look at the passwords that people use online these days, not only are they weak, they're often reused, and they're susceptible to phishing. Now, we're going to deep dive into the security behind this, like I mentioned, so I'm not going to go into it too much here. Suffice to say that Google Identity can help with this, and it's the same, again, not to give away the punchline, but it's the same security that we use for Google accounts on google.com. The third thing that can annoy me about sign-in and account creation is quality. Like, you spend a lot of time and money getting people to your site or app, and maybe they convert, maybe they change into a user, but how many of your accounts look like this? Maybe this is an extreme example, but even if a real person with a real email address comes to your site, they may not be as engaged as you'd like them to be. And we hear time and time again from people who use Google Identity that Google users are not only more engaged on their platform, but they create less spam. So at this point, you might be thinking, OK, great, this sounds great. I've got some, I can see some UX improvements I'd like to maybe see a point for in my site. Comes with great security, and you're telling me it helps keep the quality of the accounts high. But I'm building a cool thing. I don't have time for this. To which I would say that we have worked really hard to get everything you've just seen and more available to you in just a few lines of code. Again, we'll take you through that in the second half of this. So just a really quick recap. Sign in and account creation moments can be some of the most valuable for your account, for your sites, but they're often the most frictionful. Why don't we replace that with one-tap account creation and automatic sign-in? Security is in the news a lot lately. Feel free to use Google's. You spend a lot of time and money getting people to your site, so give yourself an advantage and get engaged, active users. And lastly, do away with all of the maintenance for these screens for just one or a few lines of code that you implement once. So these are just a few of the things that Google Identity can help you with. That's all I'm going to talk you through today. But I'd like to invite 3 people up on stage who are going to talk you through how you can get this yourself, some other examples of places that this has worked, and also how it works. I'd like to invite Luke, Naveen, and Stephen up on stage.
Thank you, Trifan. My name is Naveen Agarwal. I'm the Eng lead at Google's Federated Identity team. And I've been in this space from the beginning when you couldn't use all this magic. And here is Luke, who is a new product manager, and Stephen, who's been in the space for a long time. So Luke, you were telling me that you're not convinced about all this magic.
Yeah, that's right, Naveen. Hi, I'm Luke. I'm new here, and I'm still figuring all this out. So one of the things I'm really curious when I first heard about this whole federated identity thing was what the user experience is like. How does this magic really work?
So I think let's start from the basic. Lots of people say, what's this magic within there? You actually use all these identity providers every day. If you have any ID card in your pocket, that means you use an identity provider, a driver's license, your employee ID, or a passport. And what happens is they carry some information about you, and you go to a place where they want to verify some information. What do? You take out the ID card, which they accept. You show it to them. They verify that it has the right attributes. It's the right ID card. You haven't tampered with it. And then they let you in. And what happens in the online world nowadays, the state is pretty different. You go to a brand new site. They say, hey, we need to create a new ID card for you. And then we are going to verify who you are. And look at what it would look like in a real world. So you go to a bar. They say, wait, you need to create a new ID card before we let you in. What would it look like? You would be carrying a stack of ID cards on a daily basis, probably thousands. And the burden on each and every shop would be that they have to set up a system to create ID cards for everybody who walks in. If they forgot the ID card, it's a huge cost. But that's what everybody does right now on the online when they create their own authentication system. They say, no, you sign up for my site and remember a password. And that's essentially carrying a separate ID card for each of the site. And if you just replaced it with a very basic identity provider, you get a token from Google, and then they just accept it. And it's that simple. And the experience is fairly straightforward. You go to a site. You see one of the identity provider they accept. In this case, if you click on Login with Google, you go to your identity provider. They generate a card for the ID you want and essentially send it back through the magic, which we'll talk more about, and you are in. And it's much more convenient for the user and for everybody. And what happens inside the ID card, many people wonder, we have created what we call an ID token. And it's very similar to your ID card which you carry. It has some information about you and some cryptographic information for them to verify that it is authentic. And essentially, this is the ID card which the identity provider generates. In a sense, it makes it so much easier. You're using the identity which you already have in the digital world. Does that help?
Thanks, Naveen. That gives me a really good overview, but I'm still really curious what it's like for our users going through this. I know when I come to the sign-in screen, there's all these buttons, and I'm not sure which one to click, or what happens if I clicked one last time and I try and click a different one, or if I already have a password on the account. I'll probably, like most people, just end up hitting forgot password and going through the email reset flow, because that way I really know that I'm getting back into the right account. Stephen, I know you spend a lot of time thinking about what our user experience should look like. Is there a better way than this?
Well, you're completely right, Luke, that this user experience confusion is one of the top reasons why sites, apps, and end users are still using username and passwords today. And we've thought a lot about this. I'm really excited to talk about the innovations we're making in this space. We're thinking about new ways to get users signed in and signed up. What I'd like to focus on today is an experience we call a one-tap account creation. Now, this is a new way for end users of Google's identity systems to share their basic information with a site or an app that they're using with a single click. This can be shown in line on the page without the user even having to navigate to a full login screen or find the Google Sign In button. Once the user's tapped, this information is conveyed to the site or the app that they're using, and they're able to log into an existing account or help create a new one. To really illustrate this, what we're going to do is switch over to a demo and show you this in real life. OK, so what I've got here is a version of Chrome running in the mobile emulation mode. So you can see we're emulating an iPhone device. So this works across all platforms, including iOS. And I have a user signed in here. Her name is Elisa. Now, imagine that Elisa is preparing for a trip and wants to visit that site that she heard about called Hipmunk. So Hipmunk has this really cool user interface. And imagine, as she loads up the Hipmunk site, she'd like to identify herself to keep track of the travel that she's planning across devices. Now, that UI that I just mentioned shows up at the bottom here. Elisa is able to say that it's OK for this site to know who she is without having to go and find the login screen, figure out sign in, sign up, or determine which button she needs to press or which one she pressed last time. So let's try it out. With one click, we see that Elisa's account is active here on Hipmunk. And this is a live site. You can actually go and try it out yourself on your phone to see how it works. Let's go back to the slides. Now, how does this perform? Well, Hipmunk has actually come back to us and told us that this has dramatically increased the rate at which users are creating accounts with their service, and in turn, unlocking this opportunity to personalize their experience across devices. But it's not just here on the mobile web. We've had this opportunity to streamline and assist in account creation on Android for some time. So if you've been to our talks in the past, you might have seen some of the stats and numbers like this. By incorporating a one-tap identity experience, creating an account with just a single gesture, apps like Hotel Tonight have been able to improve their book out and conversion rates by things like 20 to 30%. That's pretty phenomenal for just a simple UX change, an improvement to the user's experience. We appreciate, of course, that it's not just about acquiring these new users who might be visiting for the first time. You have a lot of existing users. And it would be really a shame if all of those existing users had to identify themselves again and again across devices. After all, today people are using multiple phones, they're using tablets, and their desktop computer. And so what we offer here is the ability for people who have used a site or an app before, coming back to that same service across platforms, to be signed in without having to find the login screen. So let's take a look at an example of how that works. We'll switch back to the demo device. Now, to simulate a new device, what I'm going to do is actually switch over to an incognito tab. Now, you'll notice that in this incognito tab, we're in the full desktop version. So imagine this is Elisa coming back on her desktop machine, where she'd like to perhaps complete a booking that she was searching for from mobile earlier. As you can see, we have a link to the Hipmunk site. And what I'd like to do here is draw your attention to the top right, that as Imagine Elisa comes back on the desktop site, you'll see that her information is being retrieved by the web property and used to sign her in without having to navigate or even remember to go through a login flow. At this point, you can see that things like her previous search history are immediately available right across devices. So it's really this opportunity to have people come back to your site, not have to repopulate their shopping cart or redo all of their searches. They can continue where they left off with a shopping cart ready. So let's switch back to the slides and see how this one performs. So for Hipmug, it's also been equally impressive. The proportion of users who are using their site in a signed-in state and getting that personalized experience has gone way up. We have other numbers from folks like AliExpress really even saying that their conversion rates go up for these users who are signed in automatically. And to call out one more stat that we've seen from Android over the years, we've had big apps like Netflix using an automatic sign-in experience with data saved in their Google account, whether that's the Google account itself or things like saved passwords, and a result, seeing a dramatic reduction in the support and inquiry volumes. So of course, people who are signed in automatically don't have to call up a help desk to ask for information about their subscription or get back into their account if they get stuck. So if you put all these pieces together, I think we really are opening the door for a much better user experience across the web and apps. There's this one-tap sharing of identity that streamlines the experience to say who you are. There's an automatic sign-in for people who are coming back and want to stay signed in. You don't even have to go to the login screen anymore. And finally, it's the opportunity to unlock this personalized experience that continues across devices. I'll add one more thing here, that is that we still have the traditional button-based flows. That's the baseline that you'll have to implement across all platforms to handle edge cases like when the user's not signed in. But really the hope is that these technologies can optimize and improve the common cases for users who are visiting your site or app so that they never even have to see the login screen at all. And hopefully that will address a lot of those problems and questions that you brought up, Luke.
Thanks, Stephen. That honestly looks like a far better future than what I was seeing on that complicated button-based screen. But at the same time, I think a lot of people still have questions when it comes to using an identity provider about data sharing. When you traditionally go in through an identity provider, you have this consent moment where it's unclear, you know, will your friends get spam? Will they be able to send emails to your contacts? It's kind of scary and confusing. It's a, you know, when I sign up with an email and a password, I know that the site only knows my email. Isn't that a lot safer?
Yeah, that's an important topic these days, Luke. And so let's go back to that one-tap UI that we saw earlier. The thing I'd like to emphasize here is that it's a very limited set of information that's being shared with the site or the app that the user is interacting with. It's only exactly what's shown: their name, their picture, and their verified email address. Now, this is the same, essentially, as if the user typed in this information manually, but it doesn't have any of the problems of typos or mistakes, and it didn't require the work of the user having to manually verify that they own an email address by opening up their mail app and clicking on a link. The developer knows that their actual account, especially in the case of Gmail addresses, is active on this device and they own it. So what we've done here is really thought about separating out the basic information that's shared to say who you are in a login flow from requests for additional data, as we saw from the social sign-in days that Luke just pointed out. We do appreciate, though, that there are a lot of apps and services out there that do need and depend on this additional data. So for example, you can imagine an experience where after you've booked a flight or some travel plans, you need to synchronize this with your calendar. And it would be great if you could have this on an ongoing basis so you didn't have to manually keep your calendar up to date. In an example like this, a developer can still ask for that type of access, but it comes at a point where the user best understands why and how this data will be used. So it can be asked for contextually, just like you've seen on Android and iOS, where things like access for contacts or photos can be presented at the right time when people understand why they're needed. And when you do go through the experience as an end user, you can see that we're doing a lot here to make it really clear who you're interacting with, what data will be shared, and how you might see the terms and conditions the data will be used under, or even revoke or control access in the future. If you put all these pieces together, I think we're really trying to improve the ecosystem here. For a long time, we've had an app review process, and we're expanding that to verify who these apps are, what data they're using, and making sure that we have contact information and the ability to shut them down if things go wrong. We'll be expanding that to things like our one-tap sign-up to ensure that these powerful APIs and services are only used by the developers who have good intentions. The last big concern and question that comes up in this category about data is users' control. Both as a developer and as an end user, people wonder, if I use these Google identity technologies, am I becoming dependent on Google? Can the data that I provide to these services only be accessed by using Google services, Google identity APIs? The answer here is no. This information is conveyed to the developer. It's, as I described earlier, a shortcut, helping to pass this information over to a developer and bootstrap the experience. But at the end of the day, you're still in control as an end user and a developer. You can offer other mechanisms to log in. As we've discussed, you have the user's email address. You could send them an email with a recovery link or another way to log in. You could even accept other identity providers, perhaps having things like a phone number where you can send a recovery SMS, or even accept an entirely different identity provider to log into those existing accounts. They're still users in the developer's database and under their control. So I hope that if you put all of these pieces together, Luke, you'll have a better understanding of what we're doing to make it streamlined and clear to the user that when they share only identity information, it's just that limited piece of information that's being conveyed. On top of that, when additional data is requested, it's done in a process where things are vetted, it's clearer, and the user has better control. And finally, users can still log in at the end of the day with other mechanisms. There's no need for them to be dependent on Google. I hope that addresses some of your concerns.
Thanks, Stephen. I love how transparent it is. It's this what you see is what you get model that makes it really clear to me what I'm giving over to the third party. But I think something that goes hand in hand with privacy is security. There's this protocol going back and forth between the site and Google, and when I sign up for an account, I can create a really big password that'll really protect me. Naveen, I know your team spends a lot of time thinking about security. Can you explain why this is safer than my password?
Yeah, security is my favorite topic. Actually, this question we get asked quite often. Is this less secure? Is it going to make my account system less secure? In order to understand, just think about every site has a forgot password flow. What happens when user click on a forgot password? You send an email. The user then goes, signs into their email account, and then find the email, click on a link, and they get back into your account. Now, if you do click Sign in with Google button, what happens? You still go back, sign into your Google account. Google generates a cryptographic token, says, yes, this user owns this email address, and then you accept that, and you get back into the account. The difference is they are pretty equal from a security perspective. I would argue there are some flaws in the forgot password case where somebody could have forwarded that email to somebody else, and people can get back into your account. In this Sign with Google, you know that they actually own the email address. But this is just the security equivalence, but there is much more to the account security. How many engineers on your site are working on securing the account system? Think about that part. On the Google side, we actually have hundreds of engineers working on just protecting Google accounts. And for every login attempt, we go through a risk-based analysis based on many of the signals, traditional signals, IP addresses, location, but a lot of them which you don't see, trying to understand whether there is a bot who is trying to sign in based on the cursor movements and so on. And based on that, we figure out whether the risk of that attempt, is it low or high? And if it's basically a risky attempt, we would ask the user to verify through secondary channels. And in cases the user got hijacked, they got phished, we try to reach out to the user in different ways. Even if the hacker had a right password to the account and we think the risk is high, we will not let generally the user or the hacker in and keep the bad guys out. In those cases, you would basically, we are protecting a lot of accounts, and we are spending a lot of time and energy on doing it. But that's just right now. The bigger part is continued investment. We were the first one to launch two-factor auth for a consumer site, and that is still phishable, even though you have a SMS recovery. And we recently launched what we call advanced protection, if you go search for it, which is based on a security key. If your account needs much higher level of protection, that's non-phishable, because you cannot give away a code to the third-party site. We are also working with internet standards and other companies to protect your other accounts on other sites. And in the future, we want to share some data about the account so you can actually use it to make better security decisions during the purchases and so on. And the last is, as the new surfaces become available, like Assistant, we are making it easier for people to sign in using their Google account. So by using that, you are actually making Google Identity, the security of Google Identity is closer to what you will get the security of your account system. So sophisticated security, we are doing a lot to prevent hijacking, and then, again, the new advanced feature. Does that make you feel better, Luke?
That definitely makes me feel a lot safer as a user, that I can rely on all of these security measures Google's working on. But what about for the developers? There's all these spam and robo accounts out there, a lot of fraudulent actors trying to take advantage of services. How do I know that taking sign-in with Google doesn't create just another route for spammers to get in?
That's actually a good question. And this is something most of the people don't think about when they create their account system. What happens is, if I am actually a hacker, I can create my mail server and create probably millions of hacking accounts on your site very easily. Google actually does a lot of work to prevent creating mass accounts. And what that happens is, if you just use the Google Identity on your site, you are going to get a lot of those benefits. We were talking to one of the large banks just recently, and I asked them to separate out their accounts based on the Gmail addresses and non-Gmail addresses. And they were surprised. They saw 8 times less fraudulent activity based on the Gmail addresses than the non-Gmail addresses. And it's because all the security we are adding on the Gmail accounts, which is less spammy, and then not letting those accounts get hijacked. And not just keeping them secure, we find that these users you are acquiring through the Google sign-in are generally real users, and they are more engaged. So we talked about the Redfin having an 80% increase in the sign-up. More than that, we saw more than 40% of the users came back 5 times in the next few weeks. And that is much, much better stats than you can find within your own database. So you are not just using Google Identity to keep the bad guys out, but you are also acquiring much, much better users. And most of the users who have an Android phone, they have a Google account. So does that make things better?
Honestly, that sounds really great as sort of a side benefit of using Google Identity. But everything that you guys have talked about, so complex. There's all these security features. There's all that slick UI on different properties. How complicated? It must be really difficult for everyone in the audience to build this into their site. I know you work on this, Stephen. Do you know?
Yeah, so over the years, I've talked to literally hundreds of different developers about integrations like this. And when it comes down to it, there's 2 major pieces to be aware of. There's the front-end work to add UI to your app or your site or whatever else you're building, maybe an action. And then there's some work on the server side to take that information from the app or the site, look up the user, and provide that information to the user to personalize their experience. So let's dive a little bit into this. On the front-end side of things, you end up having to show the user either a traditional Google sign-in button, or as we've discussed today, try to optimize that with some of the one-tap or automatic sign-in UI. The first time, the user will give their consent to share this information. And at that point, Google is able to provide you, the app developer, a token representing this user, the digital passport that we've been talking about. Afterwards, there's the back-end work, and we'll dive into that in a second. So to illustrate how this front-end work works, let's actually switch over to a demo. OK, so I'm back on my machine here. And what I'll do is I'll take that code that we just saw on the previous slide, and this is the API calls that you're going to need to incorporate to add a one-tap UI to your site or app. So let's suppose you already have a Google sign-in button, and you really want to optimize this experience by turning it into the one-click UI. So what we're going to do here is we're going to take this little snippet of code and actually show it running on a real site. So there's a few parameters to this API call, asking to show the Google accounts and requesting a token. As a developer, I mentioned that there's a registration process that you have to go through to get access to these APIs. And what I'm doing here is showing the configuration for a real site. This is actually one from B&H Video. They might even be here at I/O today. And we certainly talked to them in the past. They have their traditional Google sign-in button, but they haven't included the one-tap UI. So I'll show them how easy it is to add the one-tap experience to their existing site. Now, B&H Photo Video has this really cool store in New York where they have all kinds of electronic gadgets. They even gave me a tour the last time I was there. And if you can't make it in person, you can definitely check out their app or their site. And wouldn't it be so much better experience if visiting for the very first time or coming back across devices, when you try to see the information in your cart, instead of seeing this little tumbleweed go through the empty cart because it doesn't know who I am, there was an easy way for the user to get signed in, signed up, or perhaps, as you see further down the page, subscribe for a newsletter. This really feels like the perfect opportunity to show that one-tap UI that we've been talking about today. So to demo how easy this is, what we're going to do is load a script onto the page that makes this library available. At this point, I'm just going to paste in the code from the slide and run it here. Now you see that in line on the page, this UI has appeared. As you, the developer, the key thing for you to think about is where and when to show this information to the user. What's the right time to ask somebody to sign up? As you see, it's really easy to add. The key thing to think about is showing it at the right time so that people want to click. Now what I'll do here, again, I have Elisa's account active. I'll click in through, and you'll see that the promise resolves. I get some information back about who she is, and it includes this thing we've been talking about today, the identity token. Now it's a big long string here, and that's because it's base 64 encoded. So what we're going to do is go back to the slides and talk a little bit more about what you do with this information and how B&H could actually take this and sign the user into perhaps their existing account. Before we get there, let's just finish up a few points here on the front-end side of things. So as I discussed, you need to register and create a client ID for your application, so agree to things like the terms of service. And then, not only do you need to show the UI at the right point, you probably want to check if those existing users already have an account. So perhaps before you even show the one-tap UI on page load, you'll probably want to call a corresponding API to sign in existing users. That's the retrieve method here. Now, we've talked a little bit about this in the past, that these similar APIs are available for Android. And since we're a bit short on time today, I'm just going to skip over it here, but go to developers.google.com/identity to see how to do similar things in your native apps on Android. One-tap email selection, including phone numbers, and automatic sign-in. All right, so what do we need to do with this information once we've got it? We have this token representing the user. Well, we need to send it up to the app developer server, validate the information in the token, and then apply some business logic. So things like determining whether this is an existing user or helping a user create a new account. So for that, let's take a closer look at the token. Now, I took the token here and decoded it so you can see the contents. It's a JSON web token, so a JSON dictionary that contains some information about the user. You notice that same configuration, the audience parameter here, is inline in the token, saying who this was issued for. And that's the thing you'll have to check to make sure that this isn't a stolen piece of data. Just like a passport in the real life, you have to make sure that someone hasn't taken this and used it where they shouldn't have. There's other information here about when this token was issued, so you can make sure it's still valid and make sure that it hasn't been replayed. There's the user data that we described. And finally, there's some information about who issued this token and how it's been cryptographically signed so that you can check the signature and ensure that it came from Google and hasn't been tampered with. Now, as you can imagine, it starts to get a little bit complicated about knowing all these details. And so what I'll show you next is libraries that you can use to do all of the checks and validation without having to know the internals of these tokens or how they work. So the first thing we need to do is send the token up to the server. The important thing to call out here is to make sure to do this over a secure channel. This is a user's credential that will give them access to their data, so you need to use HTTPS. Once it's on the server, as I described, we'd really strongly recommend using a library to validate this token. It is a standard JSON web token, so you could use any library that allows you to validate such tokens. But we'd recommend that you actually use an identity-specific one that checks the identity-specific claims. We'll have some libraries from Google specifically designed for these Google tokens coming soon on developers.google.com/identity. So once the token's been validated, just like the passport in real life, you can use the information that's available there. And as I described, the key things are checking whether this user has an existing account. So maybe you'll take the email address or the Google user ID, look up that user, and see if there's a matching one. As we've described, you know that in the case of Gmail users, their email address is actually active on this device or browser. They could reset their password if they had a traditional password-based account, and you should let them into that existing account. That's the first step. Now, once you've checked for existing users, the key thing to do is help onboard new users. Now, you know who these users are. You have their identity information, their name, their photo, and their email address, so you can really bootstrap the experience. But depending on the nature of your application, you might need to ask for additional data, so things like their location or their age, or maybe have them agree to terms of service. And that's stuff that you'll have to do in the front end of the app, so you have to spend some response back to finish the account creation process. At the end of the day, the hope is that you can build an experience like this. As Trefan showed at the beginning, coming to an app, either selecting with one tap or automatically signing into an existing account, with that token behind the scenes replacing manual authentication and a traditional sign-in screen. The takeaway here is that you can really focus on building your service. Adding this front-end pieces of UI have been simplified. You apply the back-end logic that's intended for your application, and you can use libraries that make this a lot easier. Before we move on, I'll add a plug for one more important tool here, and that is Firebase Auth. So if you're building for the Firebase platform, you're a new developer, or you're able to migrate in, we have a complete auth system that you can use. So instead of taking these libraries and adding to them to your existing auth system, we can make it a lot easier by using Firebase. OK, so Luke, are there any last questions we can help you with?
Yeah, that seems great that you can outsource all the work to Google by using those libraries. And as a developer, I'm totally convinced. But at the end of the day, we're trying to help out companies. How does this make financial sense to integrate into your site?
That's one that we always have to address, is that as developers, you come to places like Google I/O, and you're probably really convinced that there's opportunities for your auth system. Things could be done better. But we also have to convince people who are decision makers and business stakeholders about identity being worth investing in. So we have great stories from folks like HomeAway here, who have really leveraged the Google Identity platform to better know who their users are, to be able to personalize experiences across devices and get the right content in front of them whenever they come back to their site or app. And on top of that, it really introduces this opportunity that once the user's found that right piece of content, they can transact and engage with it. So that's things like smoothing out the checkout flow. I mentioned some of the numbers earlier about the improvement in conversion rates if you can make checkout easier. But we have this interesting stat recently from PetLoves, just saying, as a big shopping site in South America, that far more of their users are ending up at the checkout page already signed in. They never even needed to see the login page. So you get the best of both, the streamlined experience of a guest checkout, but knowing who that user is and the opportunity to re-engage them as they come back to your service in the future. So things like sending the user emails, if they've opted into that, about upcoming sales, deals, price changes, or maybe a reminder to buy flowers for your mom this weekend. So if you put all these pieces together, you get this smooth, personalized experience where you know your user, you can improve checkout and conversion rates, and you can keep users engaged and secure. After all, in a world where they don't even have passwords, they won't be phished, or you won't have problems with those weak and reused passwords. So I'll leave it to Luke to wrap up today and tell you a little bit about what we covered.
Thank you guys for explaining all this to me. I feel like I learned a lot here. It's a really seamless user experience where you can just skip the sign-in, don't even have to think about it. Transparent data sharing, you know exactly what you're giving away and what you're keeping private. And you get all these security benefits on the side. And for developers, you get all this account quality benefits. So Stephen, where do I go to start?
Well, the place to go we've mentioned a few times today is developers.google.com/identity. That's where you'll find the documentation for all of the APIs that we've described and case studies and examples with many of the partners that we've referenced. And since you're here at I/O, there's a couple of other talks that you'd probably like to visit and check out. We have some coming up tomorrow around building and personalizing in action, leveraging the same ideas and the same underlying Google identity, as well as a deep dive into this experience on the web that I've been talking about today. So if you've got time, definitely check those out tomorrow. And we'd love to continue the conversation. So we monitor the Stack Overflow tag Google-identity. Make sure to leave your questions there. That's the best place to put them out in front of the community. And our contact information is up here on the slides. You can send us an email. I'm sso@google.com. We would love to hear from you. And we'll be in the web sandbox after this, or around the stage if you've got questions that you'd like to ask us for. That's Tent G over on that side. So thank you very much for your attention today. We would love to hear from you and be able to show your site or your app up here next year at I/O about how you've made identity a more secure and easy experience for your users. Thank you.
Thank you.
Thank you for joining this session. Brand ambassadors will assist with directing you through the designated exits. We'll be making room for those who've registered for the next session. If you've registered for the next session in this room, we ask that you please clear the room and return via the registration line outside. Thank you.
Hello and welcome to I/O Live. I'm Timothy Jordan, and I'm standing here with Jeff Dean, the head of AI at Google.
Hi, Tim. Thanks.
Hi, Jeff. All right, let's start with a background of Google's work in AI.
So we've been using machine learning and AI for the last 20 years in some of our products, but in the last 5 or 6 years, we've really sort of dramatically accelerated our use of machine learning and AI into more and more of our products. We've really used it to make our products more intelligent, to make them sort of more accessible, to really improve the product and build products that we couldn't build any other way.
What's new with the technology that we're making available, say, the last year and at I/O?
In the last year, for example, we've made really great strides in improving TensorFlow, our open source machine learning system. One of the things I'm really excited about is the TensorFlow.js release, which essentially allows TensorFlow programs to be run in the browser just as normal web pages with sort of machine learning embedded code in them. And it's really easy for people to create really interesting new machine learning applications, and then people to run them by just loading up a web page. It's pretty fantastic.
And TPUs?
So we announced the third version of our TPU processor line. It's custom machine learning accelerators. The TPU V3 is really, really exciting. It's quite hot. So it actually is our first liquid-cooled processor that's in our data center. And the pods are actually larger scale than the TPU pods that we announced last year. So they're 8 times as powerful, more than 100 petaflops of compute, which is just an unbelievable amount of compute. And the really exciting thing is that allows us to make sort of more accurate models, machine learning models that can train on more data, that can train more powerful and more accurate models, and then we can use that to improve our products.
I think one of the things that makes me most excited about the technology that we're making available, it's that whole spectrum. All the way from TensorFlow.js, which is a very accessible way to get into machine learning, and AutoML, all the way up to TPUs, so like our advanced users have all that compute to do cool stuff with.
Yeah, I mean, I think there's going to be a lot of different levels of expertise and experience in using machine learning, and we want to make all of them able to use machine learning to improve their products and lives.
All right, so let's talk about what people are doing with machine learning, because we're getting there. What are some things that people are doing in the world with machine learning that you're the most excited about?
Yeah, so there's like lots of different applications. One that I'm really passionate about is the use of machine learning to improve healthcare. I think there's a real opportunity there for both kind of medical imaging related problems. We've been doing a lot of work on diabetic retinopathy and other kinds of medical imaging problems, but also in how patients' lives are affected, how doctors are able to care for patients with making better decisions. A lot of advances there. It's going to be great.
Okay, so there's these big problems that we're tackling with machine learning. What about everyday problems? Is there something that you encounter every day that you would love somebody to apply AI to?
Yeah, I mean, I think as you start to have a machine learning lens as you walk around the world, you can see things that could be better. For example, when I pull up to a stoplight and it's red and there's no cars coming the other direction, that's just silly, right? We should have computer vision based stoplights that just allow people to go when it's safe to go. And that would be like a simple improvement in the world that would improve lots of people's lives.
Thanks for joining me.
Thank you.
And thank you for watching I/O Live. To learn more about what Google is doing in AI and ML, head on over to google.ai. And to catch more videos like this, head on over to g.co/io/guide.
Cassava is a really important crop. It provides for over 500 million Africans every day.
When all other crops fail, farmers know that they could rely on their cassava plants to provide them food.
There are several diseases that affect cassava, and these diseases make the roots unedible. It is very crucial to actually control and manage these diseases.
So we're trying to use machine learning to respond to those diseases.
And TensorFlow is the best foundation for our solutions. The app that we've designed can diagnose multiple diseases. It's called Nuru, Swahili for light, the light that farmers can use to see their problems and find solutions. You wave your phone over a specific leaf, look at it, and if it has a symptom, a box will pop up saying you have this problem. When you get a diagnosis, we have an option for you to get advice and learn about the best management practices.
The object detection that we use through TensorFlow relies upon our team annotating images.
We've collected over 5,000 high-quality images of different cassava diseases for this project. We use a single-shot detector model on a mobile net architecture. It's able to make predictions in less than 1 second.
Instead of having to implement thousands of lines of code, TensorFlow provides a library of functions that allow us to build architectures in much less time.
We need something that can be deployed on a phone without any connection. TensorFlow is able to shrink these neural networks to be able to fit on your mobile device.
The human input is absolutely critical. We're really building something that augments your experience and makes you better at your job.
So with AI tools and machine learning, you can improve the yields, you can protect your crops, and you can have a much more reliable source of food.
AI offers the prospect to fundamentally transform the life of hundreds of millions of farmers around the world.
You can see a product that can actually make someone's life better. This is kind of revolutionary.
So the whole point of the AIY projects team at Google is to build artificial intelligence kits that let makers take the cool parts of Google Intelligence and put them into their builds. Last year, we released the Voice Kit, Train Fast, which was a kit that lets you record your voice and analyze it and get the text back from what you said. This year, we're releasing the Vision Kit. It does not need an internet connection. It does not need the cloud. You program it with the neural network model, and the kit then gives you back data on what it sees. So if I give it a face, the light will come on, and then as I get happier, the light will change from blue to yellow. So this is our MobileNets neural network. This is an object classifier, and it's got 1,000 different common objects in it. We have a banana, and let's see, a screwdriver. Yeah, it's got that pretty good. It's got an apple, not just an apple, it's got the type of apple as well. And even water bottle, which is tricky because it is a clear thing, so it's not really a thing, it's just reflecting other things. So learning how to use these things and how to make it detect what you want to detect is going to be part of the fun. Our face detector code tells us not only that there is a face in the image, but it also tells us where the face is. It gives us the geometry about the face. So we can use that to build a tracker that can follow me wherever I go. We've shown you face detection, object recognition, and face tracking with the Google AIY Vision Kit. But this is just the beginning. Click on the link below to learn more. We're really looking forward to seeing what you build with this kit.
Hello and welcome to I/O Live. I'm Timothy Jordan, and I'm standing here with Jeff Dean, the head of AI at Google.
Hi, Tim. Thanks.
Hi, Jeff. All right, let's start with a background of Google's work in AI.
So we've been using machine learning and AI for the last 20 years in some of our products, but in the last 5 or 6 years, we've really sort of dramatically accelerated our use of machine learning and AI into more and more of our products. We've really used it to make our products more intelligent, to make them sort of more accessible, to really improve the product and build products that we couldn't build any other way.
What's new with the technology that we're making available, say, the last year and at I/O?
In the last year, for example, we've made really great strides in improving TensorFlow, our open source machine learning system. One of the things I'm really excited about is the TensorFlow.js release, which essentially allows TensorFlow programs to be run in the browser just as normal web pages with sort of machine learning embedded code in them. And it's really easy for people to create really interesting new machine learning applications and then people to run them by just loading up a web page. It's pretty fantastic.
And TPUs?
So we announced the third version of our TPU processor line, custom machine learning accelerators. The TPU V3 is really, really exciting. It's quite hot, so it actually is our first liquid-cooled processor that's in our data center. And the pods are actually larger scale than the TPU pods that we announced last year, so they're 8 times as powerful, more than 100 petaflops of compute, which is just an unbelievable amount of compute. And the really exciting thing is that allows us to make sort of more accurate models, machine learning models that can train on more data, that can train more powerful and more accurate models, and then we can use that to improve our products.
I think one of the things that makes me most excited about the technology that we're making available, it's that whole spectrum. All the way from TensorFlow JS, which is a very accessible way to get into machine learning, and AutoML, all the way up to TPUs, so like our advanced users have all that compute to do cool stuff with.
Yeah, I mean, I think there's going to be a lot of different levels of expertise and experience in using machine learning. We want to make all of them able to use machine learning to improve their products and lives.
All right, so let's talk about what people are doing with machine learning, because we're getting there. What are some things that people are doing in the world with machine learning that you're the most excited about?
Yeah, so there's like lots of different applications. One that I'm really passionate about is the use of machine learning to improve healthcare. I think there's a real opportunity there for both kind of medical imaging related problems. We've been doing a lot of work on diabetic retinopathy and other kinds of medical imaging problems, but also in how patients' lives are affected, how doctors are able to care for patients with making better decisions. A lot of advances there. It's going to be great.
Okay, so there's these big problems that we're tackling with machine learning. What about everyday problems? Is there something that you encounter every day that you would love somebody to apply AI to?
Yeah, I mean, I think as you start to have a machine learning lens as you walk around the world, you can see things that could be better. For example, when I pull up to a stoplight and it's red and there's no cars coming the other direction, that's just silly, right? We should have computer vision-based stoplights that just allow people to go when it's safe to go.
Right. Good morning, everybody. I'm Ruchi, and this is Ben, and we are from the Google Photos team.
We built Google Photos to help people solve the problems they were having storing, organizing, and sharing their memories. And now, 3 years in, we're delighted that hundreds of millions of people around the world call the product home for their photos and videos. Here at I/O, we're announcing a new way for you as developers to be able to use this platform to build photo and video experiences that are smarter, faster, and easier to use. In the session today, we're going to dive into some of those new technologies and show how you can use them to bring the best of Google Photos into your own apps. Now, we designed Google Photos and we built the app for the way people use photos and videos today. This means users get unlimited storage, so yes, we can do the inevitable and take 15 photos to capture the perfect sunset, or automatic backup, so we never lose our memories, even as we change devices over time. And of course, we built the product with machine learning at its core. And you heard Sundar speak yesterday in the keynote about the ways in which we're applying AI to help people organize and bring their memories to life. And one of my favorites that the team's been working on is what we call Color Pop. What this means is the Google Photos Assistant can help you automatically create images like this. And you can see how this effect really elevates the subject in vivid color, fading the background. And if you look closely, the AI has even identified and segmented the flower that this little girl has in her hair. It's pretty neat. Now, these are just a few examples, but of course we all use our photos and videos in different ways. When we look across the apps and devices that are important to people, we see a lot of workflows that are difficult and tedious. Like if you've ever tried to set up a digital photo frame and you're moving files between devices, it's a real chore just to keep up to date. Or how, after you go on a holiday trip, your family memories are handed to you on a USB drive or even a DVD. Like, what do I even do with that? And we're all constantly downloading and re-uploading content between services. Maybe you're posting about your latest adventures and you have some awesome drone footage that you want to include, but it's in 4K and you have to download and re-upload over mobile data. And so we think it should be much easier for people to seamlessly use their photos and videos across all the apps and devices that are important to them. But to solve these problems, we can't do it alone. And that's why today, we're announcing the Google Photos Partner Program and giving you as developers the tools and APIs you need to build amazing photo and video experiences for your users. Now, as a developer, we know you want to make your apps engaging and user-friendly. And look, photos are a great way to do that, but often this involves complex infrastructure for serving and having to pay for storage just to duplicate the user's own content. So we think that should be easier too. And so at the core of the partner program is what we call the Google Photos Library API. This makes available some of our best technology to you to be able to bring the best of Google Photos and AI to help solve real problems for your users. And here's Ruchi to tell you more.
Thank you, Ben. All right. Now I'm going to show you how you can use the API to build more engaging experiences for your users. There are three main functionalities that the API enables. The first is that it will allow your users to access their library of photos in your products. The second is that you will be able to upload photos to a user's Google Photos library. And third, it will provide the infrastructure you need to enable sharing of photos within your apps. It goes without saying, but all of this requires explicit user consent. So let's hone in on Connect. One of the main things we wanted to solve when building this API is to make it incredibly simple for users to access and experience their photos in their favorite apps and devices, many of which you build. This could be in TimeHop, where once you've integrated your library and given permission to use it, you'll get more personalized and creative reminders of memories to look back on. Or on HP Sprocket. It's a really cute portable printer that will let you print photos from your own library as stickers on the go. While this functionality is fantastic to provide your users access to their library in your products, we also want to help developers surface the right photos a user might need in context. And you can do this thanks to the filters functionality. There are 4 ways you can filter a library of photos. The first is content categories. And that's categories of photos that a user has, whether it's pet photos, selfies, landscape photos, landmark photos, so on. Then there's the date of when the photos were created, so the time period of photos and videos. And then there's the media type, excuse me, so that's whether it's a photo or video or something else. You can pull those out too. And finally, a personal album a user already has created in their account. OK, time for a question. How many of you here have ever had to do expenses? Raise your hands. OK, full room. Keep them up, keep them up. How many of you would say that you have loved doing expenses? OK, sad state, yeah. Nobody really likes doing expenses, neither do I. But Xero, an app that helps us do expenses, is now integrating with the library API. So what this means is that they can apply these filters I referenced earlier, and they can pull receipt images in a certain time range and surface them as suggestions of expenses I should do. So completing expenses is as simple as viewing the suggestion and hitting tap to submit.
Pretty amazing. Thanks, Ruchi.
Yeah.
So using these smart filters is a really powerful way that you can make it easier for your users to find just the content they're looking for. And I'm going to show you a few code examples. And as the library API is a RESTful API, you can play along whether you're a mobile, backend, or web developer. The first filter, that we're most excited about are content categories. And as Ruchi mentioned, these use Google's computer vision to figure out what an image is about, so you can filter and narrow down results in your app. The API offers many categories to choose from. And as you can see from this example, I can also exclude categories that might not make sense for my use case. For example, an app like TimeHop, which is there to really remind me of my fondest memories, may not want to include pictures of old bills and receipts and other documents from years ago. And filters are a great way to be able to exclude this content. Another way that users explore their content is based on time. And sometimes you'll want to present photos chronologically so you can scroll back in time. But there are other use cases where being able to just jump to the right moment can make it much easier for your users to find their content. As you can see, you can filter by specific dates or date ranges. And you can also combine filters together to be even more expressive. Say I wanted to find all of my birthday photos from years past and put them together in a collage. I could sit there and scroll through decades of photos to try and find just the right pics. Or I could combine a date and content category filter like this. You can see how we've omitted the year here and left it as a wildcard, so it'll match any days on my birthday. And included a content category filter to find those great selfies and birthday celebration moments. It's pretty neat. Of course, you can also filter by other kinds of media types, so photos, videos, or other kinds of content like VR. And you can select photos that are already in an album that a user has curated for some purpose. But regardless of the filters you use, you'll get back a list of what we refer to as media items. And here's what one looks like. Google Photos supports a wide variety of media formats, from the obvious photos and videos to animations and even complex VR and 360-degree images. So for each media item, you'll get back this consistent JSON object. And there are a couple of interesting attributes here. The first is the base URL, and this is what your application uses to access the image bytes themselves, so you can show them in your app. A subtle but really powerful feature of this URL is that it has built-in resizing. So with a simple parameter, you can ask Google Photos to return an image that fits the dimensions or aspect ratio for your device, saving you a lot of boilerplate code. It also makes it really easy to reduce data transfer for users on mobile. The second URL here is a product URL. And what this is a deep link back into Google Photos. This can be really helpful if you want to provide a complete and comprehensive UX with common tasks like cropping, rotating, and even viewing complicated formats such as VR. You can just link out to Google Photos rather than rebuilding all of that code in your own app. And then, of course, there's other metadata, depending on the media format you're dealing with. And what's powerful about this is Google Photos will extract this from a variety of media formats. So you don't have to go through and parse it yourself. You'll have it returned in this consistent JSON object. And so with all of this data together, you're able to build and include the user's content inside of your user experience and make it seamless and fast for them to bring photos and videos into your application, just like the examples we showed earlier.
Thank you, Ben. All right, so Ben talked about how users can access their library of photos in your products. Now, what about when you need to send users their photos? The upload functionality can help you do this. So with the library API, developers will be able to send full resolution photos and videos to a user by adding it directly into their Google Photos account. Let me walk you through how this would work. So this is actually one of my photo albums that I have at home. But accessing all my albums can be extremely difficult. They're buried in dusty cupboards in my house, or they are thousands of miles away at my parents' home. They live in Germany. So it's not going to be very frequent when I get to see them. But I decided to get this fixed. I gathered my albums and sent them to Legacy Republic. They specialize in digitizing physical albums and old media formats like VHS tapes. I hope people have heard about VHS tapes in the room. OK. So once they had digitized it and it was ready, Legacy Republic was able to use the library API, create an album, and upload more than 600 photos they just digitized into my account almost instantly. That means, at the end of the day, I had access to all of my childhood memories and some embarrassing photos that I won't pull up here. But they were all in the palm of my hands, right in the Google Photos app. One thing my physical albums do have, and this is a scrapbook that I had from when I was younger, is a rich amount of information. They don't just hold photos, but they tell stories, at least for me. I scribble little descriptions of things I would think of, the places where the photos were taken, or when they were captured. With the library API, Legacy Republic was able to take this information and bring it into a digital album in Google Photos. So a scrapbook like what you saw turned into this. So having hundreds of photos in one place is really great. But we also want to help users find that exact photo they're talking about in a story. And thanks to the machine intelligence in Google Photos, we can do that too. So let's say I want to show you my photos from the last few weeks. I'll just type in me in the search bar, and I'll get photos of me. You don't look that impressed. I guess, yes, those photos are on the top of my grid, so it doesn't seem as hard. But let's say I wanted to tell you I was a little chubby toddler when I was a baby. I won't tell you how many years ago, but the next example will tell it to you anyway. I could type in me in 1990, and in less than a second, get photos of me as a baby. So I think, Ben, it's time for you to show some of your embarrassing photos.
I don't think anyone wants to see those, Ruchi. Now, I'm going to show you how we can create our own rich albums using the API. But before we do that, a quick poll. How many of you out there have a friend who's an outdoors person? Go ahead, raise your hand. You know the type, they go camping and running and hiking. And you'll know they're an outdoors person because they will absolutely tell you about it at every waking moment. You'll come back into the office on Monday morning and they'll regale to you the epic miles they covered and cliffs and snakes and bears that they had to fight with just to get in for Monday morning stand-ups. I have a confession to make. In my team, that guy is me. And so to prove this to my colleagues, a few months ago, I went for a hike in central outback Australia. It was a pretty memorable trip. So I built a little app to track my progress and take a few notes along the way. And now we're going to try and save it all in Google Photos. So the first thing we'll do with the API is go ahead and create an album. Simply send a post request, and you can specify the title of the album. And in the response, you'll get back an ID, which we'll use in just a second, and a product URL, which is, again, a deep link so you can show the content in Google Photos. As you can see, the album's empty for now, so let's fix that. Second step is to upload the actual image bytes to Google's servers. Because we support a wide variety of media formats, you typically won't need to worry about transcoding between formats. You just upload the bytes, and the service will give you back an upload token. And we'll use it here in the create media item call, as you can see. We'll also fill in the album ID that we just created. And at this point, you're probably thinking, OK, thanks, Ben. We've talked a lot, done a lot of plumbing, moved some IDs around. How about you show me something interesting? Well, a big benefit of Google Photos is being able to search by what you remember. Some of this happens automatically, thanks to the AI. So I could search for the Eiffel Tower and find pictures I've taken of the Eiffel Tower. but there are some things that only you or your app knows. In this case, I'm taking a photo of an area my friends told me to go and look at called the Pound. And it's colloquial, it's not on the maps, so only I remember it. But I can put it in the description with a few extra details, and you'll see that this then becomes searchable in Google Photos, and all that context is stored right with the image, so I can see it again in years to come. This is a great tool you can use in your apps. Maybe you're building a game, and you want players to be able to save their favorite moments and include the player's name or the level that their character was at. Or maybe you're just delivering marathon finish line photos and want to be able to remind the user of the great time they got. But let's be honest, individual photos aren't all that interesting on their own. So through the power of this clicker, we'll add a few more. Now, we mentioned earlier that you can create rich albums that contain text headings, locations, maps, and even control the album layout. And in Google Photos, we call these features album enrichments. Because there's not a whole lot else to do in the desert, each day I took a few notes about the track. And now using album enrichments, I can group together my photos to tell a meaningful story. To do this, we'll go ahead and call add enrichment and create a text enrichment. And finally, specifying the position for the enrichment to be displayed in the album, maybe after the last photo I took each day. And as you can see, this creates headings and dividers, and our album's really starting to come together now. There are other kinds of enrichments you can add too. I could add individual locations or even maps that describe the journey. And this can be useful for all sorts of applications. Maybe you're an amusement park and you want to be able to deliver photos from the rides that someone's just taken in the park. Or maybe you're just trying to document the progress of a project, like building your first home or seeing your child's art project progress throughout the school term. But for my hiking app, the finished product looks a little bit like this. You can see it's nicely laid out with all the context safely stored in my Google Photos library. And hey, now I can easily share it with all of my friends and colleagues back in the office.
Yeah, I think we've seen too many of Ben's hiking photos, but Ben did queue up the perfect segue to talk about the sharing capabilities that the Library API offers. Did any of you go to the I/O block party last night? So you may recall, yes, I see some of you, you may recall seeing this arcade photo booth. Now, the photo booth was really fun, but what Ben and I were most excited about was that it was integrated with our Library API. So what this meant is you didn't have to fight over who gets that one physical copy, that token from your photo booth. Instead, an attendee would get a one-time shared album where they can gather all their photos and videos that have just been captured right on the device they're using. And something to note is the attendee doesn't have to have the photo booth app or Google Photos to get this link. You can also bring the sharing functionality and make it work inside of your mobile apps. So let's take a look. Here's an app for a soccer club. Players are discussing where to meet up, sharing scores from the latest games. But to share photos today, they have to close this app, open another app, and then invite the same group to share photos. This doesn't seem that efficient. And so with the Library API, these players will be able to upload photos as they happen in the same conversation. So everything can finally happen in your app. Let's take a look at this code. With shared albums, you'll have the option to turn on or off comments or allow users to collaborate, so add their own photos into the album. In the response, you'll get a shareable URL. These are deep links that open to Google Photos and work across any platform. And you get back a share token. This is what you will use to invite people to join the shared album from within your app. It's what I showed you in the soccer example. Now, you need to show your album in your app, right? And to do this, you send a GET request. And you'll get back a list of shared albums that a user has joined. So I'll pause on the screen. The list you'll also get will show attributes like the title and cover photo, which you'll be able to build into your UI. Okay. The sharing functionality really comes together in this final use case I'd like to walk you through. But first, let me tell you a little story. A few years ago, I decided to gift my grandfather a digital photo frame. I felt like a really good granddaughter, and he loved it. Grabbed a USB drive, put in 10 photos, and there it was. But years later, as many of you have experienced, my poor grandpa is watching the same 10 photos on rotation over and over and over again. And now Nixplay, they create beautiful digital photo frames, and they're integrating with the library API to hopefully help me fix this issue. Let me show you how it would work in this context now. To get started, we would create a shared album in the Nixplay app. And they can do this because they're integrated with the library API. You can also pick an existing album you have in Google Photos, but let's go through a new album creation flow. So you can invite people, your friends and family, to collaborate in this album. And then you can select that album to be the main one you want displayed on the frame. After that, it's simple. As friends and family add photos to that album, they'll automatically be displayed on the Nixplay frame you have in your home. So I did put this to the test, and I connected my grandfather's Nixplay app to my shared album that I already had with him. I put photos in there when I'm thinking of him or missing him as I travel the world or just sitting at home in San Francisco. So once we connected it up, as I decided to share photos with my grandfather, he has a front row seat to these moments in his home all the way in Delhi without having to do any extra work.
Thanks, Ruchi. So we've shown you today 3 great ways that you can use the library API to bring the magic of Google Photos into your apps. We showed how you can create seamless connections that allow users to bring their content into your product and service and use smart filters to help them find just what they're looking for. We talked about how you can use the upload functionality to create more mobile-friendly ways of delivering content to your users. And finally, we talked about how you can build deep, engaging sharing experiences right into your apps. We've also aimed to take a lot of the hassle out of building a seamless UX with features like automatic thumbnailing and deep links that allow you to focus on what makes your app unique. And all the API services we've talked about today are available right now in developer preview, which means you can activate the API and start building right away. You can head over to developers.google.com/photos, which has full documentation, and we have samples on GitHub to help you get started. Now, we've been working with some amazing early partners, and the demos we've shown are a preview of things to come. But if you're inspired by what you've seen, you can also find a link on our website to express interest in joining the partner program for your own product. Now, I do want to point out that we care very deeply about the experience that Google Photos users have. And that's why every company we work with is expected to meet certain app quality guidelines. And we also have strict privacy provisions that govern how you can use the data that users agree to share. We take those rules very seriously. And so as your app grows, you can expect a few check-ins from time to time with the Google Photos team. Finally, we really value your suggestions as developers. And so as you start to explore the API, please get in touch through our developer channels and give us your feedback. You can also come along to the Photos office hours here at I/O and meet with the team directly to talk about your app. But that's it for this morning's session. We're really excited about the road ahead and look forward to working with you to develop great products that work with Google Photos. We've been Ben and Ruchi. You've all been a wonderful audience. Thanks very much. Have a great I/O.
Thank you for joining this session. Brand ambassadors will assist with directing you through the designated exits. We'll be making room for those who've registered for the next session. If you've registered for the next session in this room, we ask that you please clear the room and return via the registration line outside.
I'm going to be relying on my young child to take care of me, and I want him to know some things. So, you know, it's always on my mind, and it's something that I think I'm now more than ever driven to do and include as part of my design aesthetic.
Yeah, it's almost like if you can see it, you can be it.
Absolutely. And I've been watching, you know, I watch all the videos on Twitter. People will send me stuff of teachers teaching about the sort of, you know, things that we did. You know, I did a deep dive, but it was sort of a lighter dive into the technology in Black Panther and the science in Black Panther. And teachers are coming up with a way to teach their class using Black Panther as an example of sort of our vibranium and our, you know, sound science that we use in the movie. And to see that becoming part of like a curriculum and kids getting excited about it because they see themselves and, yeah, I can do this is, I mean, you can't ask for anything more. And so, you know, I've always thought, like, what can I do to better the world as one individual? And I didn't really know ever what that was until I think after Black Panther, and I saw the response of young kids, and it was all about the representation. And so, you know, that does become a design choice, and it's something that I think that I'm just going to do now forever.
Let's talk about that a little bit more, because you're on record as saying that when you were working on Black Panther, you were just focusing on it being good,
yeah.
Right? But then afterwards, looking back on how big a deal this is for how many people, how has your perspective changed?
I mean, it hugely, because it was just, you're kind of in it, you know, and you can't, like you were saying, see the forest through the trees. So you're just wanting to make sure it's good and it's right and that people are going to be happy and proud and that, you know, you did the right thing, you made the right choices, because at the end of the day, it was a lot of responsibility in some aspects. So you know, and then after when I saw it, I was like, I mean, my eyes were, because I did a little bit of the VFX, I was there for a little bit, but I didn't see the final edit. I saw one of the cuts. So when I was there in the theater with everybody else, I was blown away. I was like, this is insane. I can't believe I did this. and seeing the responses, it's just on another level. It's just, you know, it's really hard to put into words or articulate in a way that others can understand, because it really is made me speechless in a sense. There hasn't been the words made yet to describe what that's like, but it was certainly always about making a good movie with a great story, and hopefully everything else sort of fell in line. And then we had other great filmmakers, Ruth Carter, who is Oscar-nominated costume designer, who I worked with really intensively to make sure that what we did matched up, you know, because a lot of what she did in the foreground on the characters defined who they were on screen. So that also gave back to the representation of powerful women who had their own agency about them and could make their own decisions and stand up for themselves and could think quick on their feet. That's a whole nother sense of representation in a social aspect for young kids, young girls, and the men who, you know, treated them on this equal playing field. There was no like, oh, we need to make it easy for the girls. You know, you saw the door fight. You saw the king treat them as if they were, when they were the most powerful, you know, guards in Wakanda. So it's all of those things mixed together. Then you talk about the technology on top of that. You're giving a new generation, old generations, my generation, a whole another narrative than the one that we've sort of heard for the last how many ever decades.
Let's talk a little bit more about the technology, but not go away from the human aspects that you're talking about. And I think one of the things that's always really interested me in technology is not how to make tech just sort of better on its own, and then teach people how to use it, but rather teach technology how to be better for people. Absolutely. And I think that you've really captured in this film an intersection with culture and people and technology. How did you approach that?
Oh, that's heavy, man. You know, very carefully, because it's really trying to understand community, what the needs of community are, And then how do we envelop the technology, just what you said. And I know for Ryan, community was really important. So and I talked to a lot of experts. It wasn't just me sort of coming up with things. I talked to a lot of people who really knew, nanotechnologists, neuroscientists, archaeologists, geologists, geographers, on a daily basis, to understand how to fold that in. And I think one of the biggest things that I did was I tried to find, a lot of the tech was based on biomimetics. So I tried to find in nature and in the different cultures what the use of something was, and then the evolution of it. Because at the end of the day, it is all about the evolution of it, how we are in society and how we are advancing technologically. So it was me relating these things back in a way that represented what they are really used for and how they would have evolved over time. And I think technologically, oftentimes, it is the thing for the thing's sake and not here is, you know, something that has been such a big part of a tradition of any nationality, any ethnicity, any culture, religion, and this is how it becomes useful in a futuristic and advanced way. If that means technology, then that's the way that it would be. So that's sort of how I strung those together. And then pulling from nature. That was a huge one. And thereby keeping everything organic, in a sense. So it becomes not such a scary thing, but a very organic thing, because we're so used to seeing certain things in nature, patterns, shapes, you know, geometry, all of these things, math, science, it's all around us constantly. So it was really easy at some point to start just looking just into nature, because it is science. It is technology. You know what I mean? Like the way everything works. So looking beyond the hardware and the finish of the hardware of it and into the organic nature of it all. That's like a little dive into how it went.
It must have been a very full 14 months working on this film.
Beyond. We were on 3 continents, we were in 2 states, and I had a team at any given moment that were 500 strong, just in my department. So we went 14 months, and we went hard as we could go for 14 months to get this done, and put every last, like my whole team put every last inch of themselves. So, you know, it was a beautiful thing because we represented the diaspora, just our crew. So it was a micro version of the macro that we were building in Wakanda. And I lived that every single day for a little over a year.
All right, I want to ask you about what's next, but it doesn't have to be specific projects. But it's like, where do you go from here with everything that you've talked about, right? Like the production design itself, but like the bigger themes and ideas that you're working on.
You know, challenging myself, I think, to try to continue to do things that are out of my comfort zone. Something I learned from Ryan Coogler, who has taken me from Fruitvale Station to a boxing movie, Creed, to a comic book movie, Black Panther. I want to continue the trend on my own and not just be in a place that I feel comfortable. My next project with Melina Matsuko, who is a director for Insecure, I'm just working on the pilot for Why the Last Man, which is a graphic novel.
Yes. I've read the entire series. Okay. So good.
So I'm going to be designing the pilot. We're working on that currently. I can't really say much more than that, but it's super exciting. The script is phenomenal. And our approach to it is going to be, I think, something really cool. So I'm really super excited about that. Worked with Beyonce again. That's all I can say about that. And the future is wide open. And if Denis Villeneuve is listening, I'd love to do Dune.
Yes.
I throw that out every opportunity I can get. Denis?
Yes. Hannah, thank you so much for joining me and sharing your story and all the work that you do.
Thank you so much. It's super exciting. I'm so happy to be here, and I think I'm going to learn something today, too. So, you know, it's all about soaking in all this greatness. So, fabulous. Thank you.
Thank you. I'm Timothy Jordan, and this is I/O Live.
All the way up now.
I can't imagine how anybody passes a problem that they know that they can fix and doesn't try to fix it. That's not some complicated thing. It's just stop talking about it and start doing it. I feel an absolute obligation to serve. I did 2 tours in Iraq as a helicopter pilot. I loved being part of the cavalry. But then I got injured, and that caused me to lose my ability to fly. One day you're a soldier, and then overnight they rip off that tag and slap veteran on your chest. I didn't know where to start looking for the next thing. What I do is math and engineering, so I had to find a way to apply those things in a meaningful way. Service doesn't end when you get out of the military, it just changes. And I started reading about the research that they were doing at the Human Engineering Research Lab, and I thought, man, I gotta go be a part of that. HURL's mission is to help people with disabilities increase independence and quality of life. I prepare the software to support the research that we do. One of the big things that I've done is help us transition to using Android tools. They make things really accessible. Anybody can sit down and start using these technologies and perform the tasks that we hope that it'll be useful for. That's the right thing to do, is to make things not just able to be used, but to be used with the same sort of joy or ease as I do. A big part of why open technology is so attractive to engineers like myself is there's such an active community of people designing and innovating.
Welcome to Pittsburgh.
All 3 of my children have a disability. The fact that my son has autism is just one little part of him, but almost his entire existence is defined by that autism. There was part of me that hoped someday I'd be able to help my son be able to live independently and give him a future. That's part of why I became an engineer, is part of why I got into this field. There's going to be a time where someone like my son will have gotten a better opportunity, a better swing at this thing. I'm not going to sit around and wait for somebody else to fix the problem. There's not a minute to be wasted thinking about anything but the good things that we can do.
This is I/O Live, and I'm Timothy Jordan, and I'm standing here with Hannah Beekler, who is a production designer. You may know her from Black Panther.
Hello.
Hi, how are you today?
I gotta give it one of these. Great, I'm doing great. I'm so happy to be here.
Me too. We're really glad that you came here to talk about your work and to talk about diversity and inclusion and how that's affected by representation in media.
Absolutely. I mean, I think a big important part of that is if you don't see it, you can't be it. And so putting those things into our narrative work and films, which, you know, everybody finds the time to go see a good movie, as noted by Infinity War, and, you know, and to represent a huge portion of the, you know, population in that way. I think when people see it, they realize, like, I can do that. I can have those same goals in life because it's not going to be impossible. And I think that that's such a huge, important part of my work, in my body of work over the last 3 years.
Yeah, one of the things I think about a lot is that I was really lucky growing up, wanting to be an engineer and seeing lots of engineers that looked like me. And that was inspiring, and I really want that for everyone.
Absolutely. I mean, I think inspiring the next generation of young scientists who are females, young kids of color, who see a world where they have a sense of pride, where they have a sense of, you know, reaching back and seeing their tradition and their culture and their ancestors and all those things, even being a part of their future. And I think walking away with a huge sense of themselves that they otherwise may not know or have had privy to, or so it's lifting spirits that's so important when it comes to representation. It's not only about getting into certain fields; it's about who we're raising in the world for the future, because I know I'm going to be relying on my young child to take care of me, and I want him to know some things. So, you know, it's always on my mind, and it's something that I think I'm now more than ever driven to do and include as part of my design aesthetic.
Yeah, it's almost like if you can see it, you can be it.
Absolutely. And I've been watching, you know, I watch all the videos on Twitter. People will send me stuff of teachers teaching about the sort of, you know, things that we did. You know, I did a deep dive, but it was sort of a lighter dive into the technology in Black Panther and the science in Black Panther. And teachers are coming up with a way to teach their class using Black Panther as an example of sort of our vibranium and our, you know, sound science that we use in the movie. And to see that becoming part of like a curriculum and kids getting excited about it because they see themselves and, yeah, I can do this is, I mean, you can't ask for anything more. And so, you know, I've always thought, like, what can I do to better the world as one individual? And I didn't really know ever what that was until I think after Black Panther, and I saw the response of young kids, and it was all about the representation. And so, you know, that does become a design choice, and it's something that I think that I'm just going to do now forever.
Let's talk about that a little bit more, because you're on record as saying that when you were working on Black Panther, you were just focusing on it being good,
yeah.
Right? But then afterwards, looking back on how big a deal this is for how many people, how has your perspective changed?
I mean, it hugely, because it was just, you're kind of in it, you know, and you can't, like you were saying, see the forest through the trees. So you're just wanting to make sure it's good and it's right and that people are going to be happy and proud and that, you know, you did the right thing, you made the right choices, because at the end of the day, it was a lot of responsibility in some aspects. So you know, and then after when I saw it, I was like, I mean, my eyes were, because I did a little bit of the VFX, I was there for a little bit, but I didn't see the final edit. I saw one of the cuts. So when I was there in the theater with everybody else, I was blown away. I was like, this is insane. I can't believe I did this. and seeing the responses, it's just on another level. It's just, you know, it's really hard to put into words or articulate in a way that others can understand, because it really is made me speechless in a sense. There hasn't been the words made yet to describe what that's like, but it was certainly always about making a good movie with a great story, and hopefully everything else sort of fell in line. And then we had other great filmmakers, Ruth Carter, who is Oscar-nominated costume designer, who I worked with really intensively to make sure that what we did matched up, you know, because a lot of what she did in the foreground on the characters defined who they were on screen. So that also gave back to the representation of powerful women who had their own agency about them and could make their own decisions and stand up for themselves and could think quick on their feet. That's a whole nother sense of representation and a social aspect for young kids, young girls, and the men who, you know, treated them on this equal playing field. There was no like, oh, we need to make it easy for the girls. You know, you saw the door fight. You saw the king treat them as if they were, when they were the most powerful, you know, guards in Wakanda. So it's all of those things mixed together. Then you talk about the technology on top of that. You're giving a new generation, old generations, my generation, a whole another narrative than the one that we've sort of heard for the last how many ever decades.
Let's talk a little bit more about the technology, but not go away from the human aspects that you're talking about. And I think one of the things that's always really interested me in technology is not how to make tech just sort of better on its own, and then teach people how to use it, but rather teach technology how to be better for people. Absolutely. And I think that you've really captured in this film an intersection with culture and people and technology. How did you approach that?
Oh, that's heavy, man. You know, very carefully, because it's really trying to understand community, what the needs of community are, and then how do we envelop the technology, just what you said. And I know for Ryan, community was really important. So and I talked to a lot of experts. It wasn't just me sort of coming up with things. I talked to a lot of people who really knew, nanotechnologists, neuroscientists, archaeologists, geologists, geographers, on a daily basis, to understand how to fold that in. And I think one of the biggest things that I did was I tried to find, a lot of the tech was based on biomimetics. So I tried to find in nature and in the different cultures what the use of something was, and then the evolution of it. Because at the end of the day, it is all about the evolution of it, how we are in society and how we are advancing technologically. So it was me relating these things back in a way that represented what they are really used for and how they would have evolved over time. And I think technologically, oftentimes, it is the thing for the thing's sake and not here is, you know, something that has been such a big part of a tradition of any nationality, any ethnicity, any culture, religion, and this is how it becomes useful in a futuristic and advanced way. If that means technology, then that's the way that it would be. So that's sort of how I strung those together. And then pulling from nature. That was a huge one. And thereby keeping everything organic, in a sense. So it becomes not such a scary thing, but a very organic thing, because we're so used to seeing certain things in nature, patterns, shapes, you know, geometry, all of these things, math, science, it's all around us constantly. So it was really easy at some point to start just looking just into nature, because it is science. It is technology. You know what I mean? Like the way everything works. So looking beyond the hardware and the finish of the hardware of it and into the organic nature of it all. That's like a little dive into how it went.
It must have been a very full 14 months working on this film.
Beyond. We were on 3 continents, we were in 2 states, and I had a team at any given moment that were 500 strong, just in my department. So we went 14 months, and we went hard as we could go for 14 months to get this done, and put every last, like my whole team put every last inch of themselves. So, you know, it was a beautiful thing because we represented the diaspora, just our crew. So it was a micro version of the macro that we were building in Wakanda. I lived that every single day for a little over a year.
All right, I want to ask you about what's next, but it doesn't have to be specific projects. But it's like, where do you go from here with everything that you've talked about, right? Like the production design itself, but like the bigger themes and ideas that you're working on.
You know, challenging myself, I think, to try to continue to do things that are out of my comfort zone. Something I learned from Ryan Coogler, who has taken me from Fruitvale Station to a boxing movie, Creed, to a comic book movie, Black Panther. I want to continue the trend on my own and not just be in a place that I feel comfortable. My next project with Melina Matsuko, who is a director for Insecure, I'm just working on the pilot for Why the Last Man, which is a graphic novel.
Yes. I've read the entire series. So good.
So I'm going to be designing the pilot. We're working on that currently. I can't really say much more than that, but it's super exciting. The script is phenomenal. And our approach to it is going to be, I think, something really cool. So I'm really super excited about that. Worked with Beyonce again. That's all I can say about that. And the future is wide open. And if Denis Villeneuve is listening, I'd love to do Dune.
Yes.
I throw that out every opportunity I can get. Denis?
Yes. Hannah, thank you so much for joining me and sharing your story and all the work that you do.
Thank you so much. It's super exciting. I'm so happy to be here, and I think I'm going to learn something today, too. So, you know, it's all about soaking in all this greatness. So, fabulous. Thank you.
Thank you. I'm Timothy Jordan, and this is I/O Live.
All the way up now.
I can't imagine how anybody passes a problem that they know that they can fix and doesn't try to fix it. That's not some complicated thing. It's just stop talking about it and start doing it. I feel an absolute obligation to serve. I did 2 tours in Iraq as a helicopter pilot. I loved being part of the cavalry. But then I got injured, and that caused me to lose my ability to fly. One day you're a soldier, And then overnight, they rip off that tag and slap veteran on your chest. I didn't know where to start looking for the next thing. What I do is math and engineering, so I had to find a way to apply those things in a meaningful way. Service doesn't end when you get out of the military, it just changes. And I started reading about the research that they were doing at the Human Engineering Research Lab, and I thought, man, I gotta go be a part of that. HURL's mission is to help people with disabilities increase independence and quality of life. I prepare the software to support the research that we do. One of the big things that I've done is help us transition to using Android tools. They make things really accessible. Anybody can sit down and start using these technologies and perform the tasks that we hope that it'll be useful for. That's the right thing to do, is to make things not just able to be used, but to be used with the same sort of joy or ease as I do. A big part of why open technology is so attractive to engineers like myself is there's such an active community of people designing and innovating.
Welcome to Pittsburgh.
All three of my children have a disability. The fact that my son has autism is just one little part of him, but almost his entire existence is defined by that autism. There was part of me that hoped someday I'd be able to help my son be able to live independently and give him a future. That's part of why I became an engineer, it's part of why I got into this field. There's going to be a time where someone like my son will have gotten a better opportunity, a better swing at this thing. I'm not going to sit around and wait for somebody else to fix the problem. There's not a minute to be wasted thinking about anything but the good things that we can do.
This is I/O Live, and I'm Timothy Jordan, and I'm standing here with Hannah Beekler, who is a production designer. You may know her from Black Panther.
Hello.
Hi, how are you today?
I gotta give it one of these. Great, I'm doing great. I'm so happy to be here.
Me too. We're really glad that you came here to talk about your work and to talk about diversity and inclusion and how that's affected by representation in media.
Absolutely. I mean, I think a big important part of that is if you don't see it, you can't be it. And so putting those things into our narrative work and films, which, you know, everybody finds the time to go see a good movie, as noted by Infinity War, and, you know, and to represent a huge portion of the, you know, population in that way. I think when people see it, they realize, like, I can do that. I can have those same goals in life because it's not going to be impossible. And I think that that's such a huge, important part of my work and my body of work over the last 3 years.
Yeah, one of the things I think about a lot is that I was really lucky growing up, wanting to be an engineer and seeing lots of engineers that looked like me. And that was inspiring, and I really want that for everyone.
Absolutely. I mean, I think inspiring the next generation of young scientists who are female, young kids of color, who see a world where they have a sense of pride, where they have a sense of, you know, reaching back and seeing their tradition and their culture and their ancestors and all those things, even being a part of their future. And I think walking away with a huge sense of themselves that they otherwise may not know or have had privy to, or so it's lifting spirits that's so important when it comes to representation. It's not only about getting into certain fields; it's about who we're raising in the world for the future, because I know I'm going to be relying on my young child to take care of me, and I want him to know some things. So, you know, it's always on my mind, and it's something that I think I'm now more than ever driven to do and include as part of my design aesthetic.
Yeah, it's almost like if you can see it, you can be it.
Absolutely. And I've been watching, you know, I watch all the videos on Twitter. People will send me stuff of teachers teaching about the sort of, you know, things that we did. You know, I did a deep dive, but it was sort of a lighter dive into the technology in Black Panther and the science in Black Panther. And teachers are coming up with a way to teach their class using Black Panther as an example of sort of our vibranium and our sound science that we use in the movie, and to see that becoming part of like a curriculum and kids getting excited about it because they see themselves and yeah, I can do this I mean, you can't ask for anything more. And so I've always thought, like, what can I do to better the world as one individual? And I didn't really know ever what that was until I think after Black Panther, and I saw the response of young kids, and it was all about the representation. And so, that does become a design choice, and it's something that I think that I'm just going to do now forever.
Let's talk about that a little bit more, because you're on record as saying that when you were working on Black Panther, you were just focusing on it being good,
yeah.
Right? But then afterwards, looking back on how big a deal this is for how many people, how has your perspective changed?
I mean, it hugely, because it was just, you're kind of in it, and you can't, like you were saying, see the forest through the trees. So you're just wanting to make sure it's good and it's right and that people are going to be happy and proud and that, you did the right thing, you made the right choices, because at the end of the day, it was a lot of responsibility in some aspects. So and then after when I saw it, I was like, I mean, my eyes were, because I did a little bit of the VFX, I was there for a little bit, but I didn't see the final edit. I saw one of the cuts. So when I was there in the theater with everybody else, I was blown away. I was like, this is insane. I can't believe I did this. and seeing the responses, it's just on another level. It's just, it's really hard to put into words or articulate in a way that others can understand, because it really is made me speechless in a sense. There hasn't been the words made yet to describe what that's like, but it was certainly always about making a good movie with a great story, and hopefully everything else sort of fell in line. And then we had other great filmmakers, Ruth Carter, who is Oscar-nominated costume designer, who I worked with really intensively to make sure that what we did matched up, because a lot of what she did in the foreground on the characters defined to the representation of powerful women who had their own agency about them and could make their own decisions and stand up for themselves and could think quick on their feet. That's a whole nother sense of representation and a social aspect for young kids, young girls, and the men who, treated them on this equal playing field. There was no like, oh, we need to make it easy for the girls. You saw the door fight. You saw the king treat them as if they were, when they were the most powerful, guards in Wakanda. So it's all of those things mixed together. Then you talk about the technology on top of that. You're giving a new generation, old generations, my generation, a whole another narrative than the one that we've sort of heard for the last how many ever decades.
Let's talk a little bit more about the technology, but not go away from the human aspects that you're talking about. And I think one of the things that's always really interested me in technology is not how to make tech just sort of better on its own, and then teach people how to use it, but rather teach technology how to be better for people. Absolutely. And I think that you've really captured in this film an intersection with culture and people and technology. How did you approach that?
Oh, that's heavy, man. Very carefully, because it's really trying to understand community, what the needs of community are, and then how do we envelop the technology, just what you said. And I know
Hi, welcome. I'm Mike, an engineering manager on the Google Play console. And I'm very happy to be here today to talk to you about a subject that's particularly important to my team and I. And that is enabling success on Android through safe, controlled, effective app releases. we know from yourselves, from our own experience, and the experience of other teams at Google, that releasing new apps and updates is what you might describe as an exciting time. It's the time when all that hard work the whole team has been putting in finally gets into the hands of your users. And that is an incredible feeling. Users are going to be delighted by your new functionality and improved performance. Business metrics are going to go through the roof, and everyone is going to be catching on to that good kind of excitement. In essence, for a good release, we need to delight users with new experiences. We need to maintain and improve those important business metrics. And of course, we need to get that tech right to deliver a stable, high-quality product. Simple, right? But releases, they also present us with some challenges. We need to keep our existing users happy. We need to make sure we're actually improving those key performance indicators. And of course, not introduce performance regressions or bugs. And if we do get this wrong, it can lead to an altogether different kind of excitement. A miscalculated release may result in crashes and bad user experience. And this can have a prompt and measurable impact. We crunched some numbers on the subject, and our data shows users are 26% more likely to give one-star reviews on the days when your app is at its crashiest. For games, this increases to a staggering 52% more one-star ratings. Similarly, in reviews, for reviews given on those crashiest days, users are 38% more likely to mention stability and bugs. And as you might expect, this is not just limited to ratings in the store. Key performance indicators are also affected. Engagement metrics and install numbers also suffer when your app is crashing. On top of all this, let's take a moment to think about the ecosystem in which we're operating here. At more than 2 billion active devices, Android is in fact the largest software and computing platform on the planet. Of course, this presents phenomenal opportunity for scale and reach to influence an incredibly large, diverse set of users. However, it also presents some unique challenges when it comes to software deployment. That incredible diversity in users also comes with unprecedented diversity in device types, with thousands of different makes and models across a variety of different form factors. And so, to have great releases and to keep with that good kind of excitement, we need to listen and validate functionality improvements by collecting feedback from a representative set of engaged, enthusiastic users. We need to measure to make sure we're having the right impact on those key user and business metrics. And we need to optimize that technology by detecting those bugs and stability issues. Not only this, but ideally, we want to do all this as early as possible. The sooner we catch problems, the better, be them bugs, usability issues, or business metric regressions. The sooner we catch problems, the more scalable our processes are, the more effective our teams can be, and the faster we can ship even more great features. And this is where the right tools and release process comes in. For the next part of this session, we'll walk you through the suite of tools that the Google Play Console makes available to help you handle this process confidently and effectively. We'll look at deploying your release to increasingly larger audiences and what you can hope to achieve at each phase to reach that ultimate goal of deploying a great new app or update to everybody. And after that, we'll welcome Radha from the Android System Health team to give us a deep dive on the Google app release process. We'll see how teams at Google, big and small, are making great use of these tools to scale their release processes. And so, to begin all that, I'd like to welcome on stage Serge, an engineer on the Play Console, to talk to us about the first phase of a release, testing.
Thanks, Mike. First, I'd like to do a show of hands. Who amongst you have published an app in the Play Console already? Wow. OK. And please keep your hands up if you also have been using the alpha and beta track for your app. All right. Well, you guys are great. I think you'll love this talk. Of course, for those who haven't yet published an app in the Play console, a track is a way to define a group of users to whom you can publish your app. For example, there's the production track, which targets all the over 2 billion Android users. And then there's the alpha and beta track, which targets a much smaller subset of users. Of course, before you publish your app to the world, testing your app with that small group of users is really important. This is for catching bugs, issues, but also to scale and move faster. Key to this is distributing your test version of your app to a small group of users. This could be either your wider team, product managers, our QA team, or whoever can provide you with early feedback. There's lots of ways to do that. One way would be to simply email APKs to your users. But that's quite cumbersome. And actually, that puts a lot of burden on their shoulders. While the alpha and beta track can be used for distributing test APKs, we heard from you that actually the alpha and beta track are too slow for that kind of fast, iterative testing. And this is because, as we'll see later, the alpha and beta track are designed for scale testing with potentially millions of users. And the APKs published to those tracks go through processing that can take several hours. To enable fast, iterative testing, we introduced the internal test track. The internal test track is a new track in the Play console that is designed to distribute test versions of your app to a small group of users within your organization. Let me show you how it works. Switching to the computer, here I have my test app that I created for this demo called IO Demo. And I have it here in the Play console. This is the app releases page. And we can see I have the production track, the beta track, the alpha track, and the new internal test track. You can see here I have version 49 already published in a release in this track. Version 49 here. I have one tester for this app, switching to the device. And you can see this. Can you see on the device? Very soon. Yes. So this is my tester's device. And you can see I have this IO Demo app in the launcher. When I open it, there's a single activity, and it shows the version code. I'm guessing that your app is a bit more sophisticated. If I go in the Play console, I can see that I don't have any updates. So the version code of my APK on my tester's device is the same one that is in the release that I rolled out in the internal test track. Now, Mike here just told me that actually my app doesn't conform with the official Google I/O branding for the color scheme. So I will go and fix this and quickly distribute an app to my tester. Going back to the computer. So I will go to Android Studio. Here in Android Studio, I have my project already open with my app. I also have installed the Gradle Play Publisher plugin, which is set up so that it automatically publishes to the Play console updates and builds I make of my app. I have a Gradle task here, the publish APK release, and when I invoke it, it automatically pushes to the internal test track a build of my app. So I will create a new version, version 50. And then I will change my color to, what was it again? Right, Space Pineapple. All right. So what will happen is that when I invoke this Gradle task, it will automatically build the APK and then upload it to the Play console to the internal test track. Once the upload completes, I will start a timer here. I have another device with a timer, and I set the timer to 2 hours. I hope you guys are not in a hurry. This is because this is how long you should expect it to take if I was to publish this APK to the alpha or beta track. Right? Then I will go to the Play Store on my tester's device, and I will check for an update. And as soon as the update is available, I will stop the timer, and we'll see how long it takes. All right. So I start the task. So let's switch to the device, please. So Android Studio is building the APK, and I started to upload it. Of course, I don't usually do this on a Wi-Fi network in a tent shared by 2,000 people, but hopefully it still works. All right, so now the upload has completed. If I go on my tester's device, or I start a timer, all right, I check for an update. Oh, my update is here already. So actually, that took less than 5 seconds. So if I update my app, it installs the update. I open it, and I have my new color scheme and with my new version code. This is dramatically faster than publishing to the alpha and beta track, as you can see. Actually, it's quite amazing. I've been advised against doing a live demo on stage at Google I/O with a real device, but you guys deserve it. All right. So we've seen how you can publish to the Play Console using a Gradle plugin in Android Studio. But of course, you can also use the Play Console UI to do just that. You can set up testers. Sorry. Careful slide. All right. So you can set up testers by specifying a list of email addresses. The testers opt in with a single URL. Then the testers use the Play Store app on the device to install and update your app. It's super simple for testers to set up. It works on any Android device with the Play Store, and there's no special app or permission. It's fast, safe, and simple. Sorry, there's 2 buttons here and 50% chance of missing it. All right. In order to get APKs out quickly, we distribute them to testers before the processing of the APK has completed. So although the publishing of the APKs is instant, the APKs and bundles published to the internal test track are still subject to play policies. The opt-in for internal testers is also different than from alpha beta. So users can be either alpha beta testers or internal testers. There's also a cap of 100 testers in the internal test track per app. The new internal test track is supported by the Play Console Publisher API and by many Play Console Publisher plugins. So that means that you can automate publishing to the internal test track very easily from your existing tool chains and workflows. You can get up and running with very little change. The internal test track is great for quick iteration during development, for catching bugs early, for getting fast feedback from your team, and also for testing Play integration. Because your app is published through Play, it supports all the Play features. LVL testing, in-app purchases, and most importantly, the new Android app bundle and dynamic delivery features. So if you're thinking of trying out those features, the internal test track is a great way to do that. Once you have your app tested internally with the internal test track, you're ready for real user. Although typically, you're not yet ready to open up to everyone. You might be looking for trusted feedback on maybe a confidential set of features. Closed testing allows you to scale up your testing while maintaining control of who can get your app. The alpha and beta track have been supporting closed testing for some time now. But we heard feedback that as your app scales, the alpha and beta track don't scale well with various testing scenarios. What if, for example, you would like to test your app with a track for each feature branch? Or what if you would like to create a new track for new events or milestones? Well, I'm delighted to announce that now you can create new additional closed testing tracks enabling all those scenarios. You now have one production track one open testing track, any number of closed testing tracks, and an internal test track. When you want to create an additional closed testing track, you can just click on the button, create closed track, choose any name you want. And that name is also used in the API. From our early adopters, we have seen that this is great for user studies, country-specific variants, per-team feature branches, and testing in incrementally larger groups, and just scratching the surface of how those new tracks can be used. For those who have been using the alpha and beta track, you may have heard of pre-launch report. It takes APKs that you publish to the Play console, and install them on 10 different unique devices in the test farms. It runs your app for 5 minutes at a time with Robo for nearly an hour of testing in total. It shows crash reports, performance issues, and security vulnerabilities. Pre-launch report also added new ways to control the crawl, like Robo scripts and demo loop for games. They are announcing exciting new features. Go see their awesome talk tomorrow at 9:30. Be sure to set an alarm for that. Or if you're like me, and you still wake up on a different time zone, you'll be set. As we've seen, closed testing is great for when you want to test your app with a set of trusted testers. But typically, the problem with those users is that they're not very representative of production users. Obviously, production users have a wider set of devices, but they might not be as motivated as trusted testers and might engage with a different set of features than your app. When you want to have broad coverage of your code, find technical issues, or get more relevant business metrics, you can use open testing. Releasing to open testing allows any user to discover and join your testing community directly from the Google Play Store app on their device. And these users can provide you private feedback that you can review in the Play console. And those feedbacks won't affect your public ratings. This is a great way to scale up and to make sure that the new version of your app provides a great experience to users before you launch it to the world. If you need to, you can also set a cap on the number of testers or of users that join that testing program to keep things manageable. Of course, open testing is only as valuable as users are willing to participate. Today, there are over 230 million users who already opted in open test, with 2.5 million users opting in each week. So it's really up to you to put it to good use. Late last year, we also introduced the new country targeting for testing tracks. With country targeting testing, you can now control the country availability for each track individually. This can be used for both open and closed testing, and allows you to run a test in a different set of countries to those in which a production app is live. We have seen some of the features Play provides to help you test your app. It's time to go to the next step in the release process. And for that, I'm going to hand it over to Nick, another engineer on the Play console, who will talk to you about rollouts.
Awesome. Thanks, Serge. So you've tested internally, then in closed groups, and finally, using open testing. You've polished the user experience, optimized those business metrics, and ironed out those bugs and performance issues. You're confident this new release has it all. The only thing left to do is roll it out to the public. Last I/O, we unveiled a new guided release flow for managing your release. Thank you for all the feedback you provided. Based on this input, we've further streamlined the process, making it faster to provide translated release notes and enhancing the APK upload process so you can drag and drop all your APKs into your release in a single step. We have also introduced support for instant apps, instant games, actions on Android, and the new Android App Bundle. In preparation for the new Android App Bundle, we've introduced a new UI to help you understand the contents of your APK or bundle. Even if you aren't using Android App Bundle, This provides useful insights into the sizes of your APKs. Keeping your APKs as small as possible means users can download and install faster and have more free space left for their photos and music. On average, apps will see a 20% size reduction by using Android App Bundle. And the Bundle Explorer can show you exactly the size saving you can achieve for your app. We recommend all developers use staged rollouts when rolling out to production. Staged rollouts allow you to control the percentage of users eligible to update and gradually increase this as your confidence in the release grows. In the unlikely event that something goes wrong, you can also halt the release while only a small percentage of users are affected. We're really happy to see that since introducing the new guided release flow, twice as many of you are making use of staged rollouts. Following on from this, we have extended staged rollouts with the new country-targeted rollout option. This allows you to roll out per country in addition to by percentage. This is really useful to start your release in a market that you have a deep understanding of, making it easier to understand your business metrics as the rollout progresses. Once your release is rolling out, you can use the release dashboard in the Play console to monitor key metrics such as update rates and app ratings, as well as crashes and ANRs. These metrics help you evaluate your release and ensure it remains healthy as you proceed with the rollout. The statistics view now shows release events, making it even easier to understand the impact of a rollout. For a more detailed view, you can use the Vitals page to check metrics like battery usage, jank, wake clock usage, and others. While we've introduced many exciting new features for releasing your app through the Play console, we know that many of you automate your APK deployment with continuous integration systems or using Gradle plugins, as Serge did earlier. So we've updated the publishing API, and from today, you can use these features in your automated workflows. Rolling out a release via the API now uses the same release model you're familiar with from the Play console. This allows you to name your release and more easily modify release notes. In addition, we've relaxed the constraints on what you can roll out via the API to match the Play console. The new testing tracks Serge mentioned earlier are, of course, also now supported by the API. This is great for configuring your continuous integration system to push to your internal test track whenever you have a new build ready for QA. The new release model also unlocks some features that were previously only available via the Play console. For instance, it's now possible to halt a release using the publishing API. This allows you to fully automate your release process, including automatically responding to problems. We've heard from many of you that while you are comfortable rolling out test builds via the API, you like the control of coming to the console when rolling out to production. So, with the updated API, we've added the ability to create and manage draft releases via the API. This means you can stage a draft release from your continuous integration system and then have your product manager log in, check everything looks good, and hit confirm and roll out. You can find the full details of the new API changes and the associated client libraries on our developer pages and GitHub. To round this session off, I would like to welcome Radha to the stage to tell us about how the tools we have looked at are put to use at Google.
Which way is... Hi, everyone. My name is Radha, and I run product operations for Android System Health. My team is responsible for making sure that all of Google's Android developers can build excellent apps quickly. I'm here to talk to you about some of the lessons we've learned in working with Google's many app developer teams, how we use some of the tools you've heard about today, and why we love them. Google has many Android apps. Some of them you may have heard about, like Gmail, Maps, YouTube, or Search, which serve billions of users. But we actually have over 150 apps, many of which are just starting out and have a few hundred or a few thousand users. Some of these apps have small developer teams, up to 10 people total, while others have hundreds or even thousands of Googlers working on them. In this room as well, there's probably a similar diversity in terms of how big teams are and how many users you serve. Smaller apps are looking for ways to scale rapidly to a growing user base, and larger apps are looking for ways to innovate safely and quickly. In working with Google's teams, we found that even this vast range of apps have a few things in common. Each of these apps is constantly evolving. Each is looking to add new and exciting features and adapt quickly to user feedback. And they would all rather avoid that bad update and all of the implications that we heard about earlier. What I'll be walking through today is how we've come to align on some common tools and best practices that scale from the smallest to the largest apps. So if we go back to our key points on releases, we need to make sure that we can listen to our users and the feedback they give us. We need to make sure we can maintain, validate, and improve the key user and business metrics. And we need to optimize the technology to avoid bugs and performance issues, and to support the incredible diversity of users and devices out there. How do we map this to Google? And how do we scale? And as teams grow in size and ambition, how do we continue to achieve good release attributes while still moving quickly? Well, we've developed some rules of the road for how we can do testing and app updates. Using the tools we've heard about today, we've developed a few strategies to create a consistent process that scales even to the deployment of our largest apps. I'll be going over some of the strategies that Google app developers are taking advantage of to test out new features and to release the next versions of their apps. First, let's take a look at testing. We used to test by always putting the raw, most bleeding edge features into our alpha track. This ensured that the team could stay in tune with each other and with the latest and greatest as we made progress. Unfortunately, as the team grew, this led to an issue that we called, "You did what to my VP demo?" Teams need to be able to move quickly, to experiment, and to occasionally break stuff. But product managers need fresh, at most a day old, stable builds to show off the latest features to executives and other stakeholders. We might need a stable binary, let's say to do an I/O demo, that has a lot of the new features. With more testing tracks, we're now able to give individual teams their own builds, so where they can experiment independently of each other and independently of the release process. They can deploy daily or even hourly if they wish, to share the latest features among themselves. We can also set the country availability of the testing tracks to global, to allow Googlers in any country to test our apps, even if the released product is not yet available globally. More tracks also allow us to have a more thorough testing process at release time. Thanks to individual team tracks, new features have already been tested independently even before we cut our release. Once we're ready to release, we promote our build through multiple stages of testing, starting with a team-wide test of tens of people, to a Google-wide test with thousands of users, and then a public open beta with potentially millions of test users. Our open betas allow external users to try our latest and greatest features if they're willing to give us private feedback on if they find they like it or if they find the ride is a little bumpy. At first, we imagined that we might have a hard time getting users to sign up for this, but users can join direct from the store listing in the Play Store app. And some of our apps now have millions of users in their open betas. With additional testing tracks at our disposal, more and more Google apps are setting up an open beta. This quote shows how the Google Search app is benefiting from the open beta program. It also highlights that testing is not just about mitigating the risk of bugs and crashes, but it's also a chance to get feedback on features and to ensure that the new features have the right impact on key performance indicators. You might be wondering what we get from all of these various stages of testing. Why not just go straight to open beta? Well, we might want to test out some confidential new features before they're visible to external users. Why do we have both a team-wide test and a Google-wide test? At Google, we have a tradition of dog-fooding our own products, and we'd rather not break Gmail for all Googlers in our tests. So why do we still need the open beta if we have so many Googlers testing? Well, it's because even if a Google-wide test can reach thousands of users, by and large, these users tend to have a somewhat narrow set of Android devices. An open beta gives us much more scale and a device set that is much more representative of our production users. So that's testing. We've validated our features and our app update. Let's move on to talk about how we actually roll out these updates and features to users. A staged rollout is critically important to Google Teams. Rather than updating 2 billion devices in one go, we always start small and ramp up incrementally, keeping a close eye on business, user, and crash metrics. At the first sign of any issues, we can always halt a release. But how do we actually manage these releases? One method we tried for managing an app release was to wait until all the features scheduled for that release were ready, then cut and roll out the release. This worked great at first, but unfortunately, features sometimes, just sometimes, hit a snag, causing delays to all the other features scheduled for the release. Soon the May release becomes the June release, and now you're pulling more and more features into that single release. More features means more testing, more bugs, more release candidates, more changes that make it hard to track down exactly what caused any particular bug or performance regression. And since the next release might be a while away, developers scramble to get their features on board the release train. And then, in the meantime, you discover you need to ship an urgent bug fix that just can't wait. And as you can see, as the team scales, this tends to spiral. Waiting for all features to be ready slows down innovation and adds a lot of risk to the app release. We found that, counterintuitively, faster is safer. Keeping a continuous and predictable release train makes each release smaller, safer, and easier to manage. Those urgent bug fixes can be sure to go out on time. And interestingly, knowing that the next release is only a few weeks away, developers tend to avoid cramming their almost but not quite finished features into a given release. So this is a great philosophy. But how does it work in practice? How do we keep the trains running on time? And how do we ensure that new features don't go live before they're ready? To get features out safely in an app release, we use a technique called flag-guarded feature development. Whenever possible, we try to avoid shipping new features directly with an app update. We put each feature behind a flag that can be toggled on and off from the server. First, we use the staged rollout to release the app update with all the flags turned off. By first deploying such a change-neutral binary, it's easier and safer to get this update to all 100% of our users. This also allows us to evaluate the application binary itself for things like stability and system health as it installs on the user's device, separately from the feature and how the feature is doing. Once this change-neutral app update is safely deployed, we can then slowly enable each feature by turning on the flags. Again, carefully keeping an eye on all of those important user, business, and crash metrics to detect any issues. If we find an issue, we always have the option to disable the feature by turning off the flag. Importantly, keeping these features behind flags and first deploying a change-neutral binary means that any issue with one feature won't adversely affect all the other features in the app update. I like to think of this as satellite deployment, not that I've ever actually deployed a satellite, but step one is to get the thing into orbit. Once it's safely in orbit, then you can unpack each instrument one by one. You can achieve this in your own app using Firebase Remote Config. The Google Search app is one of many Google teams that have scaled their release process and their feature launches using flag-guarded development. So you might be wondering how long releases take if we're going through each of these stages of testing and ramp up. Because the release train stays predictable, we're usually able to deliver most app updates to users within a couple of weeks, while having the ability to speed up a release if absolutely necessary. For the larger apps, the ones that have more than 1 billion users, we're able to collect enough data to have confidence in our releases within a couple of days. These release best practices help us keep each of our 150-plus apps at Google high quality without ever putting the brakes on how fast we can innovate and bring fresh and exciting features to our billions of users worldwide. So that was a tour through the Google release process. I hope you found this useful and that there's some ideas that you can put to use in your own release process. And I'd like to welcome Mike back on stage to close things off.
Thanks, Radha. So to recap, we've seen why releasing is an exciting time and how we like to think about what constitutes a great release. A release that delights users, improves business metrics, and is stable and performant. After this, we took a look through the suite of tools that the Google Play Console makes available to help you achieve efficient, well-understood, risk-free app releases. We looked at the new internal testing track for fast, iterative testing with your team and testers. We looked at closed testing, where you, the developer, get to control exactly who can test your app. We've seen how Google Play is going beyond alpha beta with additional closed testing tracks. And of course, open testing, where any user can opt in to test your app direct from the Google Play Store. We've seen how this can bring huge scale to your testing. We also looked at rolling out your releases with improvements to the Releases UI, improvements to stage rollout, and the new improved Publishing API for more automation of your release using Gradle and continuous integration tools. And we took a whirlwind tour through Google's approach to creating a consistent release process that scales from the smallest to the largest teams. We hope you found this talk useful. Please do give these tools a go and let us know what you think. We look forward to hearing your feedback as you use these tools more and more. If you'd like to share your experiences, or you have thoughts or ideas on how we could make these tools even better, please do come and see us in the Android and Play Sandbox in Dome C. Thank you.
Thank you for joining this session. Brand ambassadors will assist with directing you through.
If Denis Villeneuve is listening, I'd love to do Dune.
Yes.
I throw that out every opportunity I can get. Denis?
Yes. Hannah, thank you so much for joining me and sharing your story and all the work that you do.
Thank you so much. It's super exciting. I'm so happy to be here, and I think I'm going to learn something today, too. So, you know, it's all about soaking in all this greatness. So, fabulous. Thank you.
Thank you. I'm Timothy Jordan, and this is I/O Live.
All the way up now.
I can't imagine how anybody passes a problem that they know that they can fix and doesn't try to fix it. That's not some complicated thing. It's just stop talking about it and start doing it. I feel an absolute obligation to serve. I did 2 tours in Iraq as a helicopter pilot. I loved being part of the cavalry. But then I got injured, and that caused me to lose my ability to fly. One day you're a soldier, and then overnight they rip off that tag and slap veteran on your chest. I didn't know where to start looking for the next thing. What I do is math and engineering, so I had to find a way to apply those things in a meaningful way. Service doesn't end when you get out of the military, it just changes. And I started reading about the research that they were doing at the Human Engineering Research Lab. And I thought, man, I gotta go be a part of that. HURL's mission is to help people with disabilities increase independence and quality of life. I prepare the software to support the research that we do. One of the big things that I've done is help us transition to using Android tools. They make things really accessible. Anybody can sit down and start using these technologies and perform the tasks that we hope that it'll be useful for. That's the right thing to do, is to make things not just able to be used, but to be used with the same sort of joy or ease as I do. A big part of why open technology is so attractive to engineers like myself is there's such an active community of people designing and innovating.
Welcome to Pittsburgh.
All 3 of my children have a disability. The fact that my son has autism is just one little part of him, but almost his entire existence is defined by that autism. There was part of me that hoped someday I'd be able to help my son be able to live independently and give him a future. That's part of why I became an engineer, it's part of why I got into this field. There's going to be a time where someone like my son will have gotten a better opportunity, a better swing at this thing. I'm not going to sit around and wait for somebody else to fix the problem. There's not a minute to be wasted thinking about anything but the good things that we can do.
everybody. Wow, it's a nice stage. OK, poverty and inequality. I think it's hard to say they're related or it's causal or correlated, but there's something connected that we cannot miss. And that is that if you don't have access to computation, you are excluded. And if you don't understand what it can do, you're excluded. And so technology keeps shooting off without them, us. So what's the solution? I'm passionate about remote work. I'm at a company that is all remote, automatic. Who works remotely? That's quite a few. So remote work is neat because it takes you out of these bubbles of tech. I guess I'm hopeful that at Automattic, we're trying to figure out a world where WordPress is a good design for all. How do we do that? We have to use the fact that we can go anywhere because we're remote. So for instance, let's see, I was visiting Appalachia. And in Appalachia, I heard the story about how it was a coal miner who's teaching code to ex-coal miners. And he said, you know, you people are from the three-dimensional world. You're 3D. You live in cities with skyscrapers, you know, and if you're from a smaller city, you're in a town, you live in 2D. In 2D, you have like no skyscrapers, just streets. And he said, here in Appalachia, we live in 1D. There's one street, and we all live off of it. That's where I realized the neat thing about remote work is you're zero-dimensional. And by being zero-dimensional, you can travel anywhere. And so we're trying to use this advantage to go into all kinds of places, anywhere in the world, and to connect with people. And I can tell you that this experience of being remote is a very powerful way to reduce exclusion, because you can be including by just going anywhere you think is necessary. Now, this is my favorite quote by the lawyer Vernay Myers. Diversity is being invited to the party. Inclusion is being asked to dance. Say this over to yourself. It's such a powerful idea, because if you don't have both, nothing occurs. And so when you ask how to be more inclusive, it's quite easy. Just ask, where do you spend your time? Who do you hang out with? Look at the people in the room around you. Are they diverse in some way? If they're not, you're going to have to do something terrible to yourself. You're going to have to make yourself uncomfortable. And it's exciting to be uncomfortable. Oh my gosh, you say the dumbest things. And you stumble, and you become stupid, and you become smarter and a better person through it, I believe. So all of you who are not found yourself in this way, enjoy it. It's so exciting. I'm a big entertainment fan, and I've been tracking all the movies that have put diversity and inclusion at the center of them, and they're doing very well financially. Movies like Wonder Woman, directed by Patty Jenkins. Star Wars had a much more diverse cast. The Foreigner by Jackie Chan. Who's seen The Foreigner? The Foreigner, where the terrorists aren't dark-skinned people. That was brand new. And The Big Sick, of course. And these are doing really well financially. This is teaching machine intelligence and the business world that this is a pattern to take note of. I like Kumail Nanjiani's quote, there's so many movies from different points of view that are making a ton of money. Don't do it because it's better for society and representation, even though it is. Do it because you'll get rich. You'll get that promotion, right? This thinking seems crass, yet it sits at the center of how change will start to occur. And I believe that as we see more of these kinds of things, wonderful things will happen. I want to close on, my mother went to see Black Panther. This was her review. It went kind of viral. Hi, John. Just came back from seeing Black Panther. It was very good. And we actually went to see Avengers last, me and my mom. I was in Seattle. My mom's like 83 years old. She's like, you know, little woman with a cane. You know, we're walking out of Avengers. And I said, Mom, how was it? Oh, it wasn't as good as Black Panther. You know? So anyways, thank you. And we'll have Hannah next, so please stay seated.
This is nuts. Look at all the faces.
Wow, I'm so happy. I get to interview Hannah Beachler. Yes.
Yeah, all right. Hey, y'all. Good to be here. This thing is a little weird, so you might see me kind of being a little weird.
So how's it been walking around this area?
I'm sorry?
How's it been walking around?
Cool.
Wandering
We
around,
went,
looking around?
hung out at the auditorium, and walked around some of the tents, and ate, and sat on the grass, and it was fabulous.
Anything catch your attention?
I mean, I was just looking at everything. The area is beautiful, and I think everything has been great. I've been talking to some great people, and it's been awesome.
Hmm. So, my mother loved Black Panther. I'm sure you weren't surprised, though.
What? I'm sorry?
I'm sure you weren't surprised.
That your mother loved it?
Yeah.
Not really.
82 years old.
You know, honestly, that was part of what we tried to do was, you know, make it so everybody could love it. It wasn't really geared towards one specific anything. It was more about creating a feeling and a moment, and you know what I mean? I'm pretty into my emotions. I would call myself an emotionalist, if you will. And that's really what drives me is, you know, creating things from a place that people can relate to. And then that, you know, expands.
Had you heard of Black Panther when you got the job? Or?
Yes, I did. I had heard of the character and the comics, and I kind of knew it because I knew Marvel. I've certainly asked my son, who's 20, right away when I knew I was going to interview for the job that, you know, tell me all about, you know, the MCU and all of that. And he was like, here's a Marvel dictionary, and I sort of started from there. So I knew of him, but over that 14 months, I really got to know him.
So a superhero.
Superhero.
Was your reaction positive, yay, superhero, or superhero?
My reaction to it being superhero?
Yes.
I mean, I was really super excited because it was challenging. It's, you know, I've done so many things that are so different from each other that anything that is going to challenge me, I instantly want in on, you know. And working with Ryan Coogler, the amazing director, again for the third time, was, you know, without question, I was going to be involved with that. So I never thought I would ever do something like a superhero movie. That's not where I saw my career going. That's not what I thought I wanted to do. But then that's life. It's not really what you think in the beginning. But as, you know, I started to get into it, I was like, you know, why not? I didn't think I would do a boxing movie. I didn't think I would work with Beyonce. I didn't think I would, you know, work on a little $1 million movie that would win an Oscar. So I don't generally go into anything thinking anything other than how do I make this work? How do I make this the best it can be? And, you know, for each film, it's something different. So for Panther, there was a reason behind it for Ryan and I, and same with all the other projects.
So you had to look 1,000 years in the future. And you didn't come to Silicon Valley to look at that future.
No.
Talk about that.
Well, first I had to look 1,000 years in the past. That was a big part of Wakanda, was the honoring of the culture and the tradition and the diaspora, the African diaspora, that really is what Wakanda is representational of. So I had to look backwards because I think the past is a very important bridge to what the future is. And that needs to inclusion in design, in this world of what I was doing for Black Panther. Looking into the future, I didn't know, and you know what, honestly, I didn't know that Silicon Valley could help me for my needs. I didn't think that I was going to find in there, and honestly, I didn't really know much about it. I live in New Orleans. It's a very small town. I don't live in Los Angeles. I don't live in New York. I live in a place where the population is like 250,000 to 300,000 people. You know, I didn't know much about Silicon Valley. I kind of knew what I saw on TV. Sounds familiar. But I didn't really know how that could help me create this technology, which you would think was kind of crazy. Because what I knew I needed to do was evolve something that Silicon Valley, to me, I felt had no interest in, which is this culture. So there was, you know what I mean? I felt like I kind of had to give an autonomy and to this story and a narrative that at times is restricted just in general by society, like the ability to tell communities' ability to tell their own story, how they want it told, and based on what they want it based on. So that was sort of me kind of being the person who made sure that the representation of the culture that we were digging into and creating a fictional one on top of it stayed to what I needed it to be. And I didn't know that Silicon Valley could help me. Now, I did reach out to a lot of experts about all kinds of stuff, geology, geography, archaeology. We talked to experts in architecture who were doing future cities, people who were sort of architectural archaeologists that could talk to us about some of the architecture, pre-colonial sub-Saharan Africa, and then of course going to South Africa, traveling all over South Africa for 3 weeks and sort of understanding that, because at the heart of Black Panther was the question of what is it to be African, and so that's sort of why I felt like I didn't want to go or need to go to Silicon Valley. I don't know if that is like, and I mean, that's honest. That's the honest truth. And because I was so busy, I was like, I'm just going to have to do this. I'm just going to have to figure this one out. And I didn't really know. 1,000 years into the future, here's the thing. It's hard enough to go any amount into the future and understand what you think might happen or how people would respond. So I found myself getting to this place where I started thinking about technology in the future, how Wakanda would use technology. Technically, Black Panther is placed in 2018. It's not sci-fi. It felt sci-fi because Wakanda, you know what I mean? We have to remember it's not science fiction. It's supposed to live in this universe, which is 2018. So I had to make sure it felt grounded enough that people weren't like, it's space. But it also had to be advanced enough where people thought, maybe this is something that's going to come around in 50 years, 60 years or something. It's not impossible, and then you had to add sort of with the vibranium, the fantasy of it all. So, and I'm rambling, so I don't even know if I answered the question, but, that's sort of, I might have lost myself on that.
Actually, when you were describing that, I remember walking my mom out of the theater because she can't walk very well because she has diabetes and her feet are really, makes it hard. So she's walking really slowly and talking really slowly. And I remember when we just left the theater, she said, Black Panther was so beautiful. All the scenery, everything was so beautiful. And it's a thing that stuck with her, how beautiful the movie is. And it's optimistic. And so where did that come from and how you were able to translate that?
I mean, I like to do things that are beautiful, and I think that's another part of Black Panther is changing this idea of narrative of how we see things. It was a challenge to me of how I saw Africa, what I thought about Africa. Just because I'm Black doesn't mean I'm an expert on African culture, right? So I really had to dig in and challenge myself about like, okay, well, what do I think? What are my biases? What was I raised with? From my American experience, this is a land that's 1,000 miles away, and as far as I know, my ancestry begins and ends at slavery, and then the culture that came afterwards was this bastardized idea, or we were told it was a bastardized culture. We're not African, we're not American, so it became this bastardized culture in a sense, right? And you go through all of these different points in time throughout American history. So I needed to rediscover like what that was, thousands of miles away from where I live, and how I'm connected to that, because oftentimes you feel like the hyphenate between the African and American. You're really not either one. So it was, what is it to be African? Because this is a movie, Wakanda's African, and it's not African American. And, one of the little things that Ryan was so brilliant at doing in the film with Killmonger's character, who's the villain, if you haven't seen it, Has everybody seen Black Panther? Is that a thing? Awesome. So Killmonger, played by the fabulous Michael B. Jordan, if you notice something about him is his names. And part of the reason behind him having so many names is because, you know, our American ancestry is that we have been given so many names. We were Negroes, we were black folk, we were colored, we were Afro-American, we were African-American. And that's sort of how this has gone over time. So what Ryan did was he gave Michael Jordan the Ndjidaka name, but they also called him Eric. They also called him Killmonger. They also called him Eric Stevens. So he's that representation of African American, never having a true identity. From different places and different people called him different things. And that's the tie back, and those are the types of things that we were trying to do. That is a piece of representation in a sense, and we'll get to representation because I think that's mostly what we want to be talking about is how that is so important in Black Panther.
Right.
You know, technologically, scientifically, you know, through your STEM, and then also socially and economically. And so there's so many little things that we did in there. I mean, it goes so deep into how we brought in the representation, and that was one of them. And it was in such a small story way that you don't even really realize that's what's happening, because Shuri calls him Eric Stevens, T'Challa calls him Ndjidaka, his father calls him, you know, Ross calls him Killmonger, his father calls him Eric, you know. Wow. So it's, he doesn't have an identity, and he's going to Wakanda to try to figure that out. And that's sort of the representation of where we are as sort of the lost tribe, as we called it. I'm
such a Ryan Coogler fan, so I'm like, I can see that detail. I didn't see it.
Small
when you
detail.
described it. When we were talking last week about representation,
yes,
you mentioned the production designer Wynn Thomas, and I looked up Wynn Thomas. I hadn't heard his name before. And he has credits for Hidden Figures, A Beautiful Mind, Analyze This, all of Spike Lee's movies. So you mentioned seeing him on television or something?
I saw he was nominated for an Academy Award for Mars Attack, the Tim Burton film. And I happened to be watching the Academy Awards that year, and I was like, oh, who's this black man doing this thing that I want to do? And that was really the first time that I really saw that. I was like, oh my goodness, what is this? Because I'd always been a big fan of Bernardo Bertolucci, who is an Italian director, back in the 50s, 60s, 70s, and 80s. And his designer, Fernando Scarfiotti, was someone who was really a big influence to me. He was this Italian man way back when, but my design aesthetic, you know, is highly influenced by his. But seeing him never made me feel like, yeah, I can do that, because he's this Italian guy. You know what I mean? Like, of course he can. He's an Italian guy. Like, I'm this farm girl from Ohio, you know, who literally runs around with bare feet and riding my horse to the store to get Jolly Ranchers when I was like 6. Like, how do I get to that?
Right.
How do I get, there's no path for me there. So I kind of started thinking, like, what are some of the other things that I could do where there might be a path that's still creative, and that's how I had to think, knowing that that wasn't something that was for me. But then when I saw Win, which was much later in my life, that's when I realized, like, you know what, I can actually go for this. I mean, that didn't actually mean that I could go for it, but seeing it certainly made me feel that way. And I took that chance, and that gave me an opportunity to get into this industry and really go far. I mean, as I got into it, I realized, like, oh, this is really hard. I'm the only one. And I am the only one. And that's a really strange thing, to think that you are the only black female who does this, who does what I do. And at this level. You know, there's one other one, Toni Barton, you know, and she's an art director working on television for Marvel. And I kind of saw her on Twitter, and I was like, you know, like, let's be friends. And she's like, I don't even know you. And I'm like stalking her on Twitter, like, I want to be girlfriends. And she's like, okay, maybe call my agent. Maybe don't. But we finally kind of, like, I broke her down, and she finally decided to be my friend. And we're kind of besties. Don't quote me. And don't go up to her and be like, Hannah said you were besties, because she'll be like, I don't know who she is. But that's, you want to find likeness. You want to find relatability. And when you look at communities, I think, one of the other things, too, is when you look at communities who are associated with not like having a lot of tech and not, having access to a lot of tech, and you start relating, your economic status to your racial profile, that all of a sudden, especially in poverty, the Black community becomes associated with this idea of not being tech savvy or wanting tech or having that type of thing. Do you know what I mean? Within their community, and it's basically all based on accessibility. It's not there because how many representation is not just in front of whatever it is, or like throwing the pretty on it that seems to be representing a group or a culture, but actually having the voices creating it. Is it how, you look at it like, was it important for me to be the production designer on something like Black Panther? Or the Infinity Wars designer Charles Woods, would he be able to have then done that? And so I do believe that the representation behind the camera, I'll say, because that's what I do. I mean, behind the desk, I don't, you guys stand, or I don't, I don't, you know what I'm saying? Or however it goes, is as important as creating an app or creating something, specifically as having the voices there that then has the experience in those communities. Because you really don't know what you don't know, and that's what I learned by going to Africa. Like, I don't know what I don't know, but I knew that I was going to look at it with beauty. I knew I was going to look at it with the lens of absolute modernism and beauty and capability, all the things that I wanted to put into Panther. Like, I wasn't looking for the commercial with the poverty-stricken children. I wasn't looking for the things that we're told the continent is. I was looking for the joy and the pride and the dignity of the people that lived there. And, that's the choice we make for wherever we are, because I met people who lived in the rural parts of Africa just as much as people lived in the modern cities like Johannesburg and we were in Durban, we were in Cape Town. So it's you could see someone dressed in their traditional Zulu or traditional Xhosa and in the city. Just as much as you might see that in the rural areas. So I decided not only to find myself and realize that I think I've been African this entire time, but that I was determined to find all the beautiful things that I, was told weren't there, because that then really came back to who I am as a person. You know what I mean? It really related back to who I am and how I felt about myself and the confidences I had. So it all kind of like, our fictional world building bleeds back into our realities.
We have 2 minutes left. Could you share a nonfiction story you shared with me that moved me very much, which was about the director Ryan Coogler, who I'm a huge fan of. And I've always, when in Silicon Valley we talk about leadership, CEO, or the product manager is the CEO of the product, and all these CEO-ish things. I think of Ryan Coogler as one of the great CEOs of our time and creatives. You shared a story about him. Could you talk about
when
that?
I was talking to myself?
Yes.
So you obviously know I'm kind of weird, so I'm going to tell this story. Don't hold it against me. But so we're working on Creed, and we're tech scouting, which is we go to look at all these locations, and you can spend all day. And we had stopped at this coffee shop. And I got my coffee, and everybody was getting their coffee, but I was kind of working out a problem. And when I'm trying to work out a problem or solve a problem, I talk out loud to myself, because that's the best way to do it, for me, apparently. And, my friends and stuff were like, poke fun at me, like, oh, you're crazy, you're talking to yourself. And so, sometimes I do, and I don't even know I'm doing it. So Ryan comes walking over to me, and he was like, are you talking to yourself? And I was like, a little like, oh, you know what I mean? I know you and love you, but yeah. And the first thing he said, he looked at me and he said, that's a sign of a really healthy mind and a really intelligent person. And he kind of turned around and walked away. And I was kind of like ready to get the hit of like, oh, you're crazy, you know, kind of funny joke, but a little bit like of a slight. And that's not at all where his mind came from. It looked for the immediate positive thing about the thing that I was doing that sometimes people think is weird or could make you feel a certain way about yourself that eventually starts beating you down and making, you know, defining who you are because you're hearing negative things about it. That is who Ryan is. He's the person that will constantly lift people up, you know, will constantly, and he's not perfect, I promise. There's days when I'm like, please make a decision. You have like 2 hours. But, you know, and he does all the things that directors do that can, you know, completely bother you or things that are like amazing. But he's the type of person, like we would be on set for Warrior Falls, which was the big waterfall where they had the big fight. And he gathered us all around in a big circle. You know, some people were in the water, and he really told us why that scene was important. This is before we even started shooting. He really started to say why that scene was important to him, and really talked about having all the fictional tribes of Wakanda in one place and represented by all the references that we use of the tribes, the different tribes in sub-Saharan Africa, and how that was a big part of him really feeling complete. And you know, you were holding hands and he's telling us all this and we're standing in this circle and you just feel like you can take on the entire world, you know, at that point. So that's who he is as a director and my friend. And he's a really important voice because his perspective on anything and everything is the most unique perspective you will, I promise you, ever hear from anybody. If you ever get a chance to talk to him because he will turn a situation and make you see it from a side you were never maybe even meant to see it from, and all of a sudden your world opens up. And so I can always, and he would be standing here going like, oh, please stop, but but he is really that great, so.
Well, thanks for sharing that story. What a leader and what a designer. Thank you, everyone. Thank you.
Welcome to Google I/O. For someone like me who grew up without a phone, I can distinctly remember how gaining access to technology can make a difference in your lives. That's why we've been so focused on bringing digital skills to communities around the world. We have trained over 25 million people, and we expect that number to rise over 60 million in the next 5 years. Healthcare is one of the most important fields AI is going to transform. We announced our work on diabetic retinopathy, and we use deep learning to help doctors diagnose it. We can predict the 5-year risk of you having an adverse cardiovascular event, heart attack or strokes. We've been working with our partners using de-identified medical records. It turns out if you go and analyze over 100,000 data points per patient, more than any single doctor could analyze, we can actually quantitatively predict the chance of readmission 24 to 48 hours earlier than traditional methods. It gives doctors more time to act. This is for you as you type. All you need to do is to hit tab and keep auto-completing. Another product is Google Photos. So we are bringing a new feature. If you took a picture of a document which you want to save for later, we can recognize, convert the document to PDF, and make it much easier for you to use later. Or if you happen to have a very special memory, something in black and white, we can recreate that moment in color and make that moment even more real and special. And we are adding, as of today, 6 new voices to the Google Assistant. John Legend's voice will be coming later this year so that you can get responses like
I/O keynote. Then at 1 p.m. you have margaritas. Have a wonderful day.
I'm looking forward to 1 p.m.
Today, the Assistant is available on over 500 million devices. Now, by the end of this year, the Assistant will support 30 languages and be available in 80 countries. But one step that we've been working on is something we call Pretty Please.
Hey Google, talk to VoiceTron.
Daddy, you forgot to say please. Tell me a story, please.
Thanks for asking so nicely. You're very polite.
I know.
So the assistant understands and responds to positive conversation with polite reinforcement.
Now, sometimes the assistant can actually be more helpful by having a lower visual profile. So let's say I'm heading home from work. I have Google Maps showing me the fastest route during rush hour traffic. Hey Google, send Nick my ETA and play some hip-hop.
Okay, letting Nick know you're 20 minutes away and check out this hip-hop music station on YouTube.
Let's say you want to ask Google to make you a haircut appointment. So what you're going to hear is the Google Assistant actually calling a real salon to schedule the appointment for you.
So how can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd.
Sure, give me 1 second.
Mm-hmm.
That was a real call you just heard. The amazing thing is the assistant can actually understand the nuances of conversation. We've been working on this technology for many years. It's called Google Duplex. It brings together all our investments over the years in natural language understanding, deep learning, text-to-speech. I'm really excited to announce the new Google News.
With the new Google News, we set out to help you do 3 things. First, keep up with the news you care about. Second, understand the full story. And finally, enjoy and support the sources you love. Our AI constantly reads the fire hose of the web for you, the millions of articles, videos, podcasts, and comments being published every minute and assembles the key things you need to know. We're also excited to introduce a new visual format we call newscasts. You are not going to see these in any other news app. Newscasts give me an easy way to get the basics and decide where I want to dive in more deeply. Full coverage is an invitation to learn more. It gives a complete picture of a story in terms of how it's being reported from a variety of sources and in a variety of formats. This is by far the most powerful feature of the app. And here in the newsstand section, it's easy to find and follow the sources I already love and browse and discover new ones. And if there's a publication I want to subscribe to, we make it dead simple. Because you're signed in with your Google account, you're set. We're rolling out on Android, iOS, and the web in 127 countries starting today.
Growth of Android over the last 10 years has helped fuel the shift in computing from desktop to mobile. And as Sundar mentioned, AI is going to profoundly change industries. And this brings me to the new version of Android we're working on, Android P. Adaptive Battery uses on-device machine learning to figure out which apps you'll use in the next few hours and which you won't use until later, if at all, today. With Android P, we're going beyond simply predicting the next app to launch to predicting the next action you want to take. We call this feature App Actions. What's happening here is that the actions are being predicted based on my usage patterns. The phone is adapting to me and trying to help me get to my next task more quickly. Slices are a new API for developers to define interactive snippets of the face detection, image labeling, and a lot more. And MLKit also supports the ability to tap into Google's cloud-based ML technologies.
Our team has heard so many stories from people who are trying to find the right balance with technology. One of the first things we focused on was helping you understand your habits. Android P will show you a dashboard of how you're spending time on your device. As you saw earlier, you can see how much time you spent in apps, how many times you've unlocked your device today, and how many notifications you've received. Android P lets you set time limits on apps and will nudge you when you're close to your limit that it's time to do something else. If you turn your phone over on the table, it automatically enters Do Not Disturb, so you can focus on being present. No pings, vibrations, or other distractions. You can tell the Google Assistant what time you aim to go to bed, and when that time arrives, it will switch on Do Not Disturb and fade the screen to grayscale, which is far less stimulating for the brain and can help you set the phone down. Well, today, we're announcing Android P Beta.
Maps was built to assist everyone,
We've mapped over 220 countries and territories and put hundreds of millions of businesses and places on the map. We're adding a new tab to Maps called For You. It's designed to tell you what you need to know about the neighborhoods you care about, new places that are opening, what's trending now, and personal recommendations. We've created a score called Your Match to help you find more places that you'll love. Your Match uses machine learning to combine what Google knows about hundreds of millions of places with the information that I've added.
Let me paint a familiar picture. Your phone says, head south on Market Street. One problem, you have no idea which way is south. So you look down at the phone, you're looking at that blue dot on the map, and you're starting to walk to see if it's moving in the same direction. Our teams have been working really hard to combine the power of the camera, the computer vision, with Street View and Maps to reimagine walking navigation. So here's how it could look like in Google Maps. Notice that you also see the map, so that way you stay oriented. You can start to see nearby places, so you see what's around you. Now, with smart text selection, you can now connect the words you see with the answers and actions you need. So you can do things like copy and paste from the real world directly into your phone. You're at your friend's place, you check out this trendy-looking lamp, and you want to know things that match that style. And now Lens can help you. You open the camera, and you start to see Lens surface proactively all the information instantly. And it even anchors that information to the things that you see.
Waymo is the only company in the world with a fleet of fully self-driving cars with no one in the driver's seat on public roads. So Phoenix will be the first stop for Waymo's driverless transportation service, which is launching later this year. Soon, everyone will be able to call Waymo using our app, and a fully self-driving car will pull up with no one in the driver's seat to whisk them away to their destination.
Hi, IO Live, it's Todd Kerpelman, and I am here with Asad Naweed, who is a software engineer on ARCore. So, Asad, what's new in the world of augmented reality?
Hi, Todd. So today at I/O, we're announcing 2 new features in ARCore that we're really excited about. We are announcing augmented images and cloud anchors.
Okay, those sound very impressive, but what are they? What's augmented images?
So augmented images is a set of APIs inside ARCore that allow developers to create AR apps that can recognize images in the real world and then anchor virtual content with respect to them. So if your app can recognize an image, let's say this portrait up here, then it can make that image come to life and overlay virtual content on top of that image and make it do interesting things that weren't possible before.
So what kind of apps do you see taking advantage of augmented images?
One other thing that I'm really passionate about is education. And children's education in particular, you could create an app that recognizes the images in a children's storybook. And if kids previously, when they're just reading a storybook, can now point their cell phones at the storybook and then see the story come to life on top of their books, right there and then.
Alrighty, let's check out one of these demos here.
Yeah, so this is augmented images. And we'll see that ARCore finds this image and then makes it come to life like that.
Whoa!
So this is what I was talking about when I meant immersive experiences, is that as we move the phone slightly at an angle, we see that the 3D model actually turns with us. And if we end up going a little closer, we'll see that the effect is much more pronounced. You can actually take a look at the structure of the cubes as they are there, and it's so much more immersive than the standard 2D painting because now you have this box that's reaching into the wall and the image is no longer there, and it's actually been superimposed by this 3D model that's dynamic and can move, and I can get different perspectives on it depending on where I am. So yeah, that's what's really exciting about this.
And is this a phone with any special hardware, any special features? What is this that we're looking at this on?
So this is just a phone that's running ARCore, and ARCore doesn't have any specific hardware requirements, short of maybe just like a good camera and a good gyroscope and accelerometer, but that's about it.
All right, and here we have another augmented image. Let's see what's going on here.
Yep, so this is another image that the app knows how to recognize. And now that it's done that, we can see what grows as we move the phone up. And this then grows into like a massive tree that an artist has put together that's rooted at the augmented image. So if you keep going all the way up, you'll see that it becomes like a really, really, really nice tree. And as you bring the phone down, the tree will ultimately sink back into the augmented image that it detected. So these are the kinds of visual experiences and like things that come to life rooted at images that the app knows how to recognize. And that's what we're really excited to see what developers are going to do with.
Wow, that is super cool. I could actually just stay here all day and watch the tree grow and shrink, but I think I have other interviews to do.
No, you're more than welcome to come back when you're done.
All right. Well, if you need me, folks, I'll be hanging out here making augmented reality trees grow. And then the second piece of technology we were talking about were cloud anchors. So what is that, and what does that allow me to do as the developer?
Cloud anchors allow you to create and host anchors, AR anchors, and share them between different people and different devices. And that's really exciting because then suddenly you have the ability to create apps that two people can use together to anchor content in the world and see where other people have anchored content in the world as well. One other thing that we're really excited about is that the cloud anchors are actually cross-platform. We're also really excited to announce that anchors created on AR Core devices will also be recreatable on iOS devices running AR Core on iOS. And that opens up the door to so many different possibilities and a significantly larger user base. So now iOS developers can also use AR Core cloud anchors.
All right. So basically, we are setting up a multiplayer game where both devices, an iOS and an Android device, are agreeing on the same augmented reality space that they're sharing. Is that basically what's going on here?
Yes, that's exactly what's going on here, Todd. I have in my hand an iPhone that's running AR Core on iOS. And Brian has an Android device, and we are going to play the same game together. And
all right, let's give this a try here.
That you can see right there is where Brian has placed his board, and I will place mine here. And when I am ready, we are now going to play a game where I have to fire onto Brian's light board. And when I do that, it effectively lights Brian's board up. And then he has to color all of my shots, all of my dots before I manage to do the same thing for him. And he is seeing these boards in the exact same place that I am seeing them in. And I can see him playing the game with me, and the only reason why this shared AR experience is possible is because of the magic of cloud anchors. So yeah, just to kind of like reiterate, this is an iPhone, it's not an Android device, and we do have AR Core cloud anchors supported on both iOS devices and Android devices, and we're really excited to see what developers are going to do with this.
That is super awesome. I can't wait to play some really fun augmented reality multiplayer games around my living room.
Well, definitely, and yeah, it's a blast for everyone, like the whole family, yeah.
Oh my gosh, that was super cool. If you want to see more exciting videos like this one, head on over to g.co/io/guide for lots more videos featuring me and the rest of the IO Live crew.
he doesn't even like science fiction, so it's impossible to find an analogy that he even understands.
All right. Well, today, in this talk, we're going to go through where we're at with web components and the Polymer library.
And then we're going to cover where we're taking the Polymer project in the future.
And then finally, we're going to talk about where we're going to help evolve the web platform forward to make it even better for us developers.
All right, so let's talk a bit about web components and Polymer. The Polymer project started as an experiment to embed web developers right inside the Chrome team. And the goal was to tighten the feedback loop between developers building on the web and engineers implementing the browsers.
So the experiment turned into a full-fledged project focused on identifying developer needs and participating in the standards process to address those needs and bring them to the browser. We also produced polyfills and libraries to encourage the use of these new features, all with the goal of driving the web platform forward to make it more capable for us developers so that we can all deliver better experiences to our users.
This all started almost 6 years ago now, when Alex Komorowski and Dmitry Glazkov got up here at Google I/O in 2012, and they talked about how web development at that time was really difficult. It was overwhelming how much developers had to work around the limitations in the platform and write a lot of code for really basic concepts like breaking down your application into components.
They did this whole shtick about how they were these engineers coming back from the future. And they were coming back to report that all these problems were solved and that the web platform had become a really awesome, capable platform for building applications. They told us about these new things called web components, native web platform APIs that help us create components for structuring our applications and building reusable widgets. And the components were built on a handful of new features in the browser.
The first feature they told us about was custom elements, which let us extend HTML and make our own elements work the same way that the browser's built-in ones do, like inputs and buttons. And this meant custom elements would work anywhere the web works, regardless of how you're building your app.
Next, Shadow DOM let custom elements hide their rendering so that you could create complex UI in a component that was fully encapsulated, including its styling. So you no longer had to contend with this global soup of CSS and come up with conventions on your team to avoid stomping on each other's selectors, that sort of thing.
And last, they proposed a new way to load those custom element definitions called HTML imports. And the rendering for your component would just be described declaratively in HTML and then loaded and parsed natively by the browser.
Dmitry and Alex put all of these things together into this awesome story about an amazing future where you could mix and match components from different authors on the same page. And this was because the rules for coordination were no longer convention that everyone had to agree on. They were built into the browser.
And that would allow an ecosystem of interoperable widget libraries, meaning everyone could stop reinventing that same date picker component over and over again. And since web components were built on top of HTML, we got a declarative format for describing components for free.
Yeah, that sounded like a really awesome future 6 years ago when they told us about it. So what's happened since then?
Well, it's been a bit of a long road, but web components became a real thing. And frankly, most of what they predicted actually became true. The vast majority of web users have native web components running on their devices right now.
Every one of you has a phone that runs native web components. It's true.
Yeah. There's a thriving ecosystem of components on webcomponents.org. And most JavaScript frameworks today work great with web components, as you can see on Custom Elements Everywhere, a site that tracks framework compatibility with custom elements. So the promise of one component model that works everywhere really has come true.
And of course, lots of developers are already reaping all of the benefits that Dmitry and Alex talked about. There's a lot of big sites right here within Google that are all in on web components.
And awesome companies like Electronic Arts, Coca-Cola, and USA Today are using web components to ship really great experiences. And those Google companies, you better tell us what those are.
Right, so YouTube, Chrome, and Google Earth are all in on web components. So all of these brands and sites have invested in web components to help them reach users on every corner of the earth. And that's the amazing thing about the web. It's what gets Steve and I out of bed in the morning. It's the fact that it's this one platform that reaches every user on the earth. So a ton of people are using web components. And that future that Dmitry and Alex talked about back in 2012 really has come true.
OK, but really has it? I mean, while it is true that a ton of people are using web components, not everyone is. And if they're truly as revolutionary as they seem, why isn't like absolutely everyone using them, like every single website?
OK, so to explain that, let's pause for a second and talk about this concept we have on the Polymer team called a weirdness budget.
Right. So when you're learning something new, there's really only so many kind of weird new concepts you can deal with at one time. If there's too many things that really aren't compatible with your way of thinking or way of doing something, it starts to feel kind of unwieldy and confusing, and you're likely to just punt on the whole idea.
So take the electric car for an example, right? So the novel new thing about the electric car is that you never need to go to the gas station. You just have to learn one new thing. You have to learn to plug it in at night. That's it. But in addition to that, say the car had a bunch of other weird things about it, like only 3 wheels and funky doors and like only 1 seat. The novel benefit of not needing gas would be lost because of all the other weird things about it.
Yeah, I'm not sure I'd buy that car. And sometimes that's how we feel it's been with Polymer and web components. While that original novel feature, that single standard interoperable component model, has been really compelling, and a ton of developers have been really successful using it, we think web components have been held back from their full potential because, for some people at least, they've exceeded that weirdness budget a bit.
So first and foremost were the polyfills. At the beginning, you needed polyfills to do anything with web components on every browser. And not just one polyfill, but a bunch of them, one for each big feature of web components.
Yeah, and these weren't simple polyfills either. Some pretty fundamentally changed how the browser worked.
So having to load polyfills just to do anything kind of felt weird.
Yeah, and early on, using Polymer at least felt like the only way to build web components. And this was because those polyfills were pretty tightly coupled to Polymer. And that made it feel like using web components was just like siloing yourself in another framework.
Right, and the entire purpose of web components was to break down these silos so that you didn't have to be stuck in a silo when you chose a framework.
Right, so being forced to, or feeling like you were forced to use a library like Polymer just to use web components also kind of felt weird.
And then when we started out on web components, a package manager called Bower was popular at the time and seemed like a natural fit for distributing client-side code. Like web components.
Right. But in the meantime, NPM has really become the de facto standard way to distribute JavaScript for both client and server code. And having to get your dependencies out of Bower became kind of a drag.
Yeah, so having to deal with 2 package managers, NPM and Bower, just also felt weird for developers.
And then there is HTML imports. So it's a really good idea, but it never really panned out standards-wise. This is how those guys from the future envisioned we'd all load our web components with a platform-based loader for HTML, JavaScript, and CSS.
But then once JavaScript modules started becoming popular, it became clear that we couldn't have 2 different loaders in the browser, one for HTML, one for JavaScript. And so over time, the HTML import spec was abandoned. And because of that, all of the standard tools that we all used, like bundlers and transpilers and editors, they never really adapted to dealing with HTML imports.
Right. So over time, at least, using HTML imports also started to feel weird.
So while web components have been objectively successful, there have been some legitimate reasons for developers to hold off using them. And that's been a big focus of the Polymer team over the last couple of years, to eliminate the weirdness around web components so that every web application can start taking advantage of this standard interoperable component model.
Right. So first, let's take a look at the polyfills. Now, the great news here is that you almost don't need them at all today. Last year, both Chrome and Safari shipped a standard version of custom elements in Shadow DOM, and now Firefox has implementations behind a flag and will ship pretty soon. So you need 0 polyfills for both Chrome and Safari, and soon Firefox. And for older browsers or other ones, the polyfills now use feature detection to load just what's needed.
And then the other thing is that as of Polymer 2.0 release at last year's Google I/O, the polyfills are now totally separate from Polymer and work transparently behind the scenes. So now Polymer is just an implementation detail of your web component. Users of your component use it just like they would any other HTML element and don't need to know anything about Polymer, the way it was kind of always supposed to be. And today, web components are made not just with Polymer. You can make web components with libraries like Angular and Ionic and Glimmer. And all of those components can work on the same page through the power of that interoperable component model.
So we've come a pretty long way towards reducing that weirdness around using web components. But there's still these 2 other things that have made web components built with Polymer feel kind of weird. And that's been the focus of our team for around the past year.
All right, and today we're excited to announce the release of Polymer 3.0.
With Polymer 3.0, we're building web components built with Polymer into the mainstream. Now, our boss, Matt, who's right there, he really likes flames. He insists on putting them in every presentation, so we slipped them in right there.
Did you like the flamey web components? OK.
OK, all right, good. Good.
So the first big change in Polymer 3.0 is that the Polymer library and all of the elements we produce are now being published on NPM. So this means you'll just NPM install them like you do any other dependency in your project. No more contending with a different package manager just to use Polymer and web components.
Next, we're moving from HTML imports to JavaScript modules. And this is going to match how the mainstream of code is being written today in the community. But we're not just authoring in modules. We're also publishing our packages to NPM as JavaScript modules.
And this is because as of today's release of Firefox 60, we just tested it this morning, the current version of every major browser natively supports loading JavaScript modules in the browser, all 4 of them. So native modules let you run the code that you write exactly as you wrote it, with no bundling or transpiling or source maps needed during development, which is an awesome productivity boost during development, to just be able to load and refresh your code in the browser.
Yeah, it's totally awesome. But there's just one thing we need to do to make this possible. And that's to convert the module specifiers we use to URLs, because the browsers really only understand URLs. And the convention in NPM, and really the entire JavaScript ecosystem, is to load dependencies by package name, not by URL. And Polymer is going to follow this convention. We're not going to be weird there. So to make those imports loadable in the browser, we need to transform those module specifiers to URLs.
OK, so how do we do this? Well, we've updated the Polymer CLI tools to do just that simple transformation on your source code on the fly, from module specifiers using package names to URLs. So let's take a look at this in action. So here we're loading our shop demo app using the Polymer dev server. So during development, you're loading the exact same code that you wrote in your editor. All the same files right here, no bundling during development. The only change is that the server converts module specifiers from package names to your URLs. So you see that those top couple lines there, those are converted on the fly to URLs, which makes the debugging experience great. You can just edit and refresh. That breakpoint right there is on the exact same line as it would be in our editor. So Polymer still ships with this great edit, refresh, development experience right out of the box.
Right. Now, for those of you who really like developing in HTML, stay tuned, because we're going to have more to say on that later in the talk. But the other benefit of this change, moving from HTML imports to JavaScript modules, is that code built with Polymer also just fits right into the other popular tools in the community. Tools that understand modules like TypeScript and Webpack and Rollup. And of course, you can continue to use the Polymer CLI. You can choose whatever tool works best for you and your team.
So in Polymer 3.0, we've held the API stable and only focused on this format change from HTML imports and Bower to JavaScript modules and NPM. So Polymer 3.0 has all the same stuff as Polymer 2.0, just in a slightly different form. So let's take a look at what this change practically means. Up until now, in Polymer, we define single file components using HTML. So first, you'd import dependencies like the Polymer base class here. So we're using an HTML import, a link-rel import tag to import that. And then you'd use a DOM module element to associate your template's class for your custom element with the template. And then you'd register the element with the browser using the native custom elements custom elements define API. So this is what kind of a typical single file component looked like in Polymer 2.0, all in HTML.
In Polymer 3.0, we're defining single file components using JavaScript instead of HTML. So to do that, you first just make a standard module. You import your dependencies directly from NPM using the browser's native import syntax. Define your class. That part's the same. But then here's a change. You implement a getter that returns your HTML template. And the change here is that you use this HTML function provided by Polymer to convert the string into the element that Polymer expects. Otherwise, the syntax hasn't changed. And we use the same platform API, custom elements defined, that we did before. And that's really all there is to it. Pretty standard, nothing weird here.
All right, so this may sound like a big change, but providing our users a smooth migration path between major versions has always been a really strong focus on the Polymer project. And so again, I just want to reiterate, with Polymer 3.0, we've held the API stable and only focus on this format change from HTML imports and Bower to JavaScript modules and NPM.
Yeah, and to help users migrate their existing code, we're providing a tool called the Polymer Modulizer. It converts HTML imports to JavaScript modules automatically, and it also generates the package JSON you need to install dependencies from NPM based on what you were previously using in Bower.
OK, So that sounds like a tall order, an automatic migration between two versions. So next, let's take a look at the modularizer in action by going to our shop demo application that was written in HTML imports and convert that to modules. So this is the shop demo application. I'm going to reload it here in the browser. You can see in the DevTools, we're loading all of our components there using HTML imports.
That's the 2.0 version.
Right. So if we pull up the shop app, the main component for the application in our editor, you can see all the dependencies are being imported using HTML imports. The template is right there in the HTML. And then you can see that the class is extending from the Polymer element base class that's pulled directly off of the global. Because with HTML imports, we didn't have any scoping. Everything had to go onto the global. So now if we run the modularizer command on our app, that's going to go through, convert all of those HTML files, read those in, output JavaScript modules in their place. So here we can open that same shop app component. You can see all the imports are now JavaScript module imports, and the base class is being imported from the module that provides it. We're defining our class the same way. And then here's the template being encoded right there in JavaScript using the HTML function. As Steve said, the modularizer also generates your package JSON based on all the dependencies you were previously using in Bower. So we can just go to the console here, npm install our new npm-based application, run the dev server. Now we switch back to the browser. I'm going to hit refresh right here. You'll see that automatically all of these modules have been converted. We're now loading them using the native module loader in the browser. And everything basically works. There may be a few things that the modularizer doesn't automatically convert still that you might have to hand tweak. But as you can see, the majority of the migration work is automated.
Yeah, so that's a pretty awesome tool. And we want to thank all of the users and companies in the community that helped us make that happen. And especially we want to give a big shout out to Vaadin that helped us a lot. They have a widget set based using web components that's really great. You should definitely check that out. So modularizer is available today on NPM. It's still in pretty active development, and it already automates most everything, as you just saw, but there are a few things you need to do. You should definitely check it out, and we'd love your feedback.
And finally, along with this change, we've made sure that webcomponents.org, the one-stop shop for the ecosystem of reusable web components, is being updated to host elements distributed via NPM, was previously Bower. And we're encouraging the entire community of web component developers to go through this migration to get them onto Bower and modules, the same as the rest of the community, and get them published on webcomponents.org as well.
So in this latest release, we really feel like we're removing all of the weirdness around using Polymer and web components. Using Polymer 3.0, you can build and distribute web components that are truly mainstream.
And when you're building a web application, using a web component is just like you would any other dependency. It'll fit seamlessly into your workflow.
Polymer 3.0 and most of the custom elements that the Polymer team maintains are available today on NPM. Install them just like any other NPM dependency, and you'll be off to the races.
All right, so that's where we're at with web components and Polymer today. And that future that Dimitri and Alex talked about back in 2012 really is coming true. So where does that put us today with the Polymer project? Where do we go from here?
Well, since we're holding the API stable in Polymer 3, as we said, that release is really mostly about getting our existing users kind of into the mainstream. But we've always really wanted Polymer to be just a really thin sprinkling of sugar over the native platform APIs. And having completed all that work, we're really returning to that core vision. So we've been working on a whole new generation of products that are thinner and lighter and more loosely coupled. And we see these as the future of the Polymer project. So let's take a look at what we've been working on.
All right, so the first thing that we did is take a hard look at improving the base class that we use to make web components. So the rendering and data binding parts of Polymer's base class have really been unchanged since the 1.0 release a few years ago. And since then, we've had a lot of ideas kind of stacking up on how to make it smaller and use more platform features and focus on how developers are actually building applications today.
So to do this, we separated out kind of the lowest part of the smallest part of the Polymer library. It's a roughly 2 kilobyte layer that lets you declare an element's property API and keep it in sync with its attributes and react to changes. And we really see this as a common substrate that any element needs, regardless of what rendering model is being used.
And then in place of Polymer's legacy template and data binding system, we layered on a new library called lit-HTML that we've been developing over the past year or so. Lit-HTML is a lightweight rendering library based on JavaScript string literals and the platform's template element. So we took those two platform features and kind of smushed them together into this rendering library. It's less than 3 kilobytes today, but because it's based on new and some upcoming standards that we're going to talk about, even that can mostly melt away in the future.
We're calling this new base class lit element. So let's take a look at it in action. So we start by just making a standard JavaScript module. We import lit element there from npm and its HTML tag. Then we use our standard pattern. We make a class that extends lit element. We declare our elements property API. Here we're declaring a first, last, and type properties. Users can set those either as attributes in HTML or as properties in JavaScript.
This is pretty similar to a Polymer element so far.
Yeah. Then we use the render method. And this is where lit element makes use of lit HTML and its HTML function. It takes a string containing static HTML and embedded JavaScript expressions describing where the dynamic values should be set. Behind the scenes, this is converted to a template element with some information about where those dynamic spots are. Lit element renders this content to the element's shadow DOM. And then that render method is actually called whenever any of the element's properties change. And lit HTML behind the scene keeps things fast by ensuring that the static content is rendered only once and that the dynamic parts are updated just as needed. Finally, we call custom elements define just like we always do. And that's all there is to it.
So you may notice that this lit element uses the functional reactive pattern that was popularized by React and JSX. But since we're writing standard JavaScript here, the HTML function is a standard part of we're using tag template literals, which is a standard part of the platform. So we have the full power of the language, but we don't have to compile the code to make it work in the browser.
Right. And we see lit element as a lightweight next generation replacement for Polymer 3.0's Polymer element. It's just about 5 kilobytes. That's around a third the size. But it has just what you need for making elements that leverage unidirectional data flow.
And because they're web components, you can, of course, mix and match elements made with lit element with elements you made with Polymer 3.0 or any other web components.
All right. Both lit HTML and lit element are available today on NPM. And you can start using them.
OK, so with lit element, we have a solid new base class for building custom elements and apps out of components. But when you're building a web application, you don't have to build all the components yourself, right, Steve?
No, that would be kind of crazy. So that brings us to our next new product, a new element set. So from the earliest days of the Polymer project, we've always provided a high-quality library of UI components to help you get started building rich user interfaces out of web components.
And yesterday, Google announced a new iteration of material design here at I/O. It's focused on themability. And our team is making a new set of elements expressing this new design language called Material Web Components. These elements will be replacing the Polymer team's paper elements, which are based on an older version of the material design.
Yeah, and for this new element set, we've teamed up with the material design engineering team here at Google that's in charge of supporting all of the platforms that Google builds for. And this is going to ensure that the new set is automatically kept in sync with the latest material design guidelines.
So the new set is actually built using lit element that we just talked about. But again, that's just a implementation detail under the scenes. From the user's point of view, it's just a web component.
All right, we have a preview of the material web components available on GitHub today. Some of them are published now to NPM, but they're a work in progress, and we hope to iterate quickly and have them all ready very soon.
OK, so we have a solid new base class with lit element and a new element set with material web components. The last product ties all of these things together into the end-to-end app building experience. And today we're announcing a new PWA starter kit.
It has everything you need to build scalable, high-performance, progressive web apps right out of the box using all of the latest platform features.
So of course, we're using web components for factoring the UI. And again, those are built using lit element, our new base class. It uses service worker for offline storage. It uses the purple pattern for efficiently serving your application. And we're integrating Redux for top-down scalable state management.
The kit comes with several different starter templates and has tons of documentation for ramping up. There's 0 config commands for building, unit testing, screenshot testing, and deploying. All that's included.
So you can get going with the PWA starter kit by cloning that GitHub repo. And there's a whole wiki in there that tells you how to get started. But also, Monica Dinculescu from our team is going to be giving a whole talk on that coming up in just an hour after this talk at 3:30 on stage 3. So you should definitely go check that out.
Yeah,
she's an amazing speaker. OK.
All right, so to recap, we went over a lot pretty fast there. Polymer 3.0 is bringing the Polymer Web Components ecosystem into the mainstream.
And with lit element, material web components, and PWA starter kit, building web applications with web components is easier than ever.
OK, but remember, the Polymer project's mission is not just to build tools on top of the platform. but also to evolve the platform to make it more capable and ergonomic and help people solve real-world problems.
OK, so we have 14 minutes and 37 seconds. We're going to finish up with a lightning round through a bunch of new platform APIs and features that the Polymer team is helping shape and providing feedback on in the standards process. OK, here we go.
All right, so first up, we have CSS Shadow Parts. This is a proposal that provides a first-class solution for theming web components.
So we've talked about how Shadow DOM provides styling encapsulation. It protects the inside and outside of the Shadow DOM from being accidentally styled.
However, sometimes you want to style elements inside the Shadow DOM from the outside. And the classic case is applying themes. For example, you might want a button to have rounded corners or an input to look special when it's focused.
And while you've previously been able to do this using CSS custom properties, that's kind of what we've done up until now, there wasn't a way to style any CSS property on an element in the shadow root. You could only style the ones that you expose through your custom property API.
Right, and this is where CSS Shadow Parts comes in. So it's actually modeled on the way the platform already works. Let's take the native input element, for example. It has a placeholder attribute that shows a value when you haven't typed anything, and it's usually used to tell the user what to type.
So this is a nice feature, but often developers want to be able to style the placeholder to make it match the theme of their website, right? And what you may not know is that the native input is actually implemented in the browser using Shadow DOM. It has been for years. And the rendering of the placeholder inside that element, that rendering that says enter value, that's actually just an element in the native inputs Shadow DOM. And the platform exposes a special : placeholder pseudo element in CSS that you can select on the input to style it, right? We can make it orange and centered. And we can do that without the input having to leak other implementation details of how it's implemented.
Aha, that's the problem we're trying to solve. We're trying to theme custom elements that use Shadow DOM. So let's say, for example, you had a slider element called MySlider, and you want to allow users to customize the way the thumb looks. That's the thing you drag left and right to set the value.
So Shadow Parts introduces a new part syntax in CSS that we can use to select items in the shadow root. So here we can select : part on the MySlider and pass the thumb as the thing we want to select in there. And give it a custom style. So we could make the thumb orange, if that's our theme for our website. And so this gives us the power to define pseudo elements for our own web components, just like the native platform has always done for its built-in elements.
Right. And to do that, all the developer of that MySlider element needs to do to expose the thumb as a stylable pseudo element is to add a part attribute to the right with the name you want to that right DOM node in your shadow root. And what's great about this is the developer decides exactly what styling is encapsulated in the Shadow DOM and what's themable from the outside.
So the CSS working group has already agreed to advance this syntax, and it's being implemented in Chrome right now. And we really think that CSS Shadow Parts is going to unlock generalized theming for web components that's kind of been missing up until now.
Yeah, you can go check out the draft spec here, and Monica wrote up a really nice explainer on her blog that you can check out there too.
OK, so next up is a big advancement for custom elements, which is the ability to scope new HTML tag names to a specific part of the page. So remember, custom elements allows us to associate a custom element class with a HTML tag name in the browser.
Right. However, up until now, custom elements were defined globally for the entire page. Now, in practice, really, this has been mostly fine. But it can sometimes be a problem. And to see how, let's walk through a little example real quick. So say you're on a big team building a big application, and you're responsible for the contact view. You find a fancy button component, think it'll be great, you put it in right there.
So let's say that I'm on a different team, and I'm responsible for the detail view. And my team finds a different fancy button that looks awesome, and I want to use it in my component. And both of these components need to work in the same page. So since the fancy button tag name can only be associated with one class right now in custom elements, the browser won't actually let you define two elements with the same name. So both teams would have to cooperate on picking the same fancy button or name it differently or something like that.
Right. So let's take a look at how custom element registries will help us address that problem. So with the custom element registries, you'll import the class that you want to use, and then you'll make a new custom element registry. So previously there was just one of these globally. Then you can define that fancy dash button tag name just in this registry, not the whole page. And then finally, you'll tell a shadow root to use just this registry for its scoped tree. So this way, the contact view and the detail view could each have their own registry, allowing you to use that same fancy dash button name, but with different implementations on the same page.
So we think this addition is really going to help large organizations managing a lot of complexity, a lot of dependencies in their application, adopt custom elements. The proposal got positive feedback at a recent W3C meeting this year. And you can follow along on this GitHub issue and provide feedback on the issues linked here. And actually, for all the things we're talking about, go check out the issues and comment on them and give them your use cases and feedback. That'd be great. So with CSS shadow parts and custom element registries, a couple of long-standing pain points are going to be addressed really nicely, making web components easier to use.
Yeah. Now, next we'll look at a couple of features that will enhance the way that we load components in the browser. And first, we have a new browser feature called package name maps. And this will allow us to import JavaScript modules by name in addition to by URL. So as I mentioned earlier, JavaScript modules can only really be loaded by URL, since browsers only really understand URLs right now. But everyone uses package names. This provides a lot of flexibility, like the ability for NPM to put the package just where it needs to be on disk. And frankly, it's just more convenient. But again, it means that you need some kind of tool today to make them loadable in the browser. And wouldn't it be great if you didn't have to do that?
Right. That's the one thing that the Polymer tools during development have to do is transform this. But that's where package name maps comes in. So package name maps introduces a new JSON format that'll be understood by the browser that maps module package names to URLs that the browser can load. And the idea is that this would be generated by your package manager like NPM or your CDN that's providing your modules, whatever knows the location of all the modules. And you'll just tell the browser where to load your package map. It might be something like this. The syntax is still kind of up in the air. But then you'll be able to use package names in all of your source code or your dependencies and have them load natively in the browser, just the way you would in Node.
So we're really excited about how this is going to remove the need to use tooling to load your source in the browser. And we also see this as a really big step forward for unifying the entire JavaScript community, both front-end and server-side, where packages can work out of the box in either context. There's an explainer for the proposal here on GitHub. You can go check it out. Again, please provide your feedback. That's how this stuff gets done.
So the next thing we're working on related to loading is HTML modules. So as we mentioned earlier, HTML imports kind of failed to catch on, mostly because they weren't designed to coordinate with the JavaScript module loader in the browser that started kind of emerging at the same time as actually now shipped everywhere.
Right. But a lot of our users, they really like using HTML to define components. And there's pretty broad agreement in the W3C that supporting HTML as a way to define components is still a really good idea. So we're helping to define a proposal for HTML modules. Now, this is a way to load HTML, but with the standard JavaScript module loader. The native module loader today only understands JavaScript. But if HTML modules are implemented, that same loader would just be able to load HTML. And this really unlocks a lot of possibilities. The HTML could bring in the components template. And then you could use it in a script, please. Thank you. And that'd be really easy. Use that template in your component just like that. Look a lot like HTML imports does today, but natively with the JavaScript module loader, or with the module loader then.
Yeah. All right, so with HTML modules, we're really hopeful to get a way to write single file components that leverages the native parser that keeps HTML and JavaScript or HTML and CSS in their native format without needing to encode them into JavaScript, which feels kind of weird today. The proposal is being discussed on GitHub in this issue. We're still working out a lot of the details, but we've also created an experimental tool that you can check out right now to help refine the design. It lets you write HTML modules in this speculative format and then applies a build time transform to convert them into JavaScript modules that can be loaded natively in the browser. So if you're interested in this proposal, or if you want to continue to write your components using HTML, you should definitely check that out.
Cool. All right. So package name maps and HTML modules are both going to make loading components in the browser a lot more convenient. And that brings us to the last new browser feature that we'll discuss, and that's HTML template instantiation. It's an extension to the existing template element, but it adds API for updating dynamic parts of the DOM. So here's an example template with some static elements. And you may not actually know this, but cloning a template like that is the fastest way to create a tree of DOM. It's actually faster than creating elements imperatively like many libraries do. But in practice, of course, real applications need to update that DOM as well. So like in this case, we probably wouldn't put that name, Bob Smith, statically in the template like that, would we?
Right. We'd probably fill that in from a variable that's loaded from a database or something, and we might need to update that spot in the template later on. And really, there's been no way to do this built into the browser. In fact, a lot of JavaScript libraries are focused on this one thing, like creating a tree of DOM and then updating it dynamically. So template instantiation provides a way to tell the native template element where the dynamic parts will be. So we'll be able to create what's called a template part and attach it to a spot in the template to tell it where it can be updated. And so right here, this is where we wanted to update the name. And that's the only part of this template that needs to be changed. Everything else is static. And we can tell the browser about that ahead of time. And then once we've created parts in the template, there's a new API called createInstance on the template element. And this will stamp a copy of the template, all of that static content, into a thing that looks very similar to a document fragment that can be appended using the normal DOM APIs. But then the cool thing is that the instance also knows about where all the dynamic parts are in that template without having to walk through, right? We can just call get parts on the instance, and then each part has a set value API that we can call to update that part of the DOM. And then finally, you just call commit on the instance to apply a batch of changes all at once.
Cool. All right. This looks like a pretty low-level API, and it kind of seems like it's going to mostly be used in library code. But let's take a look at what users are going to gain from adding this to the platform. So as we said earlier, it builds on top of the existing template element, which is already the fastest way to create a static chunk of DOM. But by adding this new part API, we think this will end up being the fastest way to update DOM as well. And this is because today, any library that deals with rendering has to locate these dynamic spots in the DOM manually each time you create an instance of the template. And if you're using a VDOM library, those have to walk through what could be a pretty big chunk of static nodes just to find what needs updating. With template instantiation's getParts API, you can just ask the browser for that list of spots that needs updating without needing the runtime overhead or the code to walk and find those spots.
So another cool thing is that the API is proposed to have batched updates built in. So logic to update the dynamic parts of a template and a component could potentially be spread across multiple frames and committed in one batch, which is really cool because a lot of frameworks are experimenting with this concept of spreading work out across multiple frames. So this feature is also being designed as low-level flexible primitives that can be incorporated into as many frameworks as possible. For example, we think this will replace a large portion of what our new rendering library, lit-HTML, implements, make that faster. But the Angular team has also been involved in the feedback process for this spec and is interested in using template instantiation as well.
Last, while the initial proposal for template instantiation has an imperative API that we've seen, it also paves the way for a future declarative syntax for describing where those dynamic parts are just directly in the template's HTML. And that, together with HTML modules, unlocks a potential future where components could be defined completely declaratively, which is pretty cool. So template instantiation promises to make rendering DOM a problem that every framework contends with faster, simpler, and with way less code. It's a really exciting proposal. It was started by Apple. It has strong support now from all the major browser vendors. It's still in very active development. You can check out the explainer shown there, and that issue there has some of the latest discussion.
All right, so you guys still with us? All right, let's recap. All of these features that we talked about are going to help make the browser way more capable and easier to use. So CSS shadow parts and custom element registries are going to make those features, shadow DOM and custom elements, a lot more robust. Package name maps and HTML modules let us load our source code with fewer tools. HTML modules and template instantiation unlock declarative component authoring. And template instantiation makes dynamic rendering way more performant. And if we take all of these features together, that means that we can rely more on the platform, more on the browser to get our job done and ship less code that has to run and be delivered over the network to our users. All right? Okay.
All right. So as you can see, we have a pretty exciting next new round of features that will help evolve the platform and make it better. All right. That's it for everything happening on the Polymer project. So here are the main takeaways, what you should learn from today.
All right, so web components are now a standard part of the web platform that you can use in any app that you're making today. So if you're not using them or you haven't checked them out, now is the time. There's no excuse, OK?
Polymer 3.0 is out today. It provides a really smooth migration path for existing users to a more modern development workflow, authoring in JavaScript modules and using NPM for your dependencies.
The Polymer project is moving forward with a new generation of products focused on improving the developer experience of building web apps with Lit Element, Material Web Components, and the PWA Starter Kit.
And as you've just seen in that lightning round, we have a ton of great new platform features on the horizon that will make that experience even better.
All right, again, I'm Steven Schaff.
And I'm Steven Orvel.
All right,
Thanks
you
a lot
for listening.
Thank you for joining this session. Brand ambassadors will assist with directing you through the designated exits. We'll be making room for those who've registered for the next session. If you've registered for the next session in this room, we ask that you please clear the room and return via the registration line outside. Thank you.
Hello, IO Live. Todd Kerpelman here, and I am joined with Abe Haskins, who is a developer programs engineer on the Firebase team. Hi, Abe.
Hi, Todd.
So what is this exciting game that we see going on behind us right here?
This is AppShip 2018. This is a Firebase-powered multiplayer arcade spaceship thrilling game.
Extravaganza.
Extravaganza, yeah. It's a phenomenon.
That's what I was thinking. And so how is this game making use of Firebase?
So we started weeks ago when we generated thousands of custom rocket ships that we turned into sprites, which we turned into cards, which we got printed. And we did that all with Cloud Functions and other Google technologies. And then once we had those printed, we built scanners that can scan the cards using the new ML kit from Firebase. Then we made a game which received updates from the scanner using real-time database. Once you're in the game, it loaded your actual sprites from cloud storage for Firebase. And once you're in the game doing stuff, it shoots out analytics to Google Analytics for Firebase. So it's all Firebase through and through.
Yeah, I noticed every attendee here is getting a appship.io card, each one with a unique rocket on it. Did you design all these rockets by hand?
I basically did, yeah. Whew. We made a tool that allowed you to go and mass produce rockets by picking and choosing parts that went together.
This is mine with my custom spaceship. And basically, when you scan it in at these scanners over there, everybody just sort of has their own spaceship magically appear in the game. Yep. And so that's all being powered through Firebase.
Yeah, it's all being powered through Firebase. Like I said, we use Cloud Functions to actually generate the sprites, generate the cards, and we had the cards printed, and we connected all the cloud storage, real-time database, so we're writing back when you scan it in. We have history on all the cards.
So there's a lot that's been going on with Firebase. What are your highlights of the things that have been happening with Firebase over like the last year?
Well, I personally normally work on Cloud Firestore, so I was super excited that we got to launch that. But we also have performance monitoring for keeping an eye on your app. We have A/B testing for trying out new things. We have ML Kit, which is obviously a huge, everything about ML is exciting and awesome, and I'm glad I got to use it a little bit here. Basically all that. We have so much cool stuff coming out.
Excellent. Well, I'll have to check out more of it after I play a little appship.io and I don't know, kick your butt in it. All right, let's give it a try. So every attendee at I/O this year has a unique appship.io card that they can get here at the Firebase booth, Dome, and every card has a unique rocket design on it. So when you scan this QR code at one of these scanners, my special rocket will appear on screen there. That's me.
No matter what kind of app you're developing these days, there's a good chance you'll want to store your data in the cloud. Maybe that's because your users want to share their data with their friends for some exciting in-app collaboration, or maybe it's just because they'll want to access their data from more than one device. But storing data in the cloud isn't quite as easy as it first looks. You have to set up your own servers to host the data and keep them up and running day and night. You got to spend a lot of time on the client dealing with networking issues, including making sure everything still works when your user goes offline. You need to stay up all night wondering if you've gotten your security exactly right. And spoiler alert, you probably haven't. And then you need to make sure your service can scale no matter how many millions of users you might have. All of which is time you don't get to spend on building your app. This is where Cloud Firestore comes in. Cloud Firestore lets you store your data in the cloud so you can sync it across all your devices or share them among multiple users. And it comes with all the conveniences you'd expect from a Firebase product, like robust client libraries, full support for offline mode so your app will continue to work just fine whether you're connected or not, even on the web, a comprehensive set of security rules to help you manage access and sleep at night, and an easy-to-use data browsing tool. It also lets you structure your data in ways that make sense to you thanks to its powerful querying and fetching capabilities. Cloud Firestore works in near real time, automatically fetching changes from your database as they happen. Or you can request and fetch data manually. It's completely up to you. Cloud Firestore brings you the best of Google Cloud Platform's powerful database infrastructure with features like multi-regional data replication for extra reliability, strong consistency to make sure everybody's on the same page, and multi-document transactions so you can perform complex operations on your data. And we've designed it to handle the toughest workloads from the world's most popular apps so it can scale automatically to support yours. But it still integrates with other Firebase products, including Firebase Authentication for easy sign-in, and Cloud Functions, which lets you run all sorts of server-side logic in response to changes in your database. all of which means you get a truly serverless development experience. And that means you can spend less time on infrastructure issues and more time building your app. So give Cloud Firestore a try today. You can find all our documentation here, try a sample or two, and start building something great.
Stability issues can derail the success of even the best apps. Buggy apps make your users unhappy, and they might uninstall your app, leave a bad App Store review, or write negative social media. Apps can generate a lot of different crashes, and manually tracking them is time-consuming. Even if you're able to collect all of this data, it's difficult to figure out which crashes to troubleshoot and fix first. Firebase Crashlytics helps by automatically collecting, analyzing, and organizing your crash reports. It also helps you understand which issues are most important so you can prioritize those first and keep your users happy. It combines a real-time dashboard and alerts to keep you aware of your newest issues and any sudden changes in stability. The dashboard shows crashes ranked by overall impact on your users, giving you the information you need at a glance. Crashes are intelligently grouped across versions of your app, with individual stack traces easily explored in the dashboard. Sometimes you might hear about crashes from users that you can't reproduce. With the help of logs and key value pairs in Crashlytics, you can add some context to each stack trace and see what your app was doing before the crash. When the crash is reported, this extra information is sent to Crashlytics, becomes visible in the dashboard, and gives you the context you need to help pinpoint the exact cause of the crash. Non-fatal errors can be reported in the dashboard too, so when your code fails but doesn't crash your app, you can still get full reports in the dashboard. If your app is built with the NDK on Android, Crashlytics will capture native stack traces as well. Crashlytics is easy to integrate with 0 lines of code required on Android. With iOS, just use CocoaPods for simple integration. You can count on Crashlytics to help stay on top of the stability of your app, spend less time troubleshooting issues, and more time doing what you love with Crashlytics. And to learn more and get started with Firebase Crashlytics, check out the documentation right here.
Hey, everyone. My name is Raj Adravit, and I'm a product specialist for the Android platform here at Google Play. Today, I'm going to begin our session by talking about the Android Go opportunity and walking through some details about the product since we last spoke about it. I'm then going to invite my colleague Steve to come up on stage and walk you through some of the data that we're seeing to support all the details as to why we built Go, including reasons why you should keep your app small. After that, we'll have Amrit come up on stage to walk through all the requirements that you should pay attention to when it comes to optimizing your app and your game for these devices. And finally, I'm going to have James come up on stage, and he's going to walk you through all the details that we've been doing on the Play Store to make sure that we're delivering a really awesome store experience for users on these devices. So to start things off, Android Go was an ecosystem-wide effort to make sure that we delivered a premium hardware and software experience for users on entry-level devices. Now, in all of the user research that we did globally, we found that users had very specific pain points on these types of devices. Those items included processor speed and quality, storage capacity, and battery life. No matter where we went in the world, in developed markets, in developing markets, users consistently coming up with those issues on these types of devices. So we challenged ourselves, along with our OEM partners, to deliver a much more integrated and better experience at this device capability. It's important to remember that Android Go is not a fork of Android. What we did was we actually introduced a build time flag into the platform that ensures that all devices that are 1 GB of less or RAM going forward are going to be Go configuration devices. We worked with all of our Google teams internally, from search to the assistant to YouTube and Maps, to make sure that we delivered a first-class Google experience as well to users who are on these devices. We also made sure to introduce preload limits. We definitely don't want to have users unboxing super slow phones the second they buy them. Let's dive a little bit more into storage, performance, and security. Now, again, referencing that user research that we were talking about earlier, we noticed that over 2/3 of users on devices with 8 GB of flash or less really only had about 1 GB of storage when it came down to it. You can't really do much with 1 gig of space. It's 2018. I want to take pictures. I want to download apps. I want to play games. What we realized was we needed to do a better job of actually making sure that users had more storage out of the gate. And what we were able to accomplish with software improvements was that users now have 2x more storage right off the bat. That's an additional 1,000 photos that they can take on their phone. Now, it would be disingenuous of me to come up here and ask all of you to optimize your apps and your games for these devices if we didn't ourselves actually do the same thing. So we got together with all the different product teams for some of the major apps that you know and love, like Search, the Assistant, Gmail, YouTube, and made sure that we delivered a really good experience from Google on these particular devices. Some of our product teams decided to remove some features. Others decided to add specific features for these types of devices. It really just depended on the use case for those particular teams. One of our most popular apps is actually Files Go. And in that scenario, we realized that we needed to deliver a better job for users in terms of managing space on their phones. We've been really excited to see some of the ratings and the excitement that users have with these particular apps. Now, security is at the heart of everything that we do at Android. And one of the things that we launched as part of this was Google Play Protect. With the rise of peer-to-peer sharing and offline usage of apps, we wanted to make sure that users felt very comfortable with the apps and the games that they were downloading onto their phone. Think of Play Protect as a badge of trust that essentially extends the Play brand to let a user know that the app or the game that they're putting on their phone can be trusted to be used on that particular phone. My colleague James will go through more details about what that actually looks like on a user experience for these devices. Now, I'm really proud of all the work that we've accomplished so far over the past year. But let's take a second to dive a little bit more into the opportunity around why it matters for you to optimize your specific experience for these types of devices. This chart right here shows 2017 shipments globally for Android devices, broken down by the RAM on those devices. As you'll see on the top right there, about 25% of global shipments every year are devices that have 1 GB of less or RAM, 1 GB of RAM or less. That represents about 300 million devices in the market currently. Now, we expect the number to actually increase throughout the year, but it just kind of gives you a general sense for how many devices you should expect will actually have this configuration going forward. We've seen a ton of interest in the market from all of our OEM partners. In fact, back at Mobile World Congress in March, we had about 6 OEMs launch devices. I'm happy to report now we have over 80 OEM partners committed to delivering devices, with hundreds more in the pipeline by the end of the year. We really cannot thank our partners enough for all the work that they've done to partner with us to deliver a really awesome hardware experience for entry-level devices. I definitely encourage you to go out and buy a device just so you can feel and see just how premium the experience is at such a decent price point. Now, I want to dive a little bit more into the Indian market specifically. India represents the largest market for these types of devices. We expect about 30 to 35 million devices by the end of this year that'll have the Go configuration on them. The marketing that you're seeing right here is what Micromax is actually using in market to show users just how premium the experience is. And the good thing to call out is that with carrier subsidies, many of these devices are actually under $40 US in these markets. So very, very good price point and still premium quality hardware. Of course, India does represent the largest opportunity for these devices, but I can't stress this point enough. The US is the second largest market for these devices today. Every time I tell that to people, everyone looks at me with blank stares because it doesn't make any sense. But the numbers prove out that the US is the second largest market for entry-level devices today. This isn't just a developing market problem or an emerging market problem. This is a developed Western market, first world market problem as well. Users around the world at these price points and at these device configurations want to have a premium experience, and Go delivers that. I'd like to now invite my colleague Steve to come up on stage to walk you through some of the data that we're seeing on the Play side around all the information that we see that supports the reasons why you should invest in the opportunity as well.
Hi, thanks, Raj. Hi, everyone. My name's Steve. I'm a product manager on the Google Play console. So Raj just introduced you to Android Go and talked a little bit about all the work that we've been doing to shrink the storage and memory footprint of our Google apps in preparation for it. I want to talk to you a little bit about the importance of doing your bit and the rewards you'll get to your business and your user relationships by focusing on shrinking your app size and thinking small. Now, if you haven't gotten enough data analysis over the last few days, hold on to your hats because I'm going to show you a bunch of graphs. So as devices have gotten more and more advanced, developers like you are making increasing use of their capabilities, which is great. It means you're packing in more features than ever before. You're making better user experiences, providing more value to users. But it can come at a serious cost. This chart here that I'm showing, and you might have seen it earlier, shows the average app size served on Google Play over the last 10 years. And you can see very clearly that app size has continued to increase. In fact, it's grown 250% over the last 5 years alone. And it's still growing. All that increase in size may be materially impacting your user acquisition strategy. App size has a very real effect on conversion rates and the successful download of your app. This chart shows the correlation between app size and user conversion rates. Specifically, when I'm talking about conversions, I'm talking about users who come to the Play Store and tap install. That's the conversion we're talking about here. Clearly, the heavier your app, you can see app size as the x-axis, the less likely a user will be to install your app, even when we account for things like store listing optimizations. Size has a very clear negative impact on whether or not a user will want to install your app on their device. In fact, the data shows that for every 6 megabytes that increases on an app size, we see a decrease in the user conversion rate of roughly 1%. That trend applies to all apps under 100 megabytes, and it also applies globally. That's a material loss in conversion that could be recovered if you focused on app size. But that's not all. We can also compare country by country. Now, if we compare the percentage increase in conversions by reducing app size by 10 megabytes, we first of all see, by the global average, that worldwide users see more benefit. They tend to install more. But this can vary dramatically country by country as well. Shrinking your app by 10 megabytes in a country like India or Brazil has a larger impact on your store conversion rates than countries like Germany, the USA, or Japan. But if you look across all emerging markets, the removal of 10 megabytes from an app size roughly correlates with an increase in conversion rate by about 2.5%. That's pretty big. But let's drill down a little bit farther. Often when we talk about businesses, we talk about conversion rates. But we have a different lens that you might not have seen before, because we're also the ones that serve the apps. So what happens after a user taps install? Well, they still have to download the app. Right? So we can also measure what percentage of apps by size actually fully make it to the device, have a 100% transfer rate, and are ready for install. And that's what this graph shows here. So you can see that as app size increases, the success of a download drops precipitously. Now, this could be for a variety of reasons that aren't all shown here. So for example, it might be for environmental conditions. Perhaps in certain parts of the world, network quality isn't as high as we would like it to be. It's not as reliable as we would like it to be. It might also be for user actions. Perhaps the user gets tired of waiting around for a large app to download. Or maybe once they're on the download screen, they see just how large the app is and they decide to cancel. The blue line here shows devices that have less than or equal to 1 gigabyte of RAM, which is the same device profile as the Android Go devices we're talking about. And you can see that the impact is even more dramatic for those sorts of devices. But whatever the individual reason, the action you can take today is clear. Keep your app small. In many parts of the world, users pay attention to app size when deciding what to download. This chart shows the median download size, country by country, for devices with less than or equal to 1 gigabyte of RAM. So in countries with cheap data or cheap storage or strong network reliability, we see that users have a natural tendency to prefer larger apps, which you can see in the blue. But in many markets, particularly across Africa and Asia, we see a clear trend towards smaller apps. But just to reiterate Raj's point, this isn't just an emerging market problem. If we look at that median download size again, we can see that the US is roughly right in the middle of our global minimum and our global maximum. So this implies that roughly 50% of users in the US and countries like it also are more likely to prefer smaller apps. The US is the second largest market for Android Go devices globally, and I think these numbers sort of help to support that statement. So you might be saying to yourself, what's the point of this part of the presentation? Is Google really trying to tell me to remove features from my app and try and make my app small by doing that? Not exactly. What I'm trying to do is paint for you a larger picture of the decisions and the factors that you should weigh when considering what to do in your app next. Some of your decisions might cause you to lose out on quality installs and prevent users from installing your app. I'm now going to pass it to my colleague Amrit, who will dive more into the details of how to optimize your app for Android Go. Thanks.
Thanks, Steve. I'm Amrit Sanjeev. I'm a developer advocate at Google based in India. And in this session, I want to talk about how you can optimize your apps to make them Android Go ready. What we've learned working with our partners is that when they actually optimize their apps for Android Go, it just did not benefit only the users who used Android Go devices. It did help everyone who was using these apps. It worked with people who were in emerging markets, as well as using high-end devices. As you'll hopefully see, tuning these apps with these requirements will enable all your users and will bring a lot of benefits for you. Let's walk through some of the technical requirements here. Firstly, you need to set your target SDK to 26 or above. This will not only ensure that you deliver the latest Android experience to your users, it will also allow you to comply with a play policy change that requires you to set the target SDK to N-1 API level, where N is the latest Android API. If you're targeting a version lower right now, you need to ensure that you test your apps thoroughly to make sure that there are no breakages or functionality changes because of this API change. There are some behavior changes in API 26, and you need to account for that. Limitations like background processing, location updates, notification changes are some of the examples of regions where you might want to test more thoroughly. The second requirement is to reduce the APK size. For apps, we require you to make it less than 40 MB, and for games, that's extended to 65 MB. That's excluding the secondary downloads. When I say 40 MB, that's kind of the upper limit that I'm talking about here. You need to make it as small as possible. Here are some of the things that you could do in order to reduce your APK size. Firstly, remove all unnecessary code and unnecessary libraries that you have added into your build. Ensure that the libraries that you're adding are mobile optimized and not server-side ones. The drawables in your resource folder, they need to be optimized for both size as well as for format. If you're looking for backward compatibility and you're adding support v4 modules, ensure that you're adding only the modules that are required by the application and not all of them. In case your app has audio resource files like .wav files, try converting them to MP3 or AAC, which are much smaller formats, thereby reducing the APK size. But it's not only about changing these things, you also need to measure them, right? So if you're using a traditional APK format, you can use the Android APK analyzer that's shipped along with Android Studio to check the sizes of the APK and also compare your APK against the previous one as you make changes to see how well you're making increments in this one. If you're using the new app bundle format, then you might want to use the bundle tool and check the size of the splits here. We all know that entry-level devices are RAM constrained. So you need to check all your key user features to ensure that they run properly without any issues on a 512 MB RAM device. ANR, janky frames, out-of-memory exceptions are things that you've got to watch out for. So test your apps thoroughly before you release them for these problems and fix them proactively before you send it out in the market. Once you've actually put it out there in the market, you need to observe and reactively fix issues as they come. Android Vitals, which James will actually talk about later on, Firebase Crashlytics, and Firebase Performance Monitoring Tool are some of the SDKs that you could use in order to do this reactive part really, really well. Let's take a look at the requirement for RAM usage. Startup memory in your apps should be less than 50 MB, and for games, that's extended to 150 MB. I want to be clear that when I'm talking about RAM usage, I'm talking about the proportional set size here, or PSS in short. PSS is basically the sum of the private memory your app is using plus the proportion of the shared memory with other processes. Test all your key user journeys and optimize them for memory usage and make the memory footprint as low as possible. A common way to find this PSS number is to use the meminfo command that you could run from the ADB shell, or you could use a debug memory class and programmatically calculate this. Let's move on to app startup time here. The requirement here is that app should start in less than 5 seconds. When I mean startup time in 5 seconds, what I mean is be fully interactive in less than 5 seconds. We all know that quick starts are key to avoid early uninstalls and abandonment. A quick startup time is key in building a perception that your app loads fast and is fast for the user. As a general rule, you need to ensure that your app is perceived to be fast on these devices. In order to measure the app startup time, you could use the Firebase Performance Monitoring SDK, which actually calculates this automatically and shows it on the Firebase console for you. We're extremely proud of the work our partners have done in order to reduce size and improve performance for their users. We can't thank them enough for partnering with us on this initiative and in providing a fast, performant, and rich experience for their users. I'm going to now show you a video that our team has put together, highlighting the experience Flipkart team had while they were optimizing their app for Android Go. Let's take a look.
Flipkart is India's leading e-commerce player. Its mission statement has always been, how do we enhance the living experience, the lifestyle of Indian users by bringing the most affordable and most quality products to all sections of the country using technology. One of the biggest learning from our user base was a lot of these devices were actually with less than 1 GB of RAM, where people were actually aborting their journey because the phone could not handle the storage or the computation requirements. So we launched our Android Go application.
If I can load my pages faster, I can give those additional milliseconds back to the user, which can actually give the user a much better experience in their shopping journey on Flipkart. The app install size, as per the Android Go guidelines, needs to be less than 40 MB. And with some good guidance from the Google team, we have brought that down.
We are using Android Studio Refactor and ProGuard, so which is helpful for reducing resources and code base. Apart from that, we are also using WebP, which is giving us 20% reduction in the image download size.
The guideline that we received was the proportional set size should be less than 50 MB.
So we did a lot of resource allocation changes in our code base. We reduced our memory cache size from 2 screen to 0.5 screen. We reduced our bitmap pool cache size from 4 screen to 1 screen.
Working on the Android Go app for Flipkart, our app has become much lighter. It has become more performant. The existing user base, we've actually seen the uninstall rates go down by 34%.
Our latest app versions now crash almost 10 times lesser as compared to our older versions, with an average rating of 4.4 plus. A lot of effort has gone behind reaching that milestone.
We are excited with Android Go that we'll be crossing the 200 million very, very easily and very, very soon, because we believe the next set of online users are actually going to come on devices for which Android Go is the right medium to approach. So if you're an app developer and if you're building for India, just go get out, understand your user, try to make your technology tailor to those needs, and then you would have an app which would be loved by your users.
We're so proud of the work Flipkart and all our partners have done in order to optimize their apps for Android Go. I'm going to now hand over the stage to my colleague James, who is going to talk to you about the Play updates. Thank you.
Thank you. Hey everyone, I'm James and I'm a product manager on Google Play. I work on initiatives like Android Go, the emerging markets, and end user optimizations. And I'm really excited to share all the work that the entire Play team has put in over the past couple of years to deliver a quality Android experience to our users. Let's dive into the work we're doing in the store. I'm going to chat a little bit about end user experience, and then optimizations and improvements we made under the hood. And then I'll tell you guys about some of the tools that we've developed for you to make it easier to build on Android Go. A key point that I want to make today is that there is no Go version of the Play Store. It's just the Play Store optimized for Go. It's the same Play Store on every device. We did this deliberately because we think that the optimizations that we can make should be, the customer should be able to take advantages of those optimizations on any device that they may be on, whether it be a Go device or a Pixel. We aren't limiting the catalog on Android Go, so users get access to any title that you choose to distribute to them, whether your distribution settings be limited by location or by device type. So we kind of need to set the example. You've heard today over and over that small matters. We went out over the past year and have chopped the Play Store in half from a size perspective, and we're now just at or below 10 megabytes on all devices globally. It's an accomplishment I'm super proud of. Users in emerging markets have made it ultra clear to us that mobile data is their currency. So we ran a couple of tests, and we showed how expensive any app download is on a card and on search results. And as you could imagine, users opt for smaller apps, even if a rating may be lower. So In a couple of places, we actually replaced where we previously had an app rating with an app size. We found that showing the APK size increases install rates and, more importantly, user engagement over time. Remember what Steve said earlier. APK size does have an effect on install conversion and successful install rate. And with the rise of offline and peer-to-peer sharing, Play wanted to ensure that users could still trust the apps and games that they got from us, no matter where those apps came from. That's why we introduced Play Protect. You can think of it as a badge of security that users will know and trust. So what this does is it gives users on any device type confidence that they have a safe and secure app experience when they're interacting with these apps in the context of Play. How did we do it? We wanted to make sure that an app can be trusted on a user's device, so we started to attach a very small bit of security metadata to every app and game that we publish. Then, what we can do is, if a user acquires an app offline or via peer-to-peer, we can use Play Protect to read that security metadata and determine an app's authenticity and verify its source. You, as a developer, get the added benefit of being able to service those apps because we will bring them into the user's Play library, and we'll be able to update those apps in the future. It's a major pain point that we know you've relayed to us, and we're excited to address moving forward. APK size, the downstream metrics that come from it, installs, how long a user may keep an app on their device, and APK size getting bigger over the past 10 years caused us to really take a step back and evaluate ourselves. And we said, what can we do to make this situation better? Well, through that analysis, we came up with Google Play Dynamic Delivery. Today, you can use Android App Bundle to benefit from a smaller app without needing to refactor your code. The app bundle also enables future modularization. What it does is it reduces your app at the moment the user installs the app and allows you to load dynamic feature modules on demand at the point when they're needed further down the road when the user is engaging with the app, rather than making sure there's lots of pressure at install time. The Android App Bundle, along with Google Play's Dynamic App Delivery, ensure we deliver apps of the future that are modular, instant, and dynamic. We've also tuned the Play Store's personalization algorithm to show smaller apps on lower-level devices. And as you could imagine, this increases engagement because downloads are more successful and smaller apps run better on these entry-level devices. This is evident in all the data we've collected on user behavior, and it's key to think about how size will affect App Store ranking for these users. We've done a bunch of feature improvements for the store. For example, when a user is near device disk capacity space, we suggest to users removing apps that have either never been opened or haven't been used in a long time. You can see on the screen here, we show a mock of apps that are of a specific size that haven't been used, from least frequently used to most frequently used. And we give the user who's trying to install your app an opportunity to delete an app that is stale or they've never used. And that gives them an opportunity to have a better experience with your app. Another thing that we recognized we were not serving our users in the best way was the notion that a lot of users manage app installs when they're on Wi-Fi. Well, we thought we could do better. So we created Play's Wait for Wi-Fi feature. It's a known usage pattern everyone sees all the time, but we thought Play could do a better job of serving this particular user need. Data management is important to these users. So if a user is on Play via a mobile connection, they can either, when they hit install, they can either choose to install that app immediately or delay that download until their device connects to Wi-Fi, and we'll initiate the download in the background and alert them when the download and install is complete. This gives users more control. It saves metered data, and most importantly, it saves money. We also took a look at ourselves and realized that we weren't doing a very good job from an offline or a connectivity tolerance point of view. So we built a couple of additional features. The first one is when the Play Store is on Wi-Fi, we cache a larger percentage of the most visited parts of the store. So what that means is if the user turns mobile data off, or their connectivity is crummy, or their connectivity is spotty, we can actually serve a greater percentage of the store directly from cache. This is great because it works offline. It's also great because it's a super fast experience for our users. Then, when they reach the edge of the cache, they're offline, and they can't bring up any additional pages. We've built another feature that allows the user to opt into a notification that will bring them back to that part of the store that they left once their device establishes a connection again. This is a great opportunity for the user to get back to Play to download your app. All the features I just walked through are designed to give end users a high-quality store experience. But I also want to reiterate that we have tools available for you to help you optimize your app for these Android Go devices and these markets. The first, which no one in this room should be unfamiliar with, is Android Vitals. Android Vitals gives you an insight into ANRs and crashes, and it's paramount for understanding the stability of your app, battery, and the most important part is that Android Vitals performance impacts your promotability on the Play Store, especially in the context of search and discovery. We also introduced a flag, as Raj previously spoke of, called ISLO-RAM that allows you to adjust your app's UX and distribution choices. We want you to optimize for maximum distribution. Here's an additional tool to help with that. We've also included details about Android Go devices in the console pre-launch report. This allows you to check on your builds and understand how they're performing on actual Android Go devices on test beds before you release to market. Be sure you incorporate a regular cadence with the console pre-launch report as part of your normal QA and release management process. So, you guys have been to a lot of meetings, you've heard a lot of things, and if you've been on your phone the last 25 minutes, the 4 things you need to remember. Android Go is a huge opportunity. Keep your apps small. Play is doing everything we can to improve you should do everything you can to improve app quality by leveraging the Android tools, and Play is delivering a focused experience for these users. Thank you, everyone. If you have any questions, the 4 of us will be up here at the front. Looking forward to hearing from you.
Thank you for joining this session. Brand ambassadors will assist with directing you through the designated exits.
That's the choice we make for wherever we are, because I met people who lived in the rural parts of Africa just as much as people lived in the modern cities like Johannesburg and you know, we were in Durban, we were in Cape Town. So it's you know, you could see someone dressed in their traditional Zulu or traditional Xhosa and in the city, you know, just as much as you might see that in the rural areas. So I decided not only to find myself and realize that I think I've been African this entire time, but that I was determined to find all the beautiful things that I, you know, was told weren't there, you know, because that then really came back to who I am as a person. You know what I mean? It really related back to who I am and how I felt about myself and the confidences I had. So it all kind of like, our fictional world building bleeds back into our realities.
We have 2 minutes left. Could you share a nonfiction story you shared with me that moved me very much, which was about the director Ryan Coogler, who I'm a huge fan of. And I've always, when in Silicon Valley we talk about leadership, you know, CEO, or the product manager is the CEO of the product, and all these CEO-ish things. I think of Ryan Coogler as one of the great CEOs of our time and creatives.
Yep.
And you shared a story about him. Could you talk about
when
that?
I was talking to myself?
Yes.
So you obviously know I'm kind of weird, so I'm going to tell this story. Don't hold it against me. But so we're working on Creed, and we're tech scouting, which is kind of we go to look at all these locations, and you can spend all day. And we had stopped at this coffee shop, And I got my coffee, and everybody was getting their coffee, but I was kind of working out a problem. And when I'm trying to work out a problem or solve a problem, I talk out loud to myself, because that's the best way to do it, for me, apparently. And, you know, my friends and stuff were like, poke fun at me, like, oh, you're crazy, you're talking to yourself. And so, you know, sometimes I do, and I don't even know I'm doing it. So Ryan comes walking over to me, and he was like, are you talking to yourself? And I was like, you know, a little like, oh, you know what I mean? I know you and love you, but yeah. And the first thing he said, he looked at me and he said, that's a sign of a really healthy mind and a really intelligent person. And he kind of turned around and walked away. And I was kind of like ready to get the hit of like, oh, you're crazy, you know, kind of funny joke, but a little bit like of a slight. And that's not at all where his mind came from. It looked for the immediate positive thing about the thing that I was doing that sometimes people think is weird or could make you feel a certain way about yourself that eventually starts beating you down and making, you know, defining who you are because you're hearing negative things about it. That is who Ryan is. He's the person that will constantly lift people up, you know, will constantly, and he's not perfect, I promise. There's days when I'm like, please make a decision. You have like 2 hours. But, you know, and he does all the things that directors do that can, you know, completely bother you or things that are like amazing. But he's the type of person, like we would be on set for Warrior Falls, which was the big waterfall where they had the big fight. And he gathered us all around in a big circle. You know, some people were in the water, and he really told us why that scene was important. This is before we even started shooting. He really started to say why that scene was important to him, and really talked about having all the fictional tribes of Wakanda in one place and represented by all the references that we use of the tribes, the different tribes in sub-Saharan Africa, and how that was a part of him really feeling complete. And, you know, you were holding hands and he's telling us all this and we're standing in this circle and you just feel like you can take on the entire world, you know, at that point. So that's who he is as a director and my friend. And he's a really important voice because his perspective on anything and everything is the most unique perspective you will, I promise you, ever hear from anybody. If you ever get a chance to talk to him because he will turn a situation and make you see it from a side you were never maybe even meant to see it from, and all of a sudden your world opens up. And so I can always, and he would be standing here going like, oh, please stop, but but he is really that great, so.
Well, thanks for sharing that story. What a leader and what a designer. Thank you, everyone. Thank you.
Hello and welcome to I/O Live. I'm Timothy Jordan, and I'm here with Ilyan, who is a principal engineer on Android, and he leads Project Treble. Hi, Ilyan.
Hello, Timothy. How are you?
I'm super. How are you?
Excellent. Thank you.
So that keynote was amazing, and there was a lot of your work up there. In fact, Project Treble. I want to talk about that, but before, could you describe the problem? What are you solving with Project Treble?
What we're solving is what we call Android's version fragmentation problem, which is best explained. If you're an app developer, you have to deal with all of these Android versions that you have to implement against, and this is a massive pain to deal with. So this is the problem that we started addressing out with Project Treble.
And how you solve that with Project Treble is you make it easier for manufacturers to upgrade to the latest version, right?
Correct, yeah. I mean, for developers to have the latest, device manufacturers have to launch their devices on the latest or upgrade existing ones to the latest. But historically, it's been very difficult, which means expensive, to do that, which is why device manufacturers simply didn't do it. This is why we have Android version fragmentation today. The way that we solved it is effectively by lowering their costs. That's what Project Treble is.
All right, so Project Treble was introduced last year. What's new this year?
What's new this year is that we effectively completed the engineering portion of our work, and we embarked on an operational side of it, which the goal of it is to accelerate the deliverables, the intermediate deliverables of Android to the OEMs, to the device manufacturers, so that they can do their work to launch these devices and upgrade these devices much, much earlier than previously. So the end result is that we expect companies like Samsung, for example, to do their work this same year, in the same year when we launch Android.
That's awesome. Now, what OEMs are launching?
We have 7 companies in addition to Google's very own Pixel, of course, who are launching previews, betas this year. And these are Oppo, Vivo, Nokia, Sony, Essential, OnePlus, and Xiaomi.
Awesome.
That's a lot of companies.
And you and I actually have our pockets full of some of these phones.
Yes, we do. We do.
I think it'd be neat to show there's the same version of Android running on each of these different phones.
Yeah, that's what's beautiful about this, is that these are devices by completely different companies, which all run the same version of Android. That was never happening until now.
That's totally awesome.
And, there's one more thing, of course. In addition to these previews, we have a total of 18 devices by 11 manufacturers who will either launch or upgrade their existing devices to the latest of Android this year.
That's really cool.
It is.
So for developers, this again really matters because it simplifies their overall developer experience, which they can get started on by downloading the preview.
That's exactly right.
Ilyan, thank you so much for joining us to explain all of that.
Thank you for having me.
To learn more, head on over to android.com/beta. I'm Timothy Jordan, and this is I/O Live. Hello, and welcome to I/O Live. I'm Timothy Jordan, and I'm standing here with Tim Sneath, a product manager on Flutter. Hi, Tim.
Hi, Timothy. How are you doing?
I'm doing very well, thank you. Let's talk about Flutter.
Yeah.
For those few developers out there that don't know what Flutter is yet, what is it?
Yeah, so Flutter is a toolkit for building native mobile apps for iOS or Android from the same code base. It's open, it's open source, and today at I/O we're announcing a new version of Flutter.
Oh, yeah, so that was my next question. What's new this week? There's a new version, what else?
Yeah, so this week we're announcing Beta 3. Obviously, it's the third beta of our product. We shipped the first beta at Mobile World Congress a couple of months ago, and now we're starting to get to the point where we really feel like it's ready for a lot of production use, and so we're encouraging people to start taking a look at Flutter.
Now, you've worked with developers using Flutter a lot. What would you say they're most excited about when they start using Flutter?
Yeah, so I think there are 3 things primarily that make Flutter a great platform for building apps. Number 1, we have native performance. We compile everything that you write to ARM code. We're powered by the Dart programming language, and that enables this really fast performance. Second thing is we have this unrivaled productivity. With Flutter, you can use this thing called hot reload, so you can write your code, you can continue to work with it, and see exactly the changes that you're making in real time on the device. And then thirdly, Flutter has this high velocity graphics engine that lets your dreams come true, lets designers choose what they want to build and developers put them into production.
Awesome, and there's a lot of people using Flutter today. What are some of your highlights of the apps that are out and live?
Yeah, so again, we've only just got into beta over the last couple of months, both internally at Google and externally. Internally, we power some things like our ads. If you ever create an ad campaign, you're using a Google app built with Flutter. Externally, probably the most famous one that was shipped the back end of last year was Hamilton. You know, the Broadway musical. They shipped a companion app for using Flutter that has had millions of downloads, a really great application. And then this week we're talking about some other new apps. Alibaba, the big Chinese online retailer, they've just shipped an app in Flutter that they're now rolling out to millions of customers. Groupon have an app that they're working on. We have just different kinds of apps from different industries, wine, retail, finance, loads of different people are coming out with apps. And in fact, we've just seen several hundred apps just since we shipped beta go live on the Play Store.
If you want to get started with Flutter, what's your first step?
Well, there's one simple place you can go, and that's flutter.io. And there you can find sessions, you can find code labs. We're obviously live streaming 6 different sessions here at Google this week. There's a whole bunch of documentation, and of course you can download the Flutter SDK.
And that's all at flutter.io.
Flutter.io.
Thank you, Tim.
Of course, it's a pleasure.
I'm Timothy Jordan, and this is I/O Live.
Hamilton is one of the most talked about and best loved musicals, with shows on Broadway, in London, and around the country. We wanted something to make the show more accessible for our fans, so we wanted to develop an app to meet the needs of fans as we started to expand the brand. We turned to Posse, a New York-based development firm, to help us develop the Hamilton app.
Hamilton's Flutter app launched in the App Store and the Play Store 3 months after we wrote our first line of code. And we accomplished a ton. Fans can enter a daily lottery for a shot at $10 tickets, buy merchandise through an e-commerce experience, take selfie photos with the HamCam, and get daily news and updates.
We knew that this app needed to be rock solid, both in terms of performance and visual fidelity, and really represent the amazing experience that the Hamilton show itself provides. And ultimately, that's why we decided to use Flutter.
Flutter is a mobile UI toolkit that allows developers and designers to craft beautiful native experiences on iOS and Android, and is entirely free and open source.
We have very high expectations of quality for the apps that we build. We expect pixel-perfect results, and we need them to be very high performance. Flutter gave us a lot of opportunities that previously weren't available to us. The fact that it's a single code base drastically improved our ability to deliver a consistent experience across platforms. Its hot reload gives us an ability to build more features in less time.
It allowed me to make changes really fast and iterate through the UI without having to stop and restart the app. Coming from an iOS and Android background, it's something that I've been waiting for a long time. The Flutter developer community is very active. Drop-in packages helped us maximize productivity. It helped us integrate elements like Firebase and Cloud.
At the end of the day, we're just really happy that we found Flutter so that we can build these beautiful native interfaces for both iOS and Android from a single code base.
We were given a really tight timeline, and we turned the app around faster than I ever could have imagined. We were able to make changes right up to the night before we went live, and really feel confident about them. In fact, we pushed an entirely new feature to the App Store the day before we launched.
And since launch, Flutter's efficiency and speed has helped us to build new features, such as the recent trivia game. We're really excited because as the show continues to grow, we're going to be able to keep pace with a ton of new features that's going to make the app even better.
We couldn't be more thrilled with Flutter. It has enabled us to use one code base to deliver a truly high-quality app that Hamilton fans have absolutely fallen in love with.
We're thrilled with what Posse was able to deliver. The entire brand of Hamilton is about delivering on an experience for fans. They're thrilled about the new features that we're rolling out, and we're really excited to see where the app goes next.
Welcome to Blazing Fast Content with Firebase and AMP. I'm Michael Bly. I'm an engineer on the Firebase hosting and Firebase CLI. Now, I want to start with a question. What makes a website fast? Because that's the goal, right? No matter what kind of experience I'm building, I want it to be fast. But to answer this question, I first need to ask another. What do we mean by fast? Do I mean low latency, very responsive, low time to first paint, time to interactive? Really, I mean any of these, and all of them some of the time. The most important thing to remember is that fast websites feel fast to the user. That's our end goal, right? That's the only thing that really matters. When a real user visits our site, it should feel fast and responsive to them. So going back to that original question, what makes a website fast? The answer, like with most things, is, well, it kind of depends. There are so many factors that go into real and perceived performance, and you can spend hours or days focusing on any one of them. So I'd like to simplify a bit and look at performance in terms of two different kinds of web experiences. First, let's imagine an email client. This is an application with a single entry point for users. They will almost always load it up by the same URL. Also, it requires authentication before any kind of action can be performed. The signed out experience for our email client is just a login page. An email client is going to be open all day and updated continuously as new messages arrive. So the presented data changes constantly. Finally, email clients are highly interactive. Your most important actions are being able to click into messages and read them, being able to reply to them, being able to compose new messages. So you're sort of constantly navigating around the interface and performing new actions. Now, let's contrast that to a content site. So that could be a news site, a resource, a blog, anything where the primary reason for someone to visit is to read the content that's available there. Unlike the email client, the primary entry point for a content site is likely to be a deep link to a particular article that was posted by social media or discovered through search. Content sites are publicly accessible. It doesn't require a login to view. While new articles may be created on a regular basis, once created, they're generally going to stay stable with a few updates here and there. And again, reading and scrolling are our primary interactions here. We aren't as concerned with being able to do other actions than just look at the page, see what's on the page, scroll down to see more of what's on the page. So what do we do to make an email client fast? Well, here we're going to follow the best practices for progressive web apps. We can build with the app shell pattern, where a service worker caches all of the JavaScript, HTML, CSS, etc., that's needed to render our site. And then we can use API calls to fetch data and render it client-side. Now, this is actually a fascinating topic, and I could go into detail, but it's also not what we're here to cover today. I want to talk about how to make content sites fast. And it's actually pretty different from what you're going to do in the sort of rich client experience. Fundamentally, for content sites, we have to optimize for first page load. This means that our ideal and common case is when someone is visiting the website for the very first time. They don't have anything in their cache for our site. They don't have anything at all about our site on their computer. And that changes how we need to optimize performance. This means we need as few round trips as possible before the page gets painted. Especially in poor connectivity environments, every round trip the browser has to make before it displays content is just going to kill performance. We also need to minimize scripts and styles that block page render. Any critical CSS that you have should be inlined right away. Finally, we need extremely low latency from the server. We need to be delivering content close to the user so that the time that it takes for them to request a page and then actually have the page sent back to them is as small as possible. So what does a performant website look like? Well, it might look like this. This is actually incredibly performant HTML. There's no style sheet. There's no blocking scripts. This is just a few bytes of text that we send over the wire, and we're good to go. And I'd say if this were the 90s, I'd say let's go for it. But it's 2018, and user expectations go a little bit further than default browser style sheets. That's where AMP comes in. AMP stands for Accelerated Mobile Pages and is an open source library created by Google specifically to provide a foundation for fast content sites. AMP is fast by default because AMP stops you from doing things that slow down your web experience. With AMP, you can't do any custom JavaScript at all. CSS has to be inlined. You're not allowed to load any style sheets externally. Instead, AMP adds functionality and interactive behavior through specially approved custom elements that are part of the AMP project. This also means that AMP pages can be efficiently cached by search engines or social networks and preloaded in advance of user interaction. So when you do a Google search and you see those little lightning bolt icons and then you tap on that and it loads instantly, that's because Google has cached the AMP content, and as soon as you made the search query, it started loading that AMP content in the background so that it was already ready to go by the time you tapped the link in search. So this content has been preloaded and served by the AMP cache. Now, it is important to remember, because it can sound a little scary up front, like, oh, this AMP is just like, it's a whole different system that's being built on top of HTML. This is radically different. But for the most part, when you're building an AMP page, you're just writing standard HTML. So let's take a look at sort of the boilerplate AMP page. And you can see that this looks pretty much like any other HTML page. The only difference is we have that cool little lightning bolt in the HTML tag, and where the ... in the AMP boilerplate style tag is, there would be just a number of styles that have to be included by AMP by default so that it can sort of do the right things in terms of displaying content by loading the AMP runtime. And while AMP is mostly just HTML, that doesn't mean that it's only HTML and only sort of the standard tags you get with the browser. AMP is HTML with some custom elements that are designed to bring you modern niceties without sacrificing performance. So let's take a look at just a couple of those. First, we have AMP image. Now, the AMP image tag is actually baked into the AMP runtime, so you don't have to load anything extra or special to get this. This just comes with. And the first thing that it does is this controls the loading of the image to ensure maximum efficiency. So when you load an AMP page, it's not necessarily going to load every image on the page immediately the way it would if you were using a standard image tag. Instead, it will sort of do its own optimizations to figure out when's the right time to render something. It might wait until you scroll it into view. It might wait for other things. The AMP runtime handles that for you, so you don't have to think about it. Next, you'll notice this little layout responsive attribute that's on the AMP image. Layout responsive tells AMP that this element should fill the horizontal width of its container and then match the height based on what you supply in width and height. So normally, while you might have to specify exact image dimensions, with AMP, if you're using the responsive layout, you can just specify an aspect ratio. So here, I just say it's 1.33 to 1. Another thing that AMP gives you with AMP image is the ability to do placeholders for any element. So here, inside my first AMP image, I have another AMP image with a placeholder attribute. And the source for that is just a data URI with a super low resolution version of the image that I want to load. So essentially, on the server, I inline this super low resolution data URI, and then that gets loaded almost immediately because it's small and tiny, and the AMP runtime says, OK, let's do this. And then when my higher resolution image is loaded, it'll just instantly snap in and replace the placeholder. So this is a great way to give sort of improved perceived performance, where you can get an idea of what the page content is going to look like before it's 100% loaded. Some elements aren't baked into the AMP runtime, and you have to load them separately via a script tag. So here's a script tag to load the AMP font element. And you can see that this is really straightforward. It just has a custom element attribute that describes what the element is going to be named. And then it points to the AMP CDN to load the script. You'll also notice that it's an async tag. And this is true of all AMP custom elements. Because like I said, we're trying to minimize blocking scripts and styles. So all AMP custom elements are loaded asynchronously. The only blocking script in an AMP page is the AMP runtime itself. Now, AMP font is actually pretty cool. What it lets you do is essentially control the font loading behavior of the browser and optimize it for performance. So essentially, you can add a timeout attribute to AMP font, and that says, if this much time has elapsed since the page started loading, and I still don't have this font loaded, then I should abandon loading it and do something else. And you can set that to 0 to essentially say, if this font isn't already loaded and on the user's system, then I'm just going to not try to load it and do something else instead. And that something else is that when the deadline expires, AMP will add a custom CSS class to your document that you can then use to apply additional styles or switch things around, change font sizes, whatever you need to do to fall back to system default fonts. Now, I don't really have time to get into it in this session, but web fonts are very expensive from a performance perspective. If you don't need them, don't use them. Or at least use tools like AMP font to fall back quickly if they're not loading. Especially if you're trying to load an external style sheet like through Google Fonts, that introduces a blocking script style request that you have to wait for before your page loads. You can inline font family to improve the performance a little bit here, but just in general, be careful and very deliberate when you're using custom fonts in a high-performance content site. Now, of course, there are a lot more AMP elements than these, and I'd encourage you to explore the AMP documentation for elements that help with everything from layout to media to interactivity in your AMP pages. And another thing I want to call out is that AMP is just one way to make content sites fast. It's not the only way. If you can't use AMP or you don't want to use AMP, you don't like AMP, you don't use it. And the same techniques that I'm going to show throughout the rest of this talk will still largely apply to you and can still help to make your content site high performance. Remember, this is what we're starting with, and this is high performance. So as long as you are being careful in the way that you apply scripts and styles and all of the nice things that the web platform has gotten in the last several decades, then you can make a performant experience. So let's go back to our original checklist for making a content site fast. And we can see that AMP actually helps quite a bit. It helps us optimize for that first page load by minimizing network round trips, reducing blocking scripts and styles, and that kind of just leaves this last one, minimizing network latency. So how can we tackle that? That's where Firebase comes in. Firebase is a comprehensive platform for building mobile experiences. And today, we'll be using it to build our AMP site. Now, you may be already familiar with Firebase as a great fit for sort of these rich, highly interactive applications like our email client example from earlier. Firebase's JavaScript SDKs for products like the real-time database and Cloud Firestore are great tools for highly interactive apps. But Firebase can be just as powerful for building latency-sensitive content sites. So today, we're going to try to use Firebase and AMP together and hopefully build a lightning-fast experience for our users. Now, I really love escape rooms. Working together with my friends to solve puzzles before the clock runs out, it's a lot of fun. So I built Escapable, which is a simple resource to discover escape rooms in your area. Can we switch over to the demo, please? So this is Escapable. As you can see, it's very simple. I'm just going to pick San Francisco Bay here. And now you can see I just have a list of escape rooms. So the top one is Escape Google I/O, and I can scroll down and see all the other ones that are around. For each location, I can link to the website or get directions. And then I also have the rooms that are offered by each location, and I can tap those to expand it out and see a little bit more info. So I can see that this one is 1 to 4 players. It lasts 60 minutes, and it's 96% recommended. So that's really all that there is to this site. And it's very simple, but it also, this has the kind of like rich modern look that you're looking for in a web experience, and it accomplishes what the users set out to do, which is discover escape rooms in their area. So remember, whenever you're tackling creating an experience of any kind, think about first what your users need to do and how you can make that experience the most efficient before you dive into other things. Can we go back to the slides? So when I set out to build Escapable, I came up with 3 potential approaches to make it fast: static compilation, dynamic rendering, and evented rendering. Static compilation is probably familiar to many of you. It was also the first major use case of Firebase Hosting, Firebase's developer-focused web hosting platform. Firebase Hosting serves static content from a global content delivery network, automatically provisions SSL certs for free for custom domains, has atomic release management for easy deploy and rollback, and also lets you configure niceties like doing rewrites for single-page apps. And for static sites, compilation happens up front on the developer's machine. So the developer is going to compile the assets into just HTML, CSS, whatever else they need, and those are going to be deployed to Firebase Hosting directly. Firebase Hosting will then just serve those requests from its global CDN whenever they're requested. So this is really straightforward. The advantages of static sites are clear. There is 0 request time processing. You're just serving flat files. So it can be incredibly fast that way. Also, it's extremely cache efficient. Since things only change when you do a new deploy, Firebase Hosting is able to efficiently cache all of the content on edge servers around the world until you do a new deploy. On the other side, it's not really suited well for frequent updates, especially for user-generated content. Remember, these assets have to be redeployed every time they change. So if you have a website where users are constantly changing things or making the content shift in any way, static's not necessarily going to be a good fit. It also usually requires some dev skills to edit a static website, because usually, like I said, you're editing markdown files on your machine and then building them with Jekyll and deploying them or something like that, as opposed to using a friendly CMS-like UI. Now, there are lots of tools that are available, and again, this is not what we're going to talk about today. Because if you can use a static site, there are lots of resources to help you get started, and I encourage you to do so. There is literally not going to be a more performant way than doing a static site where you're just serving flat files. So like, you can just go do that. But, and in fact, the AMP project website is a static site hosted on Firebase Hosting. So this is not just something that we talk about as like, oh, maybe some people should do it. This is something that we do as well. But some sites are too complex or get updated too frequently for static compilation to be a good fit. So here we turn to dynamic rendering, also commonly called server-side rendering. Now, to do dynamic rendering, we're going to have to bring in some additional features. We started with Firebase Hosting, but now we're going to need to bring in Cloud Firestore to store the data for our site. Cloud Firestore is a flexible, NoSQL database that can scale from weekend projects to planet-scale applications. We're also going to use Cloud Functions for Firebase to do the actual server-side rendering with Node.js. Cloud Functions provides serverless compute for your Firebase project, and we can connect them directly to Firebase Hosting. So let's see how that works. In a dynamic rendering world, the user requests a site from Firebase Hosting. Firebase Hosting then proxies that request to a Cloud Function. The Cloud Function is then going to go out and fetch all the data that it needs to render the page from Cloud Firestore. Once it's done that, it's going to render HTML and send that back to hosting, which then gets sent back to the user. And if we set a cache control header on that response, then Firebase Hosting will cache that at the edge and send that back immediately instead of going back to functions as long as the cache hasn't expired. So the great thing about dynamic rendering is that fresh content is available immediately. Since we are rendering every time a request comes in, we know that we're getting the freshest content on every request, period. It's also a familiar architecture for most developers. Almost everyone has built some kind of request response web server in their time, and so this is something that just is easy to slot in and easy to understand. On the other hand, it's somewhat inefficient and compute expensive when you really think about it. Because like I said, we are fetching all these documents and rendering them every single time a request comes in, when the documents aren't actually necessarily changing all that often. It's also really difficult to efficiently cache dynamic content because since we're rendering every time and we don't necessarily know when the content has changed, we have to make a trade-off between how long can we bear to serve up stale content versus when do we want to incur the penalty of having to re-render and compute. So how do we actually do server-side rendering with Firebase? Here's a streamlined example. As a quick note, I built Escapable using TypeScript to take advantage of modern JavaScript features like async await. And here you can see that I have just a pretty standard Express app. I'm fetching some data, I'm setting some headers, and then I'm rendering a page. One thing to call out is notice that I do an await promise.all here. And that's so that I'm fetching all of the data for my page in parallel instead of fetching it one at a time and waiting for that to complete before kicking off the next fetch. It's also really important to think about cache control headers just generally in web applications, but especially for server-side rendered things on Firebase hosting. You can see here I have a max age equals 300, which is saying it's OK to cache this in your local browser for up to 5 minutes or 300 seconds. I also have an s-max age set to 1200, which says it's OK to cache this in the CDN for 20 minutes. Now, again, this is something that's going to be a trade-off. If your content changes sort of at most once a day, maybe you can afford a longer TTL. But then again, maybe you can't, because maybe it only changes once a day. But when it changes, it's super vital that people see it right away. So that's something that you'll have to determine for your own app. And in this case, because I have 20 minutes on the server and 5 minutes on the client, I have sort of a worst-case scenario of a 25-minute stale page that gets served to a user. So after that, I'm simply rendering the content using the data that I fetched and sending it back as a response, which we'll talk more about in a moment. Now that I have my Express app, I need to register it as a Cloud Function and connect it to Firebase hosting. So here you can see I import the Firebase Functions SDK, and then I export a function using functions.https.onRequest. And then I just pass in my Express app. So when you're registering an HTTPS function, one of the things that you can do is just pass in an Express app as a handler, and that'll just work. So you don't need a special wrapper or anything like that. You can just pass the Express app right in. And now this says that when I deploy, I want an HTTPS function called app, and that it's going to serve content from my Express app. Then in Firebase.json, the first thing I do is declare a public directory. And this is where my static assets will live. And in general, just like with static sites before, anything you can serve as a static file, you should. So this is where I'm putting things like the logo for Escapable and my manifest.json, things that don't change very frequently, and I'm fine redeploying the site if that's necessary when they do change. Then I'm rewriting all URLs to a function called app. And this will only rewrite URLs that aren't an exact match for something in my public directory, so I can safely just say, hey, if it doesn't exactly match a static file, then I want to send it off to my Cloud Function to see if it needs to be rendered there. Now, I'm not going to go super in-depth into the rendering here. While you can use your favorite templating library or even something like Preact to render AMP pages, I decided to avoid libraries altogether and just use template literals with string interpolation because it's possible, so why not? If you have user-generated content, though, please be sure to properly sanitize your data and don't just do this, because you'll have bad script injection attacks and have a bad time generally. But ultimately, this is just a function that returns a string, because all I'm doing is creating my AMP page as HTML as a string. The only other thing that I did is I put CSS in separate files, and then I just inlined those in the AMP custom tag by loading them literally out of my functions directory. So again, this is like very duct tape, but it works. So how well does this perform? Well, when hitting the origin and performing a full fetch of all the documents to render the page, I got a response in about a second. Sometimes it was a little better, sometimes it was a little worse, but that was kind of on average. And that's not horrible, but it's not great. But if you compare that to when the CDN was serving content, we had 21 milliseconds as the total round-trip time, including delivery. That's a pretty marked difference. And if you look at the film strip, you can see that difference clear as day. So here we have essentially a 1-second difference that is the difference between the CDN and the origin. So this is 3G perf. On the origin, I got my page to paint in about 3 seconds. On the CDN, it's in about 2. Now, interestingly, if we look at the version of the page in Google's AMP cache, we knock another 800 milliseconds off of the meaningful paint time. That seems unfair, right? Like, how's the AMP cache get to be faster than my site? Well, it's cheating, kind of. The AMP cache does some optimizations of AMP pages when it loads them into the cache that make it perform better by doing some specific things that optimize and further reduce those render blocking scripts and styles. But what about users who come to my site directly? I want that kind of performance on my site. Well, there's a pretty new open source library called the AMP Toolbox. And the AMP team open sourced some tools that let us mimic the same optimizations that the AMP cache does on our own server. It does this by removing the boilerplate, locking AMP to a specific version, and inlining critical CSS. Also, once it does this, the page becomes not valid AMP, which is kind of interesting. So by optimizing the AMP, you make it invalid AMP. So the way that you approach this is you serve both the unoptimized AMP page, which can be slurped up by the AMP cache and used there, and then you also serve the optimized AMP page as the canonical link that people are going to go to when they visit your site. And we do this by installing 2 packages in our project, AMP Toolbox Optimizer and AMP Toolbox Runtime Version. Runtime version literally just goes out and figures out what the latest runtime version of AMP is and then tells it to you. And it does a little bit of in-memory caching, so it's not making that every time you call it. The optimizer contains a transform HTML function, which essentially takes valid AMP HTML, a couple arguments, and then transforms it into the optimized HTML. So how can we use this optimized function in our app? Well, we have our Express endpoint, and we can essentially just copy-paste that into another endpoint that's going to be our canonical page instead of our AMP page. And so here you'll notice the differences. We dropped AMP from the URL because now this is our canonical page, so it's just going to be /region name. We also have await optimize in the render page because we're just wrapping our previous render block with an optimize call, and we're passing in the AMP URL. Now, it's important to pass in the AMP URL because when you render an AMP page, you need to have a link rel canonical that points to the canonical version of the page on your site. And by passing this into the optimizer, we tell it to invert that because we're turning this into the canonical version of our page, so it needs to turn that link back into a link out to the AMP page. Now, when we do this dynamic, when we apply the optimizer and we compare that to our previous CDN result, that's a pretty marked improvement. We get a full second improvement over the CDN time. And now we're painting in 1 second, which is really fast on 3G. What's interesting, though, is now if we go back and compare this to the AMP cache, we're actually beating that as well. So by using the AMP optimizer, you can actually beat the AMP cache in rendering your page on your domain. Now, of course, I hope that I've drilled it into you at this point that CDNs are really important for performance. All of these performance benefits from the optimizer that I just showed, we only get those when we're rendering from the CDN. So if we want to truly maximize performance, we need to render from the CDN as often as possible. That's where evented rendering comes in. For our dynamic rendered page, we added Firestore and Cloud Functions to Firebase Hosting to generate our HTML on the fly. Now we're going to add one more Firebase product, Cloud Storage. And what we're going to do is we're going to pre-render content on demand when the data changes and store it in Cloud Storage as a flat file to deliver later. Here's how it works. When data changes in my Firestore database, that triggers a Cloud Function because you can do that with Cloud Functions. It's really great. The Cloud Function then does 2 things. First, it renders the HTML and writes that to a Cloud Storage file. And second, it sends a request to purge the hosting cache for that specific URL. And what this enables us to do is have the content change when the content changes, not every time it's requested. So that all happens when the data changes, but what about when the user requests a site? So the user makes a request, and again, we're going to proxy to a Cloud function, but this time, instead of calling out to Firestore and grabbing all the documents, instead, we're just going to do a transparent read-through proxy straight to Cloud Storage. So we're going to say, I already have this stored as a flat file, so I'm just going to serve that up. And in fact, this is mimicking a lot of what the Firebase Hosting origin does itself when you deploy a static site to Firebase Hosting. The result is that all subsequent requests are going to be served up by the CDN. And because we are invalidating the cache on the CDN whenever the content changes, we can set this to be essentially an indefinite server cache, which means that we're going to have that CDN performance more often. So the benefits here are pretty clear. You still have fresh content available instantly, just like you do with dynamic rendering. Unlike dynamic rendering, though, we only pay the cost of render when the data changes, not when the user requests the site. So if my data changes once a day, then I'm only paying that cost once a day instead of every time a user comes to my site, or every time the cache expires when a user comes to my site. You can also cache until the content changes. And because of the performance benefits of CDNs, this is kind of the critical piece. This is what lets you have static-like performance, even though you're rendering content on demand in an evented way. And the only real downside here is that this may be kind of unfamiliar territory. If you're not super familiar with Cloud Functions and sort of piping things through events, this may be a little weird or scary to you. But we're going to walk through some code, and hopefully it'll get less so. So here is where I set up the 3 functions that I use to listen to when I need to re-render the page. And it's 3 because, remember, I'm going to need to re-render the page whenever any data changes on the page that I care about. And so for escapable, that's 3 different things. If the region document changes, I need to re-render the page. If a location that's in the region changes, I need to re-render the page. And if a room that's in the region changes, I need to re-render the page. So for the region, it's really simple. Just whenever it changes, period, I fire off a render. For the location and the room changes, I pull the region out of the document and say, OK, this is the region that I'm going to need to re-render. Also pretty simple. Now, the actual update region page is just rendering strings, basically. So we call the same render function that we used to render the HTML before, but now we call it with the data that we're fetching because we're just triggering it at a different time. So we're essentially doing the same thing, but triggering it when the data changed. We're then also generating the optimized HTML, and then we're storing both of those in Cloud Storage with this write and purge function. And the write and purge function, first, we just use the Firebase admin SDKs for Cloud Storage to save the file into Cloud Storage. And then I'm going to tell you a little trick. So by making a request to Firebase Hosting with the purge method, you actually tell the CDN to purge the contents, and then the next request will go through to the origin. So basically, you can send this request, and then that'll cause the next request to be fresh content. Now, fair warning, this isn't exactly an official API, and it might change in the future. We're taking a look at how we can incorporate this more officially into the Firebase Hosting product, but it really enables some powerful use cases, so I wanted to give you kind of a sneak peek. Now that we've stored our content and purged the cache, we need to actually serve it up. So back to our Express app, we just write a simple bucket proxy. And all that does is, again, using the storage admin SDK, we create a read stream. We set the cache control. And this time, you'll notice that the server max age is a large number. That's actually a year in seconds. So we're saying cache this on the server for a year. And the reason that we don't care is because we're going to proactively invalidate that cache when the content changes. Then finally, we just pipe the content from our read stream down as the response, and that's all we have to do. So that was a lot of steps, and I'd like to show you how it works in practice. So can we jump back to the demo, please? All right, so here we go. I've got my site, and I'm going to jump over here into my Firestore database. And I have a new room that I've been working on. The only thing that's left to add is the region. So region SFO, add that there. Now I'm going to jump over to my functions logs. And within a couple seconds, we should see that the change to my Firestore database has caused the function onRoomChange to trigger. Any second now. There we go. And so you can see onRoomChange started executing, and it did some stuff. So what we've done is we've rendered an AMP optimized version. We wrote amp/sfo.html, sfo.html, and then we purged both of those URLs, and it's done. Now if we jump over to cloud storage, you can see that I have the structure of my site in HTML in cloud storage. I'm going to refresh this really quickly. And once it loads back up, I'm going to click on SFO, and you can see that this was modified just now. So it's updated here, but of course, that's not actually super impressive if the website itself doesn't update. So let's try it there. So I'll hit refresh, and there we go. Now we have a new room, Flames of the Firebase, that just appeared on our site. And if I switch over and look at the dev tools here, you can see that that response served up in 841 milliseconds, which isn't super fast. I mean, it's fine. But you can also see that that was a cache miss, because this was my first request after having purged. If I go back and reload again, jump back here, now we have a response time of 10 milliseconds. And it's going to stay that way on this edge server until my content changes. Can we go back to the slides? Now, even when just comparing the origin performance and not whether or not it's being served up by the CDN, I found that the evented rendering has about a 32% speed up over dynamic rendering, mostly because you're just proxying through to a flat file in GCS. And that's notable, but again, it's not the most important thing. The important thing is that we get this optimized CDN level of performance almost all of the time. And it's only just after our content changes and the first request to each edge server after that that we ever get anything other than this super optimized, super fast performance. So hopefully this has given you a few ideas to sort of go out there and try for yourself. And to go back to the original question, I don't know if I've completely answered it. You know, what makes a website fast? But I do have an answer, and the answer is super cheesy, because what makes a website fast is you. You do. Web experiences aren't fast because of magic. They're fast because developers care about performance and work hard to make it better. So we can provide you some of the tools and some of the technology that help you do this, but at the end of the day, it's your elbow grease and you digging in and caring about performance and making it work that is going to give your users the experience that they deserve. That's all I've got today. I hope to get your feedback on this session at google.com/io/schedule. I also want to call out before I go that Jeff Posnick is giving a talk in an hour called Beyond Single Page Apps, Alternative Architectures for Your PWA, which also has tons of interesting things about building performant PWAs on Firebase hosting with Cloud Functions. And it's a totally different approach than I took here. So if you want to sort of get even more ideas to help you get started, I'd recommend that highly. That's all I've got for today. I will be heading over to the Firebase Sandbox directly after this, and thanks for taking the time.
Thank you for joining this session. Brand ambassadors will assist with directing you through the designated exits. We'll be making room for those who've registered for the next session. If you've registered for the next session in this room, we ask that you...
Hey there, IO Live. I am Todd Kerpelman, and I am here inside the very crowded and popular Flutter Firebase Dome, talking to Michael Thompson, product manager of Flutter. Hi, Michael.
Hi, how are you?
I'm doing well, thanks. So there's a lot going on here inside the dome, as well as some stuff going on outside. Tell me, what are we looking at here? What's going on behind us?
So this is our showcase wall that illustrates the wide selection of different types of apps you can build with Flutter. So Flutter, of course, is Google's multi-platform SDK for building mobile apps for both iOS and Android. So what we're seeing here are some apps that look very traditional iOS look and feel. We're seeing an app from Google over here from our Atlas team that has a much more traditional material look and feel. And we're seeing a number of apps that have a much more custom look and feel, where they've tried to create this more brand-specific extension, and where the layout of the app really is an extension of that brand.
And so what else can an attendee find if they're exploring the Flutter Dome?
Yeah, so what we're seeing here is the end result. And the thing that's really interesting is that's just one of our key components of our offering. The other thing is we have a great developer experience. So when you try and create UI, whether it's more traditional or more custom, we found that there's a lot of iteration going on. You may have one notion of what your screen should look like, but it's really helpful to take that and tweak it, and step by step to build up your UI. So for that, we built something called Hot Reload, which is the ability to update the current screen you're looking at, and in just a few hundred milliseconds, push a small change to that running application, preserving the whole state without having to re-navigate back in. And that's actually an example of all the great engineering we do in this project. So when you use Hot Reload, you're running against a virtual machine, which is how we can do those quick reloads. But when you're running these apps in production, very importantly, we compile these to native ARM machine code. So you get the combination of fast iteration speed at development time with fast execution speed in production builds.
The thing about Hot Reload that I think maybe not everyone gets at first is this is actually running on a real device. Like the game, you're editing real code.
Yeah, so this is, we do a lot of really cool engineering in this project, I think. So when you run during development time with your Flutter app, we run on a virtual machine, so we can push these tiny updates to the running app and see that effect right away. But when you're running all these apps behind us in release mode, we actually compile straight to native machine code. So we get the combination of this fantastic performance with 60 frames a second in production apps and amazing stateful hot reload, where we can update the UI in just a few hundred milliseconds.
Wow, I have to say that is great. As a developer, like, I know sometimes it takes 30.
All right, hello everyone. Welcome to the session for Firebase Cloud Messaging. My name is Subir, and I'm the engineering lead for FCM.
And I'm John. I'm the product manager for FCM.
Awesome. Cool. So as most of you know, FCM is Google's reliable cross-platform messaging service. Developers use this service to send user notifications, data messages to their applications across multiple platforms. And it's also seamlessly integrated with Firebase. What that means is that multiple Firebase features like predictions, A/B testing, analytics just work seamlessly with FCM. And we'll touch base with all these today. Talking about scale, the infrastructure that powers FCM is supporting more than 1 million active developer accounts today. And that means These developers are sending notifications to more than 3 billion devices every week. So it's a very large-scale infrastructure.
Well, as Sabir mentioned, Firebase Cloud Messaging is a part of Firebase. And Firebase is a set of products that helps developers like you to build better apps, to improve app stability, and to grow your app from your first user to your millionth. This talk is focused on Firebase Cloud Messaging specifically, but I'd encourage you to look at the other products and features under the Firebase brand, many of which will be showcased right here at I/O. FCM is the successor to GCM, or Google Cloud Messaging. And for those of you who are familiar with GCM, and especially for those of you who rely upon it every day, have no fear. FCM builds on the exact same infrastructure as GCM and adds many great new features. In just a few minutes, we're going to talk about the new and improved client SDKs, the new Firebase integrations, and our new version Send API, which makes sending to cross-platform targets easier than ever before.
All right, so before we take a deep look into all the integrations and the features that John just mentioned, I'd like to take a step back and understand some basic concepts in FCM. So the most common use case in FCM is to send a message to a particular app instance. What's happening behind the scenes here is that the SDK is getting a token from the FCM cloud, and it gets this token. Now this token acts as an address for this device. So whenever you want to send a message to this device, you need this token. Obviously, the apps then upload this to their servers so that when it's time to send the message, server knows how to reach this device. Server has to authenticate with FCM and send the message. FCM Cloud figures out how to route this message to this particular app instance, regardless of what platform it is on. Another popular feature in FCM is topic messaging. And a lot of developers use this feature when their use cases are to send the same type of notification to a large number of devices. Common examples can be sending a news app notification to folks interested in certain topics, a sports app, for example, notifying, hey, there's an update on your team that you follow, etc. In this case, every device subscribes to topic. It's a one-line code on the client side. And instead of sending one message per device, you only send one message to FCM Cloud, and it's fanned out to all the devices subscribed to this. And this makes it really easy and scalable for developers to reach a large number of devices. Another way of sending and receiving messages from FCM is to open a persistent connection from your application server to the FCM Cloud. Now, you can do this using the XMPP endpoint that we have. You can send messages to topics or directly to devices on this connection, and you can also receive messages from your application. A popular use case for this is when developers want to notify that their application has actually received a message. So they can make other changes or send follow-up notifications, etc. Right? So we talked about scale earlier, and I would like to highlight that latency is super important to us. We'll want to deliver your messages as fast as possible, as long as the devices are connected. Now, the numbers you see here are the in-network latency numbers. That means time when the notification gets to the FCM backend until it's dispatched on the carrier channel. And any change we make in our infrastructure, we're committed to not impact these negatively.
Earlier in the presentation, we promised to give you a look at the latest and greatest Firebase integrations, and that's exactly what we're going to do now. So FCM integrates deeply and seamlessly with all of the Firebase products, including analytics, A/B testing, predictions, and more. And these products all work together synergistically to help you produce more effective, more understandable notifications for your users. So let's walk through a quick demo of those new features. So let's say that I'm an app owner, and my app works by encouraging team-based competitions. So my users will have some sort of an army, maybe a robot army, and they're going to fight against other armies, like the Sparky army. And each team basically competes to get to the top of the leaderboard. Fame and fortune ensue. They can buy upgrades to their army with a premium currency that I call BattleBucks. So one of the things that I like to do as an app owner is to send notifications to my users to bring them back into the game. And I'm particularly interested in sending notifications to my paying users because they're the ones who actually keep the lights on in my company. So I have this idea that sending a message that appeals to team loyalty is going to be the best way to talk to these users, and it's going to be better than the status quo that I have. So what I'm going to want to do is to build an A/B test to test that theory. And here you see in this UI screen the beginnings of my A/B test, where I'm setting up all the parameters. This is an actual UI screen from the Firebase console, where you can set up such an A/B test. So I'll walk through some of these different items on the screen so you can understand what's going on. First, we have the experiment name, which is really for me, so I don't lose track of what my test is trying to do. It's the theme text test, which I practiced saying many times before I got up on stage today. And the description is to test team. No, I didn't practice enough. Test team theme text versus status quo. I actually set up that problem for myself, so I have no one to blame. This is going to be targeted towards my paying users using Firebase predictions. So with Firebase predictions, another Firebase product, I'm actually able to target the subset of my users who are predicted to spend based on their history within my app. So automatically, and by integrating the Firebase SDK, I get access to Firebase predictions, and it's just a few clicks to turn it on. Here I'm going to be targeting my users who are predicted to spend real money in my app because they're the users I care about for this test. And I'm going to send it to 5% of those users so I can test this on a smaller population before rolling out more broadly.
So one quick point I'd like to highlight there is that if you have Google Analytics events for spend, and you've turned on predictions, you don't have to do anything in your SDK on top of that. Predictions are available to you, and we'll create these spend and churn buckets for you. So,
all right, very true. So as you proceed through the flow, this just kind of sets up the variance of my A/B test. For those of you who are familiar with A/B testing, you essentially just have different experiences, A, B, maybe C, that your users can see, and you just look at the metrics of interest for each of those groups within your audience, and whichever set of metrics you like the most, that's the experience that you know is having the impact you want it to have. So this is essentially the three variants that I've got set up in this test that I was describing earlier. I've got a variant A, which is going out to 33% of the users in the test, and that's the old status quo. It's my boring old text that says, get 20% off BattleBucks, pretty generic. And then I've got variant B, which is the new hot version of my text, which says, hey, Sparky, get 20% off BattleBucks with this code. So that's appealing to the team spirit and the affinity that they'll have for their team. I think, as a product manager, maybe that's going to do better than the old way of doing things. Both of these are going to be compared against the control group, which is no message at all. And at the end of this experiment, all of our deltas in our metrics, user engagement, those will be measured relative to not receiving a message of any sort. All right.
All right.
More screens. So in just a few clicks, you set up the goal for the test. My goal is user engagement. I want my paying users to come into the app. So that's the goal I set. I also want to check a few other metrics like retention and purchase revenue, so I can have a more holistic view of what's going on with this experiment. And I'm going to look at all of these metrics together after my test is concluded to be sure that the winning variant is really winning on all counts. So sometime in the future, about 7 days later, after I've sent out those messages to those different groups, I'm going to have a screen that looks something like this, which tells me about the actual results of the experiment. And what do you know? It turns out that the theory was right. The themed text was the clear leader for this experiment, and it actually did outperform the status quo and the control group. So that had an improvement over control for user engagement. I'd also be able to dive into some of the other metrics, like purchase revenue, to make sure that that wasn't strangely adversely impacted or anything like that. But once I'm satisfied that variant C is actually the winner, theme text, it's very easy for me to roll that out to the remaining population of my app by clicking the big blue button up at the top of the screen that says roll out the leader. And then that message will go out to the remaining people in my app who haven't seen the message.
Awesome. So as we know, FCM is cross-platform service. That means you can send notifications to Android, iOS, and web applications. Late last year, we announced a new API, which makes it even simpler. And what this API allows us to do is to override platform-specific parameters in a single request. Just type. What it also allows you to do is service account-based authentication. So if you use any other Google API, you probably are familiar with it. It's pretty standard. It gives you short-lived tokens to authenticate with our service, etc. And it's also integrated with Firebase Admin SDK. So if you're a user of Firebase Admin SDK, all these features are already available. You have the convenience methods for authentication, sending messages using this API, etc. There is a deep dive into Admin SDK and a talk on that later today. So and they're going to demo some FCM things with it. So if you are interested, please attend that. So let's take an example of this API. Let's say you want to send a message to your topic for sale watchers. Now, these are people interested in sales. You can include the main items like title and body in the main notification body. And now, if you want to specify what will happen if somebody clicks on this notification, on Android, you have a field called click action to tell which activity to open. So you can specify that in the Android message section. And then on iOS, this field is called category. Same purpose, but different name. So you can specify that in the APNS part of it. And you can specify your platform-specific fields here. They will be passed as is to the platform so that they are rendered the way you expect them to. This API is extendable. You can also specify web parameters here. We can also add more platforms in the future. So I highly recommend you checking this out. All right, so we talked a lot about Firebase Cloud Messaging and its integrations in different features. If you're already on FCM, you already have access to all this good stuff, so job well done. Congrats. But if you haven't moved from GCM yet, it's time to upgrade. All right, so let's walk through quickly on the steps that are needed to move from GCM to FCM, and I'll cover each of these quickly. First is to have a few clicks on the Firebase console and add your apps to Firebase. So for each Android application, you'll have to enable Firebase for that application. Just to mention, these steps are specific to Android. Next step is to change your dependencies. So instead of, in the build Gradle file, instead of using Play Services GCM, you should move to Firebase Messaging. Just a one-line change. And now the fun stuff. Let's start taking things out of our manifest. So you don't need to declare any permissions with FCM. These are automatically handled by the SDK. So you can just take these out. And if you're using GCM, you probably had these receivers. You don't need these anymore either. You can take them out. The FCM SDK automatically merges in the receivers it needs. So on the server side, when you talk to the FCM cloud, you should update the endpoints to the FCM endpoints. We highly recommend you doing this. The request response format is the same. Your request will continue to work as is. You just need to update your URLs. And lastly, some code changes on the client side, and you need to move to the new messaging service, Firebase Messaging Service. It has the same method for when you receive a message called onMessageReceived. So all your logic remains the same. And you also need to move to the Firebase Instance ID service, which also has the same method as before, like onTokenRefresh. That's it.
That's it.
That was easy.
So
right?
easy.
As I mentioned, we have a migration guide at the link mentioned here if you want more details, and it also covers other platforms.
OK. Well, that is not so bad. But we have picked up a couple tips along the way that we'd like to share with you, starting with the first one. Let FCM manage your registration retry logic. It used to be the case that in GCM, it's possible to not get a valid registration token back from the GCM cloud. In FCM, we automatically handle all of the retry logic for you, so you don't need to replicate the old code that you would have had in your GCM implementation. So just let FCM handle it. It'll do it. Second tip, avoid using GCM and FCM in the same app at the same time. because they'll try to do the same things and potentially conflict with each other. So when you're moving from GCM to FCM, just start clean, clean out your GCM implementation, and put the FCM implementation in place. That's the way to do it. The third tip, store 1 token per app instance. They are mutually interchangeable between GCM and FCM, so you don't need to maintain separate lists of tokens between GCM and FCM. All you need is 1 list of tokens. They're just tokens. And when you replace a GCM token for a particular app instance, make sure you replace that token rather than appending it to the list or doing something else. Those tokens do translate to the same app instance. And finally, make sure that you're periodically refreshing your tokens so you get a valid token at all times. And Sabir has some more details about that last point.
I do. So fun stat, we receive around 40% notifications for devices and tokens which are invalid. These are tokens which have been unregistered, they have been invalidated by other platforms, etc. And this is basically extra load on your servers plus our servers. You are storing these tokens, you don't have a fresh state of your devices. So how can we fix it? Well, we can do 2 things. First is to have the observers in the onToken refresh method. This is an example on iOS. So when you get the onToken refresh method invoked, you should upload the latest token to your server and override the state on the server as soon as possible. That way, you always have the most accurate way to reach your devices. Again, this is the code on Android. Same logic. When you get onToken refresh, you get the token, upload it to your server. Second thing you can do is periodically refresh your tokens. And what this means is, like, at some frequency, just keep uploading the tokens from your device to the server, so you at all times have a fresh state on the server side. And also, you clean up the tokens that you had previously, which are not being used anymore. The frequency depends on your use cases, but we recommend anything between 2 to 4 weeks should be good enough. All right. With that said, let's do a quick poll by raise of hands. Who here cares about delivery and battery impact? All right, most of you raise your hands. That's a good sign. So let's talk a little bit more in detail on how we can get the best performance from FCM. And for that, let's have Todd Hansen on stage. All right.
Thank you, Sabir. Hey, John.
Hey, Todd. All right, so for the rest of the session today, I'm basically going to ask Todd all of my burning questions about FCM performance so he can tell us all how to make high-performing apps with FCM. And I'll start with our very first question here. Todd, please tell us, what are the newest versions of Android doing to improve battery life, and what are the implications for FCM?
OK. Android versions as recent or as far back as Marshmallow can be doing things that impact your battery life. Let's examine those and see what those changes are. And then we'll also talk about how you can make sure that FCM continues to perform well on your app. So Marshmallow and Nougat introduced Doze and Doze on the Go battery saving features, which disabled some activities when the screen was turned off. We introduced 2 FCM message priorities to allow users or allow apps to decide whether the message should be able to wake the device up when it's in Doze or not. Then comes Oreo. Oreo added background check, which prevents the apps from running in the background for too long. So this means that you can run in the background for a short period of time, and then after that, you can't run in the background longer. We also introduced a temp whitelist, which allows you to access the network for a few seconds after receiving a high-priority message. Neither of these were intended to be sufficient for all applications on all network conditions, which we'll talk about more in a few minutes. In November, existing apps in the Play Store will be required to target O. So many of you are just now starting to deal with these challenges as you're updating your apps. We're here to help. Android P introduces app standby buckets. App standby buckets group apps based on their recency of use and the frequency of use, and provides restrictions so that apps that aren't used as frequently will be less consuming of battery. App standby buckets also changes how FCM works a little bit. In effect, it means that FCM high priority messages should only be used for things that will generate a user interaction, such as a notification or ringing a phone or something. So this is a snapshot from a coworker's device, and it shows you how different apps can be categorized based on the recency and, again, the frequency at which they're used. This particular coworker clearly has Gmail in the rare bucket, and I sent him an email to find out why, but he hasn't gotten back to me. So tomorrow there's a talk that talks more about app standby buckets in depth in general. That's a great place to go. For now, we're going to concentrate on FCM's impact, or the impact to FCM. So this table shows app standby buckets and their impact on high priority messages. You can see that messages have different quotas for different buckets. So clearly, if you're in a rare bucket, you're only going to get 5 messages per day. If you exceed that amount, the messages will be delivered as normal priority. But there's more. If you display a notification, your application moves to the working set. And that means that effectively, if you only use high priority messages for displaying a notification or other user interactions, you won't be limited at all by this change. In addition, if the app is opened, it'll move to the active bucket. And so similarly, it won't be affected at all. So the situations in which you will potentially run into challenges is when, say, you display a notification to a disabled channel, or when you use a high priority message to trigger background work. In those situations, you do not change your app standby buckets, and you could run into these limits.
All right, next question for Todd. So just to summarize, when should I use high priority, and when should I use normal priority?
OK, and the basic rule has been the same since Marshmallow. Use high priority messages only for situations in which you'll generate a user interaction, such as a notification. In addition, I also want to point out that you should not expect to be able to call home to your servers to get additional content before displaying a notification, as the background service may time out.
All right, great. So if I'm feeling maybe a little bit lazy, what happens if I just leave everything in my app exactly how it is today? Like, what's the problem with that?
So let's look at an example, and I'll propose a solution for you. OK, we'll start by looking at a simple chat app. The main premise of this simple chat app is after receiving a high priority message, it goes and contacts the servers to download additional content before displaying a notification. Let's see what happens when it targets Oreo. So we start to see some notifications not showing up. It's not very high, and we maybe don't notice right away, but we start to get some complaints accumulating. So as we start to investigate, we find that 5% of notifications are lost because the network access times out before we can even connect to our servers. And we look further, and we find another 5% of notifications are lost because the background service times out before we can even complete retrieving all of the content. So sooner or later, you've got an angry boss wondering why your app is broken.
All right. Well, that's a big problem.
So a 10% loss rate is pretty bad. We could try and brute force this. We could solve this maybe by letting the app run for a lot longer. To get the failure rate down to under 1%, we have to let the app run for 7 minutes in response to each message. So clearly, that's a lot of battery spend that we're costing users. It could be possible that a user on a poor quality network would have a really bad experience having their app run for their device run for 7 minutes for every message, and they might prefer to choose when to download that content. So let's go further.
OK. Follow-up question. Since background runtime can be limited, what's the right way to ensure that my notifications are actually going to be seen by all of my users?
So clearly, we need a better solution. And let's go into that now. So what we will do is we'll re-implement the app to implement graceful degradation. And graceful degradation is meaning that we'll always display the notification, even if we can't get the content from the servers. So the following steps of graceful degradation are here. First, you display a notification immediately. You can often use the payload of an FCM message to display the content. If that's not sufficient, you can display a placeholder. Then you schedule a job to go and collect the information in the background. If that job completes, then you can update the notification if that's appropriate. If the user opens the app before the job completes, then you would display a spinner and start the job immediately to collect that data. If you do this right, I believe that very few users will actually notice this difference, and those few users will be on poor quality networks, and so they'll appreciate the extra battery savings.
Great. So I think I understand how to handle downstream messages now. Can you tell me how these background limits apply to client-to-server messages?
Yes. So background restrictions apply to whenever your app is running in the background, regardless of what you're doing. So our simple chat app sends outgoing messages using a background service. And so we see that sometimes that background service times out before the message is sent, especially if we have to retry sending the message multiple times because of, say, a network issue or something. So one solution that you could do is you could use a foreground service to send these messages. However, a better solution would probably be to use FCM upstream messaging, which handles the work for you in a more efficient manner. It handles the retries and maintaining the connection and ensuring that the message gets there.
OK, Todd. Well, there's more to life than Android, as this message or this drawing here somehow demonstrates. I'm not sure exactly how. But do you have some more general tips about understanding and improving the performance of FCM?
Yes. So let's walk through the flow of a message through FCM. So this diagram, as we saw before, shows how you're sending a message from your servers through FCM to the device. We'll start by examining when you send messages to FCM servers. As Sabir already alluded to, 40% of messages are targeted at inactive devices. Those are devices that haven't connected to our servers in over a month. Some engineers think that deleting registration tokens upon receiving error not registered is sufficient to solve this. However, we only send error not registered when we're absolutely certain that that registration is no longer valid. So that means that you can accumulate a large list of inactive device registrations in your registration list. A better solution is to periodically refresh your FCM token. Again, something that Sabir talked about earlier. This will often return the same token, although it may update it in certain conditions. But most importantly, this refreshes your registration targets so that you can easily start to identify inactive devices by looking at which ones haven't registered recently.
OK, so I clear out my old registrations that haven't connected in a long time. So I have just one more question for you. Earlier, Sabir said that mean latency for FCM is around 70 milliseconds. And when I test my app, I often find that I experience latencies over 300 milliseconds. What's up?
OK, let's look at the messages as they depart FCM servers to the device. Network latency adds significantly to the latency that you observe. For example, the 80th percentile latency for FCM servers to dispatch a message to you is 120 milliseconds. However, when we add network latency into account, we find that latency jumps to 350 milliseconds. So given your 300 milliseconds, I think you should probably get a better network.
All right. Come on, Google. I was lying earlier about one last question. This is my real last question right here. So I don't get messages when my phone is turned off. I think most people are probably in the same boat. Are a lot of message deliveries affected by this same situation?
Yeah, so what we see is that device availability varies dramatically around the globe. But on an average, we see about 11% of messages are delivered to devices that haven't been connected in the last hour. So that means that when you're sending messages to devices, a portion of your devices, could be as high as 11%, could be higher depending on where you're located, are offline at that point, and they'll receive the message when they get online. And so we really do recommend that you take those users into account and make the app work well even when the users aren't available. There could be reasons that they're doing that, like an airplane ride or something like that.
Yes, that's what I do. OK, well, thank you very much, Todd, for all of your great answers to our performance questions. If you'd like to learn more about FCM, or if you'd just like to stop by and say hello, we'll be in Tent B, Office Hours Tent Table B tomorrow morning at 8:30 a.m. until 9:30 a.m. We'll be there smiling with a cup of coffee. Please come and see us. And finally, oh, well, wait, back. That's the one. We want to hear from you. We'd love to hear your feedback on this session. Please go to the link on the screen, google.com/io/schedule. Leave some feedback. We'd love to know what you thought. Thank you. We'll be at the Firebase Sandbox right after this.
Hey there, IO Live. Todd Kerpelman here, and I'm here with Jen Tong, who is apparently using the power of the cloud to find new planets. No big deal, you know.
Yeah, why not?
Sure. So Jen, what is going on here at this booth?
So behind us, we see Project Panoptes, which is an open source project that includes open source hardware that is composed entirely of commercial, off-the-shelf components. And it is intended to be low cost enough for educational institutions and hobby astronomers to build these robotic telescopes and contribute to the project.
And so what happens once they build these robotic telescopes? How are they discovering stars, or planets, I should say?
So the way they discover planets around other stars is by combining their efforts using the cloud. So what happens is each night the telescopes will all wake up and look at the sky, and they'll get a bunch of great images of the sky. And then when the day comes, they'll go to sleep, but not really. They're going to start uploading all of their data to Cloud Platform. And from there, we can combine all the data together, aggregate it, and then from that, we can infer the existence of planets around other stars.
And how do you infer the existence of planets?
So planets are very hard to see directly because their stars are very bright and there's lots of glare and they're very far away. In fact, a star only looks like 1 pixel on the camera. So we have to use some trickery to do that. So instead of looking for the planet directly, we look for a dimming of the star when the planet moves between us and the star, kind of like an eclipse, or we call it a transit in a more general case.
And so the general idea is you've got hundreds of telescopes all around the world taking pictures of the night sky. They combine all those images up to Google Cloud, which analyzes them all and looks for a star that dims on a regular enough basis that you think it must be because there's a planet passing in front of it.
That is exactly correct. So we're able to infer that just by having a whole bunch of samples from having a very large fleet of telescopes.
Wow, that's very interesting. Now, if I remember from being 3 years old, stars do twinkle. How can you tell that a star is dimming because of a planet passing in front of it versus normal star twinkling, which is totally a technical term?
Totally technical. And that's a great question because that's part of the stuff that makes Panoptes special. Because we're using commercial off-the-shelf cameras instead of specialized astronomy sensors, we have to compensate for the fact that those cameras are designed to take color photos. Because when a camera takes color photos, it filters some of the light out using this thing called a Bayer filter. And when the star twinkles, it moves around that Bayer filter, and it makes it much harder to count the number of photons, because we don't know how much are getting filtered out by the Bayer filter. So the way we compensate for that is we look for another star in the same picture that has the exact same amount of twinkle. And from that, we can do a relative brightness measurement, because we know how bright those stars should be, because we can identify the star. And that's how we kind of cancel out the twinkle.
And I'm contractually obligated to ask, what awesome Google Cloud Platform features are you using to power Project Panoptes?
Yeah, Panoptes definitely kind of illustrates that boring uses of the cloud can enable really cool stuff. So we are using some simple stuff. We're using some of the simple security controls. We're putting a service account on each one of the devices so we can control access to a specific telescope, can access a specific part of our storage buckets. And then we're using Google Cloud Storage to store all of that data, and then we're aggregating it on Google Compute Engine.
And so the general idea is anybody can get involved, they can build their own telescope, and they can be part of this project, and then if they find a star, they can name it after themselves. Is that basically it?
Well, naming stars is a more complicated issue. And individual Panoptes telescopes don't actually discover a star themselves. It's kind of like a team that collaboratively accomplishes a goal. But yeah, anybody can get involved. We especially like to work with hobbyist astronomers and educational institutions because we want to kind of inspire a love of astronomy in the youth around the world.
That's good. And how would I get started if I wanted to?
So I encourage you to go check out projectpanoptes.org.
All right, so you heard it here. Go to projectpanoptes.org, and you too can name a star after you. Jen totally promised that you can do that. Hello, IO Live, and I am coming to you from the cloud, or I guess more specifically, the cloud section of the IO space. And we're just going to do some demos. So I'm here with Sarah Robinson. Sarah, what is this that we're looking at here?
We are looking at a demo of our cloud machine learning APIs, specifically highlighting our video API, speech API, and translation API. So what these let you do is they let you access a pre-trained machine learning model with a single REST API request. So you don't need to know anything about how machine learning works to use them.
Awesome. And what is this game that we have set up?
So we're going to see how we compare to our video API. Should we take a look?
You mean like me against a computer?
You against our pre-trained model.
All right, well, let's see how it goes.
Challenge?
I think so. What are we going to do in this game?
So what we're going to do is we're going to play a video, and I'm going to have you try to annotate the video as it's going.
Good evening. Hi. I'm going to present electronic design for Android ThinkSystems on modules. My name is Jinal Dalal. I am a hardware engineer for Android Things, and I'm really excited to present to you this particular talk, especially because I built hardware for Google for about 10 years, and I built for consumer and enterprise. So everything that you see here are the things that I've learned over the past 10 years, and please don't repeat the same mistakes. All right, let's get started. So before I get into the details of how to build hardware, Android Things has System on Module, which is the core component of Android Things, which has CPU, memory, power, as well as Wi-Fi and Bluetooth. This is the core component of Android Things, which allows you to take all the complexity out of your hardware and put the wrapper around it. So going into the detail, this board is about 2 inches by 2 inches, and it basically is something you can buy off the shelf today. So if you were to think of an idea that you want to build using this as the core module, you don't have to go out and design it, and all the type of complexity around this has been taken away from it. As part of this particular talk, the thing that we built internally to Google in a very simplified way is this baseboard. This is the board that goes with the SOM and allows you to add more functionality to it. So imagine use cases like cameras, routers, and displays that would like to use the SOM as the core component. It's the baseboard that you end up designing for your solution. It has, in this particular case that I designed, it had a USB ports, audio, HDMI, buttons, LEDs. So this is something you can design. This does not require a whole team of hardware engineers to go out and design it for you. And I'm going to walk you through those steps of how to actually do those things as part of this talk. All right. Before jumping into the details of hardware design again, Android Things joins this group of Android platform, which are about 2 billion devices that exist today, as well as it takes advantage of the Android framework, so it allows you to use what you already know. For example, even in cases of whether it's cars, TVs, watches, and Wear OS, as well as cell phones, you're already familiar with these platforms, and now you're using this to build IoT devices around it. From the ideas perspective and from what this enables, there are a bunch of options to go out and design. In terms of home, you can think about security systems, speakers, routers, doorbells. For enterprise, point of sale, interactive ads, vending machines. I'm going to share some examples of that. And for more of buildings and enterprise buildings, it's cameras, HVAC, smart meters. And for cars and fleet management, you could think about smart parkings, car audios, and so on. The opportunities are endless. There will be about 20 billion devices by 2020. And so this really opens up the whole opportunity. In terms of hardware, how many of you here have actually designed hardware or been part of the design? So having realized a few of them, this is really we are at this point where hardware is really not about is different or hard. It's more about how you actually go through the process to build it. So as much as how software is built, hardware is built differently, but the focus should be really on making those small steps to get you to the right platform and to the more solid hardware. So there are three things that have happened in the past, I would say 5 years, that have phenomenally changed the way hardware is built. One, there are 3D printers. If you think about a box or a photo frame or anything that you would like to design, you can actually go print it out today. This, plus the IoT platform that we are building, would enable you to build a platform or a product around it. Secondly, there is crowdsourcing. And third is the cost of manufacturing. All these three things have allowed you to experiment with the ideas without actually needing a big team to go out and do it. Again, going back to this example, this, along with the wrapper, took us one person at Google to go out and build it. These are just two general examples of what you can do with it, with the existing solutions. For example, a vending machine that doesn't have a display can start using display and phone for its checkout. And with this Android Things platform, you are able to actually experiment with it. As well as the pill dispenser, again, allows you to manage the schedule for the pills, as well as notifications and so on. Again, making something that's been there for a while and making it smart. In terms of, so before we talk about the process again, this is the board that I was just showing you. The red is the baseboard that I designed. The green is the system on module that sits on the baseboard. As you can see, this was for an NXP device. So the SOM is actually an NXP device, but the baseboard is flexible. It allows you to add any features that you would like to use for your product. All right, so process. The first step for hardware design is planning. Planning really means identifying the core components and features that you want, and then sketching it out on paper to figure out how it all connects. Second is prototype. Prototype is about actually buying off-the-shelf hardware and implementing it as an experiment. Third is design. From a software standpoint, design is making the UI. From a hardware standpoint, you're really getting into the nitty-gritty of using the schematic tools, the layout tools, as well as releasing those for manufacturing. And last is qualify. Each of these steps needs to be followed and are really critical for the success of your design, and it needs to be repeated to ensure that you can keep building more volumes. So let's go into the detail for plan. Planning from the hardware standpoint is really one, identifying the components, the features that you want. So you want a USB support, you need a USB connector. If you want audio, you need to add audio connector. If you want to use a display, this again needs to go here. It's critical to actually sketch your design up before you start implementing it. This is a critical step, and you need to think about all the features as well as the rest of the things, which is power and size. So this is in a different dimension. Think about how hot this product is going to get. Where is it going to be used? Is it going to need cables from your product standpoint? Beyond that, also think about the cost very early on so that you don't end up buying components that are expensive from the beginning. And then finally, how is it all powered? Is it a battery powered or AC? This also matters in the design. So that's the planning piece. Next is prototype. I want to emphasize the value of prototype. When you start thinking about your design and you think that you need to wait all the way until you actually design everything in schematic and layout, it's already too late and you already spent thousands of dollars to get there. So before you do that, try and see if you can buy components online, put it on the breadboard, connect wires, and get your basic functionality in place. Again, I'm going to repeat, get your basic functionality in place as much as possible so you know exactly what you are using, how you are using it, how much power does it draw, and even to the extent that how does it look. If you can 3D print something or use a cardboard, it's worth trying it, because by the time you get it to the production, it's going to be too late. Design. This is something where most of the software developers are going to be challenged in terms of how to actually start implementing the schematics. Fortunately, again, in the last few years, there are a lot of open source options that you can use to start sketching out your design. As an example, KiCad is an open source schematic and layout tool that you can use today with no cost and try a simple board. There are a few other options as well from Altium, Cadence, and Eagle, and each one has its own pros and cons. For example, depending on how many layers the board is, or the cost that you're willing to pay for this tool, each one has its own trade-offs. In my particular case, we ended up using Altium, mostly because it's what I knew, and as well as what I was trying to build, which was an 8 to 10 layer board. All right, let's take a little bit deeper into what a schematic really is. So from a hardware standpoint, the schematic is a 2D representation of your design. Every component that you can think about that's going to be on your board needs to be on the schematic. As you can see onto the screen, on the left side is the capacitors that's marked as C1, C2, which are the reference designators. The one in the yellow are generally ASICs or connectors, the components that are tied to these discrete or components. There is ground, which is represented by the lines, which represents the ground of the board. There is a power, which is the input to your circuit. And then all these traces that you see are all your connections. They're physical traces that are going to be populated onto the board to make these connections. Next, after you are finished your schematic, the next step is to start doing the layout. Layout is, in some sense, a 3D representation of what your design is. You start thinking about where the components go physically on the design, how they are routed. Not going into too much detail, but this hardware is tied to physics. And so how you run your single-ended and differential pairs, like clocks and signals, are critical in the design. And this is where you can leverage either some help from online schematic or data sheets, or work with somebody you know. But this is where you need to spend some time thinking about how your board needs to look, where the key components needs to go. This is what the board's layout looked like. And this is just one of the layers. There were 8 layers on this board. The traces or the lines that you see going from top to the bottom are essentially the physical traces that have been routed to a connector. The yellow, I would say, text is reference designators. And if you care about how you're going to debug this board, you need to ensure that these things are placed properly. Similarly, some of the symbols represent where the components needs to go. Once you're done with the layout, the next step is to see what exactly it looks like. And this is pretty cool. In hardware, you can actually start thinking about, not only thinking about what you are trying to build, but also feel and kind of see what it is. And this is where things get really exciting. You need to take the time to actually look at where your components are in this framework. For example, are my buttons in the right place? Is LED accessible? Are the connectors accessible for connecting? This is where you can physically check every single thing to make sure that they're lined up properly. For example, one of the issues that we found when we were designing this board is the LED was actually placed in the back. And so it wasn't visually possible to see the LEDs from the front when they are blinking, especially for error LEDs. So it's important, again, to think about these as part of your design. After you're done with this, what happens next is really taken over by the manufacturing company. But what you need to send them is the Gerber files. Now, if you don't know what the Gerber files are a representation or a software text representation of each of these components, the size of the board, the traces, the holes that needs to go onto the board, and as well as all the connections. This is a file that you then send over to your manufacturing company, who then ends up building it for you. It's important for them to not only check this for you, but this is also something that they will help you confirm that they received all the right information. A critical step in this process, even though it might seem simple, it might, in my case, there was an instance where they received the files, but they were corrupted, and they couldn't actually build the right board. So expensive and important step that you need to pay attention to. In terms of manufacturing, there are two options today, which is really great in terms of the cost, and there are trade-offs for each one. One is local. Once your board is ready, you have your Gerber files, you could release it to somebody locally, either it's US or somewhere else, which generally cost higher, and here are a few examples of which companies you can use. Or you can do it offshore. There, the trade-off is its cost is cheaper, but it also takes much longer time for you to receive your boards. Kind of key takeaways for manufacturing. One, test every board. It is important that you're building your board for the first time. Do not make the assumption that it's the replica and it's just going to work. You have to test every single board that comes out of the line for the first time. Two, visually inspect before you actually start powering it on. There was an instance where I had the capacitor reversed, and as soon as I plugged in the power, it actually blew, and there was real fire. So this is real. You got to pay attention to your design. It does matter how careful you are before you actually turn on the power. And third, if possible, don't wait until the boards are shipped to you. Go to the factory if you can, see how, as soon as they come out, and make sure that they work as intended. There have been instances where by the time they reach after 10 to 15 days, you might find a bug. And now it takes another set of changes and time before you can get this error corrected, versus in software, you can just do it in a few seconds. All right, once you have your board, you received it, you checked for key components, whether they have been populated properly or not. The next step is to debug. If you have some basic EE skills, you can use a multimeter to check your signals and see if they are wiggling. You can use a scope if you have one. But really, the key message here is try and debug as much as possible. I'll give you one example here that is not obvious to you, but on the left side, or on the right side for you, is the one that is marked as D is a diode. And what we realized as part of our manufacturing process is that the diode was actually reversed. And this diode actually serves a SD card. SD card wasn't detected. Again, visually really hard to see, but this ended up being a bug in our design, where the diode was placed reversed and ended up causing us a no detect for the SD card. Thermals. I'm briefly going to touch on thermals, but this is an important aspect of the hardware design as well. So you would assume that if the hardware works on your table, it's going to work on your desk, it's going to work everywhere else. That's not true. As soon as you start bumping up the temperature on the hardware, you will start seeing all kinds of issues, from shutdown to heating up some components and causing fire. It's important to think about the critical components in your design and make sure you meet the guidelines and the operating spec of those components. If you can detect, in this particular case, I have a heat sink for the CPU. And initially, based on our experiments, we realized that heatsink may not be required. After trying a few experiments on the desk, as well as in a thermal chamber, we realized that this was required to operate the CPU at a particular temperature or range. Again, a small thing in this design, got to pay attention to it. Lastly, mechanicals. after you're done your hardware design and finished the design for it, the next step is what the enclosure looks like. With 3D printing, you can sketch, you can print something out and test it out. Critical here is to look for all the instances where you're going to interact with your design. If there is a button, make sure it's accessible and it's in the place where you want it to be. If it is LEDs, they should be you should be visually able to see them from what is expected out of it. Similarly for connectors, make sure that they're not blocked. It's always worth experimenting and printing something out or use a cardboard to make sure that the EE components are in its place before you go to the next step. In terms of mechanicals, there are two options to actually design this, design it. One is called soft tooling, and the other one is hard tooling. In soft tooling, this is where you use, the cost is higher, the turnaround time is again shorter, and it is really designed for limited use cases. So if you expected the lifetime of a product to be 3 years, a part that is soft tool might last only a year. A hard tool is where you actually use the sheet metal and use a hard tooling solution to build your product. This is higher cost. There is a high NRE associated with it, a slower kind of turnaround, used mostly for high volume products, and it's designed for the full life of the product. This is what you buy when you buy consumer electronics. This is most of the tooling is hard tooled, while all the experimental hardware that you have internally or at your desk, for example, might all be soft tooled. Okay, finally, qualify. I think after you've finished all the aspects of this design, you got to qualify your product from end to end in terms of software. So bring the hardware up, run all the software on top of it, and make sure the design is solid and all the features are meeting your expectations. And set up a pass-fail criteria for them so that you know what's going to happen if certain features are turned on and off. This finishes the cycle from plan to qualify. And in some ways, you would think that you are done. Not yet. Take this process that I just showed, and if you are trying to build a product that's going to be thousands of units, you need to move on to the next phase, which is what I'm going to go through. So EVT is the engineering validation test. The whole process that I just showed you needs to be repeated for EVT. Generally, EVT is about tens of units. And the goal here to validate your schematics, your layout, your design, the core features, the components on the board, and ensuring that it all works. It is not necessarily designed to run all the software that is expected at the end product. The cost for EVT is high. So in some ways, you would think that the cost of the product is going to be high. But that's not necessarily true. There are few reasons why the cost for EVT is high. One, it's low volumes. Two, it is manufactured in a very controlled way. So there's a high cost associated from an NRE standpoint. And then three, the components that you buy are also going to be limited. And so that's going to keep your cost high. Next is DVD. DVD is the design validation process where you validate the design and also involve some of the software teams into your platform. This is also where you test out the software bugs, and generally you find the issues which are 10% of the total yields. So pay attention to those, fixing those, and then ensuring that you are ready to move on to the next stage. In terms of the cost for a DVT platform, is about a few percent lower than EVT. The cost is, again, driven by the cost of the board, the components that you select, as well as the process that you're using. Finally, PVT is a production validation test. This is generally in thousands of units, and you need to ensure that the manufacturing line that you have is set up to handle the volumes that you are projecting. this validates that process as part of this step. In terms of the issues that you find are the 1%. Imagine now you're building thousands of units, and so you're going to catch those small bugs that happens in your hardware, which you wouldn't have found otherwise. The other focus is really on ensuring that the process and the line is set up to go really high. Cost. The cost for PVD is generally less than half or even 1/3 of what the cost of EVT is. This is really where the high volume kicks in. Along with that, the tooling is going to be hard tooling. So that means that you're going to start using much more, much better design solution for your product. Finally, mass production. Mass production is where you are going to start selling your units to your end customers. This is going to be thousands of units, and this is where you start also qualifying your second sources, where you start adding more new components to your design to reduce cost. And the yields are going to be critical. So pay attention to how your product is performing in the factory, especially for those small percentage of failures that you are seeing. This steps is really where the real cost comes in. This is generally, like I said, less than 1/3 of the cost of an EVT or even lower. And you can further push it by using second source, optimizing your processes, even kind of changing some of the design in terms of the components that you have selected and reducing the cost or even removing them. Finally, you would think you're done. Again, not yet. There is a bunch of tests that are required for you to meet before you can ship out to your customers. And each country has its own set of compliance tests, EMI and EMC tests, which is critical to the product, and of course your software qualification. So let's try to wrap this up. In terms of you did the planning, you did the prototype, you did the design, and then you did the qualify. These 4 steps needs to be repeated in each of these EVT, DVT, PVT, and mass production phases. And each of these steps are designed to de-risk your hardware, as I mentioned earlier. If you take these steps and follow it through, most likely your design will not have the issues that would cost thousands of dollars. That's the end of this talk. There are a bunch of things around. If you haven't checked out the Android Things demo, you can go check it out. There's Code Labs. And there are also a few other presentations from Android Things team that you can check it out. And the scavenger hunt. If you haven't tried this yet, you should try it. You can end up getting a kit. And I would love to get your feedback. Thank you.
Thank you for joining this session. Brand ambassadors will assist with directing you through the designated exits. We'll be making room for those who've registered for the next session. If you've registered for the next session in this room, we ask that you please clear the room and return via the registration line outside.
Coming to you from the cloud, or I guess more specifically the cloud section of the I/O space. And we're just going to do some demos. So I'm here with Sarah Robinson. Sarah, what is this that we're looking at here?
We are looking at a demo of our cloud machine learning APIs, specifically highlighting our video API, speech API, and translation API. So what these let you do is they let you access a pre-trained machine learning model with a single REST API request. So you don't need to know anything about how machine learning works to use them.
Awesome. And what is this game that we have set up?
So we're going to see how we compare to our video API. Should we take a look?
You mean like me against a computer?
You against our pre-trained model.
All right, well, let's see how it goes.
Are you up for the challenge?
I think so. What are we going to do in this game?
So what we're going to do is we're going to play a video, and I'm going to have you try to annotate the video as it's going. And then when it's done, we'll compare the annotations you came up with our video API.
All right, let's. I'm feeling confident. Let's see if I can beat this computer. All right, here we go.
All right, so let's take a look at this video. and we're going to play against the APIs. We're going to play against the video API. So when I hit play, type what you see.
My typing is terrible. Woman, phone, lost, suitcase, she's still lost. Wait, no, now she has Google Trips.
Okay, so we can skip to the end of the video.
But wait,
We won't play the whole thing, but we saw about half of the video, so we can see that you found 13 items. Video API found 89 items, but it was a valiant effort.
Once again, beaten by a machine.
Do you want to take a look at the API response in a little bit more detail?
Yeah, let's take a look at what we got here.
Okay, so this is everything that the video API found. So we can actually skip to the points in the video where it found these things. And then if we want to look at the JSON response from the API, we can do that here. So we can see all of the different entities it picked up in the video. And we can also take a look at what the speech API transcribed from this video. So this is an entire transcription of the audio from that video using our speech-to-text API. And we can even use this to skip to various points in the video. And then finally, I'll show our translation API. So let's say you're a user somewhere else in the world and you want to translate a video into your own language. You can go over here, and we can try it out in French, for example. We can also translate the video API entities there. So that's an overview of our machine learning API demo.
Hey, if you liked any of this fancy computer vision stuff, want to find out more, check out this conversation between Sarah and Yufeng about object detection using TensorFlow on iOS.
What does it take to build a custom object recognition mobile app? Starting from raw data. We'll find out on this episode of Cloud AI Adventures. Today, we're joined by Sarah Robinson, a developer advocate on my team who also focuses on machine learning. She created an app that recognizes pictures of Taylor Swift, and she joins me today in the studio to discuss how she accomplished it. Welcome, Sarah. Thanks for joining me.
Thanks for having me. Super excited to be on AI Adventures.
So you wrote a sensational Medium article that I've got open here about your Swift detector, which kind of showcases end-to-end machine learning, from gathering and preprocessing the data to training and serving from Cloud Machine Learning Engine. And there's even Firebase and an iPhone app in the mix.
Lots of different tools.
Yeah, definitely. It's super amazing. What inspired this project?
So I had seen a couple of other blog posts on the TensorFlow Object Detection API, and I've been wanting to try it out. These blog posts did things like detecting pets, whether there was a cat or a dog in an image. I saw another one about detecting raccoons.
Oh, wow.
So then I thought I wanted to try it on my own with some training data that I found. And the easiest thing I thought of was to just look at my Google Photos and find all the pictures of myself.
Right.
To train a model to recognize me. Had lots of selfies, so I had enough training data.
Yeah, and that search function on Google Photos, super helpful.
It's pretty great.
Yeah.
So I trained that model locally. It works pretty well. But I wanted to build an end-to-end demo. And I know a little bit of Swift, so I thought it'd be cool if I built an iOS client to make a prediction request against my model, which made me think, why did I build a model to detect Taylor Swift? Because why not?
Swift with Swift. Perfect. So it looks like here you're using the TensorFlow Object Detection API to find Taylor Swift in these pictures. Can you talk a little bit about what that is and how you use it? What was it like to use it?
Yeah, sure. So the Object Detection API is some utilities that make it easier to recognize objects in an image. So rather than just classifying an image as this image has a cat in it, it'll return bounding boxes of where that object is in the image. And to do that, it's using a technique called transfer learning, which utilizes a model that's already been trained on a similar classification task using millions and millions of images.
Right.
And then what I do as a developer using the Object Detection API is I take the checkpoints of the second to last layer of that model that's been trained on millions of images, and then I update it with my own data so that I don't need to start from scratch. So I didn't have time to label millions of images of Taylor Swift.
Though I'm sure you wouldn't have minded, right?
I wouldn't have minded.
Going through all those pictures, yeah.
So I just needed to use a smaller set of training data to update the final layer of that model.
It's fantastic that you can kind of stand on the shoulder of giants, all the work and all the training that's already been done on these models.
That's one of the great things about transfer learning.
Yeah. So was the training kind of quicker as a result because you didn't have to go through as many images?
Much faster. So instead of taking maybe days, it took just a couple hours.
Fantastic. Awesome. And then so actually doing the work then, right? I guess you would have had to somehow get the images and do any pre-processing required to have the TensorFlow Object Detection API kind of consume those images, whatever formatting you needed to do, and then actually run the training.
So the Object Detection API requires your images be in what's called a TF record format.
TF record, okay.
And to get them in that format, I converted my images to what's called the Pascal VOC format, which is just one format you can choose from. It stands for Visual Object Classification.
Okay.
And what that is that's an XML file. So I take all my images and I generate this XML file, which gives me details on the bounding box of where the object is.
So that's what's in the XML file. It's just kind of coordinates here of the boxes themselves.
So it has the XY coordinates of where my object is in the image, and then it just has the label associated with that bounding box. In this case, I just have one label, Taylor Swift.
Only need one.
Only need one.
Awesome. So then, let's see, we have our data, it's labeled, and I guess now there's only one thing to do, hit the training.
Yeah, so training is next.
So with all these kind of steps, can you just outline kind of how they all connect together?
So I drew the bounding boxes around my images, got them into the Pascal format.
Right.
And then once they're in that format, I wrote a script to convert them to a TF record, which I can then use to feed into my model.
Gotcha. Okay, so all of these kind of steps, now they're all connected. We've gone from the raw image to a, well, not just a label image, but specifically TF record, so it's even formatted correctly. So now we're ready for our training, I guess, right? And so in this case, we're going to do our training on ML Engine, it looks like, based on your blog post here.
Yep.
How was that process, and kind of what did you have to do to make that work?
So it was similar to the process I used for running the training locally. The main difference being I needed to put all of my data in Google Cloud Storage and tell ML Engine where to find it. So the first thing I needed to get in Google Cloud Storage was the model checkpoints from the pre-trained model I was using. I used a model called MobileNets, which is optimized for mobile, obviously. So I put those checkpoints in my cloud storage bucket. I also needed my training and test TF record files, which I talked about before, how I generated those. And then I have a config file, which tells the Object Detection API where my training and test data is located. And it supports ML Engine and Google Cloud Storage.
Great. And so that whole thing kind of comes together and I guess just takes care of all the training for you then? Awesome. And how long did that training kind of take? Everyone wants to know, if the training takes a long time or a little time, and how long you had to wait for that.
I think it took about 30 minutes.
30 minutes. Okay, that's
not too long.
Yeah. Given what you're getting out of it, that's quite nice. So once training's done, what do you have kind of as your result? What do you have in your hands?
So you have a model checkpoint, which is just a binary file, similar to the pre-trained model checkpoint that I used to start training. This is now going to be the final model checkpoint, which has been updated with all of my training data.
Gotcha. Okay. So that's very nice. And then you, I guess, would now kind of flip it over the wall to the serving side.
So to serve it, I can use a gcloud command with ML Engine to deploy my model. I just need to point it at where those checkpoint files are of my final trained model.
Okay.
And then in just a couple of minutes, I have my model available for serving, and I can use that to generate predictions against the model.
Fantastic. And so I guess this kind of brings us to the next phase of this project. We've gone from our data, we've pre-processed it, we've done the training, and we have this kind of API that can serve up predictions at scale.
Exactly.
So now we're ready to call that endpoint. And what did you end up kind of architecting here? It looks like you have a couple of pieces.
It's using a couple of different Firebase SDKs. So the client is a Swift app. It's an iOS app that's written in Swift, and it's a pretty thin client. So all the client is doing is it's uploading an image to Firebase storage.
Oh, okay. So that's what that arrow is for.
Gotcha. Exactly. And then we're using the Firebase SDK for Cloud Functions. So a function is triggered whenever an image is uploaded to a specific storage bucket.
Ah, very handy.
So the function is written in Node.js, And that function does a bunch of different things. It downloads the image, and then it resizes it. It base64 encodes it, which will prepare it for the ML Engine online prediction request.
Okay.
So I make that prediction request. If the confidence that I get back is greater than 70%, that's just a threshold that I've chosen, I'm going to draw a box around that image.
Okay, so that, and the box drawing is, it looks like it's happening here in your Node code.
Yeah, I'm doing that using ImageMagick, which is available in Google Cloud Functions.
Oh, perfect.
Mm-hmm.
Yeah, very convenient. And so then once the box is drawn, do you, how do you get that information back to your client then?
So once the box is drawn, I write the image to Firebase Storage, and then I also write some metadata on the image to Cloud Firestore, which is a database.
Mm-hmm.
So I'm writing the confidence of the detection along with the path of the image in Firebase Storage.
Gotcha. So that's why you kind of have these two write operations coming from your Cloud Function.
Exactly. And the reason I'm using Firestore is in my client, I can create a listener on the ID of that image path. And so then I get updates whenever new data has been added to that collection in Firestore.
Oh, perfect.
So I don't have to keep pulling that to see if the detection is finished. So right when it's finished, my client will get an update, and then I can then download the new image with the box around it,
right,
along with the confidence detection score.
So that's really neat that you've managed to use the kind of architecture to signal in both directions, right? You upload to cloud storage, and that triggers the Cloud Function. So on upload, something happens, and it happens right away. And then coming back, once the response from ML Engine is received, you're using Firestore to basically give that real-time update to hit your phone right away as well. So you kind of keep that loop tight, even though you've managed to do this while all the while maintaining this kind of thin client. That's really nice, that the way you've kind of leveraged the existing technology. You didn't have to write anything to make sure everything happened nice and quick, but async.
Yeah, one thing that's great about Firebase is I get those real-time updates whenever new data comes in that path.
Fantastic. So I guess zooming out a little bit, you've built the mobile app that builds a custom machine learning model. You've collected your data, you annotated it, you're training, and you're serving at scale to your mobile client. What did you find to be kind of the most interesting part of all of this?
I would say definitely learning to tie together all these different tools. So there's a lot of different things I use to build the app from end to end, from TensorFlow object detection to Cloud Machine Learning Engine, which had a couple of different components. It had training, serving, and online prediction. And then the client piece using some Swift SDKs and Firebase SDK for Cloud Functions.
Yeah, I mean, just along the way, you're hitting Python, Node, Swift, JavaScript. Oh, JavaScript is there.
Even a little bit of Bash with the G-Cloud commands.
Right. That's right. Outstanding. And so on the whole, what did you find to be most challenging kind of out of all of this?
The most challenging part was getting all of the data into Google Cloud Storage, because there's a lot of different pieces that needed to be there, from the pre-trained model checkpoints, the TF records, and then that config file, which tells object detection where to find these different pieces.
Right. And these are all coming kind of from different places, and just getting it all arranged. Yeah, I could see how that could be challenging. And I guess, was there some fun parts as well, hopefully, along the way?
It was pretty fun to build. One thing that was kind of funny was, as I labeled all the images myself. So there was a day
Hard
where
work.
I know, it was a tough job. So there was a day where I had pictures of Taylor Swift on my computer. People walked by, were probably wondering what I was doing.
Yeah, just perusing photos all day. Right?
Exactly, generating those bounding boxes. And the most fun thing was definitely the final result of seeing on the iOS app the prediction with the bounding box come back in real time.
Definitely, yeah. That's a long journey.
It was.
Awesome. And as I understand, you've actually open sourced your code on GitHub.
Yeah, it's all available on my personal GitHub repo, and there's instructions in the README if you want to build the same model yourself.
Awesome. So that's so great that our audience can go out and build their own model. And I want to thank you so much. Really appreciate you coming in today and chatting in the studio.
Thanks for having me. Great to be here.
Yeah, it's been great. Thanks for watching this episode of Cloud AI Adventures. Today, we saw how to go from raw data to training to a mobile client. You can use Sarah's GitHub repo to not only recreate this, but extend it with your own data, a different model, or a different client app. For more details, we've included links to all the resources we discussed in the description, so check it out. And if you've enjoyed this episode, please like it and subscribe to get more episodes right when they come out.
everybody. Thanks so much for coming to our talk about integrating Firebase into your existing backend services. I know that it's kind of dinner time right now, so we can really tell that you are the die-hard Firebase fans, and we're really glad to have you. I'm Jen Person. I'm a developer advocate for Firebase.
I'm Hiranya. I'm a tech lead for the Firebase SDK team.
So to talk about integrating Firebase into your existing backend infrastructure, we are going to be examining a made-up company called Fireflix. And we are currently collaborating with the team at Fireflix, which is an up-and-coming movie streaming service. And the Fireflix team is on a mission. They want to develop an app that enables their users to browse their growing collection of streaming movies. So that way, when you're on the go, on your phone, or even on your computer, you can check out everything that they have to offer, save movies you want to check out later, write reviews of movies you've already seen, and maybe even get some recommendations. Now, right now, they're off to a really great start. They have a few key core features to their app, but don't take my word for it. Go ahead and check it out yourself. So I have a short link as well as a long link. I won't be ashamed, I won't be embarrassed if you take out your phone or your computer right now and check it out. I will say that there will be something that'll pop up asking you if you want to get notifications. If you choose to do that, we promise we won't spam you. We're just going to send you a couple that you'll see as part of our talk. So I'll give everyone just another second to get to the link. This is your opportunity to be on your computer during the talk, and it's perfectly OK. OK, so let's check out what it looks like for everybody. If you want to go over to the demo machine, then everyone can see it even if you don't pull it up on your device. And you'll see it looks something like this. We have this extended list of movies. You can load more of them. You can add it to your library. Let's say you want to keep track of everything you've seen, or maybe keep track of something that you want to see in the future. You can also add a review for a movie. Give that one 4 stars. You can give it a rating, and then you can give it a review. The text will be just for you, so you can remember what you thought of it. But the rating will actually be factored into the overall rating that people have made for the movie. There we go. Submitted my review. You also see you can filter by genre if you're really interested in a specific genre. Check out your saved movies and your reviews, and this tab called My Recommended, which we'll get into later. And yes, feel free to keep playing with it. I especially recommend that you start making some ratings. Rate some movies that you really love, and also rate some that you are not a fan of. The more ratings you do, the more interesting one of our later demos will be. So again, it's OK to play with your phone during our talk. But at this time, let's switch back to the slides while everyone's playing. Here we go. So yeah, we have some great features, but we want to make the app even more sophisticated and engaging. We want to be able to add a moderator role so that some members of the Fireflix team are able to add new movies as they're added to their growing collection. We wouldn't want just anybody to be able to add movies, right? So it has to be designated admin users. We want to be able to implement secure backend services for managing all sorts of different app resources. And we want to leverage the company's existing search infrastructure to index app data and enable full-text search. That way, people can quickly look for the movies they want. You wouldn't want to just have to scroll through, I think, 10,000 movies. Yeah, you got to be able to search for the one you're looking for. Make movie recommendations to really pull users in, give them something that fits their specific interests, and keep users engaged by sending them notifications. And these are the examples that we're going to be examining today using the admin SDK. So we're faced with a challenge that many app developers are familiar with. Successful apps do not exist in isolated silos. They look a lot more like this. They often collaborate and share data with various backend systems, cloud services, machine learning models, administrative tools, and legacy systems. So rather than just your little app in the middle, there's a lot more going on. Fortunately, Firebase has got you covered. And to tell you more about it, I'm going to pass over to Hiranya.
Yes. As Jen mentioned, developers working on sophisticated apps with complex requirements often need to access Firebase services and Firebase app data from their own backend systems. This is especially true in the case of enterprise app developers who typically have various in-house systems that should become part of their mobile and web ecosystems. But it could also apply to small-time app developers who may require some form of backend integration as their apps grow and evolve over time. This is where the admin SDKs come into the picture. Admin SDKs enable you to develop backend software that interact with Firebase. And you can deploy them in an environment or in a server that you own or manage, like the servers sitting in your company's data center. Or if you are running some services in a cloud platform like Google App Engine or Google Compute Engine, you can use admin SDKs to integrate those services with Firebase as well. Also, since the serverless architecture has now gone mainstream, you can use admin SDKs to implement various serverless event triggers and deploy them in an environment like Google Cloud Functions. To make a long story short, admin SDKs are available in 4 server-side programming languages. And you can deploy them in any environment that you control as the app developer and supports one of these languages. Now, let's move past the intros and really dig into some serious admin SDK use cases, starting with the custom permissions model that Fireflix is trying to implement. Fireflix wants to define 2 classes of users, moderators and regular users. Moderators will have the authorization to perform certain privileged operations in the app, like adding new movies to the database. Typically, when a user signs into a Firebase app, Firebase Auth issues that user something called an ID token. This ID token is then sent along with all the service requests made by the app. Firebase backend services authorize the incoming requests if they are accompanied with a valid ID token. The ID token itself is a short-lived JSON Web Token, or a JWT, with some metadata about the user encoded into it. They are signed by Firebase Auth, so they cannot be spoofed. So one simple way to implement roles in a Firebase app is by instructing Firebase Auth to add the roles information to the same ID token issued at signing. For example, since there are only 2 roles in the Fireflix app, we can tell Firebase Auth to add a special moderator claim to the ID tokens issued to Fireflix moderators. In the backend service, we can check if the claim is present on the JWT to see if it came from an actual moderator. Now the question is, how do we tell Firebase Auth to add additional claims to the ID tokens issued at user login? It's actually fairly straightforward with the admin SDK. Let's go to the demo machine and look at an example. This is part of a Go web service that we have implemented to grant the moderator role to selected users. We start by calling the firebase.newApp function, which initializes the admin SDK. This function takes a context and an optional set of Firebase settings, like the authorization credentials and project ID. But in this case, as you can see, we are not specifying any of those settings. We simply pass nil and let the SDK automatically discover all the required settings from the environment. Once we have initialized an app, we can use it to obtain an auth client or a Firestore client, which we would use later. We store these client instances inside a struct called admin client that we have defined in our code. Now, we can go ahead and implement the function to grant the moderator role to a selected user. The grant moderator role function takes the email address of the target user as the input. We pass it to the getUserByEmail function of the SDK. This function returns a record of all the metadata that Firebase Auth currently knows about the target user. We can inspect the user record to see if it already contains the moderator claim. If so, then there's nothing else to do, so we can return early. Otherwise, we go ahead and call the setCustomUserClaims function provided by the admin SDK. This function takes the unique user ID of the target user, which we can also get from the same user record that we retrieved earlier. and a map of claims to be added to that user account. Once this function has been invoked on a user, whenever that user logs into Firebase, Firebase Auth will automatically issue an ID token containing those custom claims. Now, another thing to note here is, in this example, we are using the Go programming language to connect all the claims and user IDs together. But it doesn't necessarily have to be that way. If you have your own external user store, like an LDAP server or an Active Directory server, you can actually query that server from this code and use the results to decide how to set claims on different accounts. Let's go back to the slides. Having implemented the grant moderator role functionality, suppose we decided to expose it as a web service so that client applications can call it remotely and manage permissions. But in that case, we'd want to make sure that only authorized users are able to call it. We certainly don't want anybody to be able to just call into that service and potentially gain moderator privileges. That would be bad. Let's say, for the sake of argument, that only an existing Fireflix moderator should be able to grant another user moderator privileges. Same can be true for other critical backend functionality like adding movies. Only moderators should be able to do it. So how do we go about implementing a backend service that requires authorization from the caller? To meet this requirement, we need to guard all the critical backend functionality in our web service with a permission check. Let's go back to our demo machine and look at an example. So we implement a new function called checkAuth. This function takes the ID token of a Firebase user as the input. This implies that whoever calls this service will have to send the ID token along with the requests. Once we have received an ID token, we can pass it to the verify ID token function of the admin SDK. This function performs a series of checks. It checks whether the ID token is a well-formed JWT, that it is not expired, and it is correctly signed by the Firebase Auth. If any of these checks fail, then you get an error, which we can return back to the user. Otherwise, you get a decoded representation of the ID token. We can inspect this decoded representation to see if it contains the moderator claim. If not, we return an error. Otherwise, we signal success by returning nil. Once you have this checkAuth function, it's just a matter of wiring your web service so that all the incoming requests first go through the checkAuth function before hitting any of the other critical backend functionality like add movie function or the grant moderator role function that we looked at earlier. Now, we already have this web service up and running in the cloud as a Google App Engine service. Let's go to the demo machine, send it a few requests, and see how this permission check works out in practice. I'm using this Chrome extension called Advanced REST Client to send requests. And this is the URL that we have mapped to the grant moderator role function that we looked at earlier. This endpoint accepts a small JSON payload containing the email address of the target user. It extracts the ID token of the caller from a specific HTTP header, but first, let's just send it some request without any HTTP header and see what happens. So you can see you get a 401 unauthorized error response, and with error detail indicating ID token not specified. If you go back to our code, you can see ID token not specified is the error returned by our checkAuth function when there's no ID token available on the requests. Let's also send it some ID token value and see what happens. So X Firebase ID token is the custom HTTP header that our backend service expects. And I'm going to call it with this random JWT value. It's not a valid ID token. In this case, too, we still get a 401 unauthorized response, but it's a different error detail this time. This time, it says failed to verify token signature. This is an error returned by the verify ID token function. So you can see how the checkAuth function and the admin SDK prevents different types of unauthorized access attempts to our backend service. But now let's go ahead and try to call it as a valid moderator with the correct permissions. Now, I've already set up my personal Fireflix account as a moderator. As a result, if I log in to my app, I'm showing an additional moderator tab that you probably don't see on your screens. And on the other window, you can see that's Jen's account. You can see that she doesn't have moderator privileges at the moment either. The controls in this tab allow me to call the same backend service on App Engine, and these controls will take care of sending my ID token along with the request. The permission-driven UI experience you see here is implemented by parsing the ID token on the client apps and checking the result to see if it contains the moderator claim. It's not a very secure check, since it's client-side. There are ways to get around it. But that's OK, because as we saw earlier, our server implementation has its own and more robust permission checks. So I'm going to use the Add New Moderator form to give Jen moderator privileges in the system. Maybe I would ask Jen to type in her email. And this time I get a successful response.
OK.
And hopefully Jen can log back in and show off her newfound privileges.
I promise not to get drunk on power and add too many movies. But if you see some silly movies, later on it was probably me. Yeah, so now you can see that the moderator tab shows up for me as well. And I have the ability to add new movies as well as additional moderators. Can we go back to the slides? So let's talk a little bit about what those custom claims can do for you. We have looked at 2 examples of where you can use those custom claims. In your server environment, where we had the check-auth function, and also on the client, where we had sort of just a silly check that hides something from developers. Of course, again, if you're a developer, you can probably expose that tab, but you won't be able to make any sort of requests with it because you are not authorized to do so. The other place that we did not examine using these custom claims is within the Firebase server. So if you are using Cloud Firestore or the real-time database or cloud storage, you can use custom claims in the rules that you set up in your database to manage what people can read and write. Just this very simple example that we have here of how you could set up your Firestore rules. If I have a movies collection, I can allow anyone who is authenticated to read. Because we have anonymous auth set up, that would be anyone who has accessed the app. But in terms of writing, we could set it up so that if the auth token has the moderator claim set to true, then they're able to write. Otherwise, it will return an error saying that you do not have permission. So let's take a look at another example of integrating Firebase into your existing services. Currently, Fireflix has an Elasticsearch cluster that they're using. They use it to power a number of their search applications that they have. And they want to use the same infrastructure to index Firebase app data and to support new keyword search so you can look for movies by genre or by title. In an enterprise customer, this is a very common use case. You already have some things in place. It may be a little difficult to sell someone on starting something new. You can, in fact, incorporate Firebase into this. So currently, the app needs to update search indexes just when movies are added. But in order to prepare for future changes to the app, tracking all of these can be very difficult. If only there were a way to trigger some backend code in response to Firestore update events. Of course, Cloud Functions for Firebase, which I'm a huge fan of. So you can deploy some Node.js code to automatically trigger when certain events occur in your Firebase project. And these could be something auth-related, like adding a new user. These could be writes to the real-time database or Cloud Firestore. There are a lot of different options, but the ones we're going to examine today are going to be based around Cloud Firestore because that's what we're using in our app. So the first example we're going to look at is updating those indexes. What we want to do is whenever a new movie is added by one of us to the Cloud Firestore, we want to trigger those indexes to update. So we have a proxy that talks to Elasticsearch using its internal IP address, because they're both on the same private network. In this case, we're talking about App Engine. The proxy is exposed using custom HTTP auth. Now, this is just one way that you can do it. There are certainly other options, but we'll show you what this looks like. So let's dive into that Firestore trigger on our computer. Put this down. So you'll see here that we import the admin SDK as well as functions. And when we initialize the app, we can do so calling just admin.initializeApp. Just like we did with our Go code, normally we may need to pass in some credentials, but because we are in a Google-managed environment, we can just call initializeApp, and Google does all the work for us, which I just love. Let's take a look at our update search index function. This is the format that you'll see for most cloud functions. We have functions dot some feature, in this case, Firestore, and then the specific document on which we want it to trigger. So we have a collection of movies, and inside that are a series of documents, each with a unique ID. The brackets indicate a wildcard. Whatever that movie ID is, we want this to trigger. This triggers on write, and on write means that anytime something is changed or written to that location, this is going to fire. When you first write, when you make a change, or when you delete, then this code is going to run. Our parameters are change in context, and we have a couple examples of how you use each of these. For instance, if we want to get the data after a change occurred, we do that using change.after.data. And that'll pull all of the information inside of the document. In this case, all the details about the movie, its title, its genres, et cetera. We also have previous, which if there's any previous data, say it's not the first time writing to that location, we can get the data that way. Otherwise, we're just going to have an empty object. We do a couple of quick checks before we go updating our indexes, because there are some situations where we won't need to do that. So for instance, if the type of data is undefined, as in the movie was just deleted, we're going to return a promise that is resolved with true. And we return out of this to clean up the function. It doesn't need to do any more work. Otherwise, we check if the title or the genres are changed. If they weren't, again, we don't need to update the indexes, because currently, that is what we are indexing. If it passes those checks, then we have our secure proxy service. This is our endpoint. And we have some options. This is where that context parameter comes into place to access that movie ID. So we want to get that unique key. This is how you can access it from within the function. And we get the title and the genres. Then we have this really sophisticated looking authorization header, which says functions.config.fireflix.token, which sounds like something maybe sophisticated from within Firebase, but it is just an environment variable that you can set up from the command line interface. So when you deploy your functions and all of this code is available, there may be some information that you don't want to deploy with it. Like if you have some sort of password, or in this case, some key that we want to hide, you can hide it inside of your environmental variable, setting it up in the command line interface. So you can call it whatever you want. We called it fireflix.token. You can call it banana, and you can give it whatever value you want, and then access it from within functions.config. What the token is doesn't really matter. We just made it something arbitrary that the server-side code knows to check for. Finally, we make a post request, and we update that index. If there's an error, we catch it. And then we always end by returning to clean up the function and tear it down. Can we go back to the slides? Thank you. So similarly, on the client side, when a search is made, it also goes through this Elasticsearch proxy, and then the results are streamed back to the client. So either way, we're keeping that information secure and not accessible to the client. We can also use Cloud Functions to automate other tasks. I have so many ideas about what we can do, but I just looked at a couple. So for instance, we can notify users about new movie additions to try to engage them with what we're adding to our collection. And we can use Cloud Functions to automatically keep movie statistics up to date as ratings trickle in. This is a very common use case where you might have some number that you need to keep track of, a total or an average. Cloud Functions are great for that because they can trigger and run automatically anytime something else is written to the database. So let's go back to the demo machine to look at those examples. Can we check out the demo? Cool. So we have the sendNewRelease function, which looks very similar in format. Again, it's functions.firestore.document. it's going to be triggered anytime a movie of any ID is added to that movie's collection. But in this case, we're looking at an onCreate trigger, which means it's only going to run the first time something is written to that location. We don't need to notify people if we change something in the spelling of the title or add a different genre. We just want it to run the first time and notify users of our new movies. The parameters are slightly different as a result. We don't have change, we have snapshot because there is no change that occurred, there's just the original write. But again, we use .data to access what was inside of the write. We use the admin SDK to access Firebase Cloud Messaging. And Firebase Cloud Messaging enables you to send data messages and notifications to iOS, Android, and web. So this way we can send our messages to our users no matter what platform they're on. We have just a simple topic and notification. We get the title of the movie from that snapshot data. And then we use the admin SDK to send that message. Then we just log that we sent it. And we finally have one more example we're going to look at, which is updating those ratings. This time, instead of the movies collection, we're looking at the ratings collection. And inside of that, we have a movie ID. Under the movie ID, we have just a whole bunch of user IDs of anyone who's written a rating of that movie. And then the value is the rating that they gave that movie. So boom, whenever a new rating occurs, we want this to run. So again, we have an onWrite trigger. It's going to get the change after. We get all of the keys, so we can basically count up how many reviews there were, so we can get an average. Then we compute the average rating and use the admin SDK to write it back to the database. Notice we use doc.set to set those key value pairs, but we also use merge true. That means instead of replacing the entire document, we're just merging together, adding these keys rather than replacing everything else that's there. We don't want to replace the ratings that are already there. So that's a lot of code to look at. It'd be kind of cool to look at an example. So let's add a new movie. Let's see. This, I think, is going to be a bestseller, incorporating Firebase into your existing back-end infrastructure. Let's say this is an action, a little bit of comedy, drama. Submit my movie. And it says it was successfully added. So now, I should be able to search for it. Notice the function was triggered to index my movie, so I'm immediately able to search for it. And I can add a review of it. I know this is under your account. I hope you don't mind. I think it's 5 stars. Will watch again. Review is submitted. And then, if I take a look, my average has been updated. And if you give it a rating as well, you'll see that the average will be updated. You might not see it on other movies because we have so many ratings for other movies that are in there. But again, just a reminder to put in some ratings because you're going to really want them for this next part. So let's head back to the slides.
Fireflix would also like to unleash some of the machine learning tools developed by their data science team on the ratings collected by the app. Specifically, they have built a collaborative filtering model in TensorFlow to make movie recommendations. This model needs to be trained periodically, and Fireflix would like to do so using their own servers. The movie recommendations that result from this computation should be fed back to the app so the users can see the results on the screen. The TensorFlow code is written in Python. So in this case, we can use the Python admin SDK to directly interface Firebase with the machine learning code. We can use the Firestore API available in admin SDK to query the app database. The movie ratings fetched in this manner can be directly fed to TensorFlow or any other Python number crunching tool that you want to use. In the same way, the results of the machine learning tools can be written back to Cloud Firestore. But we also have the option of directly notifying the Fireflix client apps through FCM if machine learning tools uncover something noteworthy that the user should be notified about. Now, this machine learning code is going to take a minute to run. So let's go to the demo machine and get that going first. And let's go into a quick code walk.
Yeah, we're doing a lot of live demos. We're very brave.
Yeah. Hopefully, it will be running in the background. And let's go to the code. The Python code is organized into 3 high-level steps. In step 1, we initialize the admin SDK as usual, and then query the app database for all the information we need. As you can see, again, we are not passing any arguments to initialize app call. If executed in an environment like Google Compute Engine, this will seek out application default credentials and automatically connect to the Firebase resources associated with your GCP project. But you can, as you can see, you can get this style of parameterless initialization to work on your own machines too. Currently, this is running on my machine. And you do that by installing a service account to the environment. To query the app database, we import the Firestore module through Firebase admin. If we go to the very top. Yes, we import the Firestore module through Firebase admin and then use it to get hold of a Firestore client instance. And then we can use it to retrieve all the ratings accumulated in the ratings collection. There are around 100,000 ratings in our demo dataset, plus whatever the ratings that you were nice enough to give during this session. So this query can take around 4 to 5 seconds, depending on the network speed. In addition to the ratings collection, we also query the users collection, where we have stored your FCM registration tokens. We will use those tokens later to send notifications. Next up, in step 2, we run this data through the TensorFlow model and make movie recommendations. Now, I'm not going to go into the details of that, but if anybody's curious, just come find me after the talk or tomorrow at the Ask Firebase sandbox, and I'll be happy to walk you through as to how we did that. It's a singular value decomposition model for if you're really curious. Finally, in step 3, we write the movie recommendations made by TensorFlow back to the app database. Now, this can potentially result in a large number of small Firestore writes. So to make it a little more efficient on the wire, we split our recommendations to chunks and then use the batch write support available in Firestore API to write 500 recommendations at a time. Having written all the recommendations to the database, we also use the FCM support or the messaging support available in the admin SDK to send notifications targeting individual users. Now, hopefully, the script has run to its completion by now. Let's see how did that go. Yep. And that means we have some recommendations to look at. Let's go to the dual screen setup.
Let's see both of our screens so we can check out both our
So here's a notification that I've received. We have found some new movies you might like. That's the Python code notifying my app instance. And let's see if
it just takes a minute. There it goes.
So let's see if there's anything that I would actually want to see here.
Ooh,
Avatar
Ice
is a good
Princess.
one.
I definitely want to see that.
Con Air is a
Just
good
kidding.
one.
I already have.
So looks like I'm getting a lot of sci-fi action type movies. And I actually do watch quite a lot of sci-fi and action type movies.
Yeah.
But
I'm getting a mix of some indie movies, some sci-fi, and also some animated. So yeah, it's pretty accurate.
yeah. Hopefully you get something more sensible too. It works a little better when there are more recommendations from the same user, so not just the high ratings, but low ratings as well. Let's go back to the slides. We've actually made a lot of progress at this point, so it's a good time to take a step back and look at what we managed to deliver. We started with a fairly straightforward app that supports user authentication and some database interactions. We overlaid a custom permission model on this app using Firebase Auth. We used the Go admin SDK to set custom claims on selected user accounts, which we can validate using the admin SDK itself or Firebase security rules. We leveraged this permission model to implement a backend service that only Fireflix moderators can access. Moderators were able to use this service to add new movies to the database. Then we used Cloud Functions for Firebase to integrate the in-house search platform at Fireflix with the app database to support full-text search within the app. We use Cloud Functions for Firebase, which tracks the updates that go into to the app database and then indexes them in the private Elasticsearch server. We expose the Elasticsearch server to Cloud Functions as well as the client apps through a proxy service that we deployed in App Engine. We also use the Node.js admin SDK to keep the movie statistics up to date and send notifications about new movies. And finally, we use the Python admin SDK to harvest all the ratings collected in the app database, run it through a TensorFlow model, and feed the resulting recommendations back through Cloud Firestore and Cloud Messaging. So this is what the final enhanced Fireflix app architecture looks like. So you can see it's no longer a simple, straightforward app, but it has become a fairly sophisticated system where several in-house services and several Firebase services work side by side. And chances are, if you're an enterprise app developer, your architecture already kind of looks like this. If you're a small-time app developer, don't feel left out. As your apps grow over time, they might begin to look a little bit like this. And as far as the admin SDK capabilities go, we just scratched the surface today.
That's right. There are a lot of other examples of ways that you can integrate the admin SDK into your apps. So here are some good examples that we did not touch on today. GDPR is a big topic right now. You need to be able to delete your users' data. And the admin SDK gives you the opportunity to delete instance IDs and other private data from your users when needed. You're also able to use it to access Google Cloud Storage, the Firebase real-time database. You can manage your FCM topic subscriptions, so you can add people to specific topics that they want to get notifications about and remove them, et cetera. You can also use it for custom auth. So again, if you have some sort of system that is required to be used at your company, you can still integrate Firebase using that custom authentication in the admin SDK. You can also use it for bulk user import and export when you need to make those big changes. If you have a traditional web app that's using web session management with cookies, you can do that. Yeah, there's so much more. I mean, more than we can even fit on this slide.
Yeah. And also, incidentally, admin SDKs is one area where we'd like to welcome your input and help as well. Firebase admin SDKs are developed in open source, so feel free to file bug reports, suggest new features, and just point out areas of improvement in general. And also, if you have the time, please keep those pull requests rolling in as well. We love working with our community and are always looking to get more developers involved in the process. Isn't that right, Jen?
Absolutely. Yeah, we love to hear from you. So in addition to rating movies, you can also rate our session on the Google.io schedule. And also, you can reach out to us and tell us what you think. We will be in the Ask Firebase area of the tent tomorrow morning, probably all morning. But
for a good chunk of the day.
Yeah. And then you can contact Hiranya on GitHub. You can see his handle here. And you can find me on Twitter at @ThatGenPerson. Thanks so much for coming. It's great to have you.
Thank you.
Thank you for joining this session. Brand ambassadors will assist with directing you through the designated exits.
It was another great day at Google I/O 2018, and it isn't over yet. Come back at 8:30 p.m. Pacific Time for our live concert with Justice. They'll be debuting their new song, Stop. Tomorrow, we'll be back here at 8:30 a.m. with more sessions, sandbox demos, and special guest interviews. See you back here in 1.5 hours. We'll leave now with Justice's new music video, Stop.